Hello and welcome to Unity 3D Game Development course. In this course you will learn the 3D dynamic parkour system. You will learn how to deduct the obstacle height, and then according to the deducted obstacle height we will perform the parkour action. For every obstacle there will be different parkour action. You will learn how to climb up large buildings in a Unity 3D game. You will learn how to deduct the climb ledge, jump to ledge, move on the ledges in any direction the user wants. You will learn all these things. You will also learn the shimmy actions for a parkour, as you can see, while moving on a ledge, turn around to another ledge and then come back to the previous state, similarly as you can see now, and then how to jump up from the hanging state on the wall and then jump up back to the ledge, as you can see that. So you will learn this step by step, all these professional techniques for a professional parkour system, as you have already seen in games like Assassin's Creed and other parkour games. You will learn how to deduct a ledge and jumping from a ledge. You will also learn how to drop to hanging state, as you can see that. Then the ledge, on the deducted ledges we are moving and we are jumping. So you will also learn how to jump from one ledge to another ledge. As you can see, we are jumping between ledges and we are moving, that is, from a large building we come down towards the floor, as you can see that. So you will learn all these professional parkour system in this course. You will learn this amazing parkour techniques, parkour actions and parkour climbing system, that is a complete professional parkour system you will learn and develop in this course. So I hope you will love this course and you will learn many new skills in this course. So yeah, see you guys in the course.
Hello guys and welcome back. So as you know that from this video onwards we will start working on our new course, which is a parkour game. But before starting it, let me tell you that many of you guys were asking that why we are not uploading new courses. It is because I was sick. I was suffering from TB and I was on my bed for the past 6 months. But now as I am feeling a little bit fine and I have energy to record videos, so here we are. Okay, so as you know that before starting any project, make sure that you have downloaded Unity Okay, after that just simply open up Unity Hub. Okay, here it is. This is my Unity Hub, and right here make sure that you click on projects and then click on this new project button, and right here select this all templates, and inside the all templates we have this 3D URP right here. So select 3D URP. If you didn't download this universal render pipeline, then make sure that you download it first. Okay, right here it will be showing the download template or the download button. Okay, and then right here let's name our project as Parkour game. Okay, and I will save my project inside this Unity project R. By R I mean recording. Okay, so I will select that folder. You can select your own location, and after selecting the location let's click on this create project, and now in a few minutes or seconds our project will be up and running. As you can see, now it is installing all of the packages inside our Parkour game project. So as you can see, now our project is up and running right here. Okay, we have the URP empty template open right here. We actually don't want that. We will be creating our own scene and our own environment, but we're gonna do that in the next video. In this video we have created our project inside Unity. Okay, and now from the next video we will be uploading all the assets which are required for our environment and for this game. Hello guys, and welcome back. So as you know that in the previous video we have created our project in Unity by the name of Parkour game. Now in this video we will be uploading all of the assets which are required for our Parkour game. So first of all we will start from the environment. Okay, for the environment we will be using this Steam City. Let me tell you guys that I don't own this asset, okay, or any of these two assets. These are from the Unity asset store. As you can see right here, this is the Steam City right here. Okay, so you can get the Steam City from Unity asset store. Anyways, right here, now what will I do is I will simply extract this zip file. Okay, so I will right click, then click on this WinRAR. Okay, you can download WinRAR from online website of the WinRAR. Okay, then simply click on this extract to Steam City. After that it will give you this folder by the name of Steam City, and if you open that up, in here you will find this Unity package file by the name of Steam City as well. So what we're gonna do is simply double click on it, and it will automatically open up our Parkour game project. It will take a minute or two, and after that you will see this import Unity package window. Okay, and as you can see in here we have all of the environment assets and the scenes. Okay, so let's click on import, and now importing will take few seconds or maybe a minute. Let's see. Right here as you can see the Steam City has been added inside our project. It took few minutes, I think 5 or 6 minutes, and after that it is now imported. So now what we're gonna do is we will open up this demo scene, and in here let's open up this city scene. And as you can see right here everything is in pink color. Okay, this is due to the materials are not compatible with our URP pipeline. Okay, or you can say universal render pipeline. So what we're gonna do is now we will change the materials, or you can say convert the materials to URP. So for that what we will do is we will get back to the Steam City folder, and we will open up this materials folder. As you can see all of the materials are pink, so let's click the Control A button and it will select all of them. Let's hold down the Control button and left click on this folder to deselect it. Okay, and make sure that you select the other materials. Then right click, and actually we don't need to right click, we need to click on this edit. Okay, then click on this rendering, make sure that all of the materials are selected as you can see, and then click on this material, and inside the material we have this option. Okay, convert selected built-in materials to URP. Click on proceed, and now as you can see all of them are now converting to URP. So let's just wait for it. Now, as you can see, all of the materials are converted. As you can see, these three are not converted, but this is for the Steam Gull. Okay, we are not using that Gull character, so we don't need to change that. Okay, now as you can see, most of the materials are updated to URP, but not all of them. So now let's get back to the Steam City folder. Actually, we need to go inside this materials and then this swappable, because now we need to convert all of that as well. So select all of them and then convert to URP. And now as you can see all of them are converted. And right here as you can see these materials are not. So let's select this object. This is the material. Let's right click and then click on select material. Okay, it will open up the materials folder, which is inside Steam City, Mesh, and then materials. Let's convert all of them as well. Click on proceed, and now as you can see all of the materials are converted. But now we have other problem, which is this one. As you can see the leaves are not looking perfectly fine. So what we're gonna do is simply select these, okay, this fall leaves. Then we need to, I think, open this up. Okay, right here we have this four leaves material. Let's click on select material. Okay, this is the material, and now right here what we will do is we will change the surface type to transparent. Now as you can see it is now looking fine, as you can see. Okay, just simply change the surface type to transparent from opaque, and now we're gonna do the same with this one as well. Okay, so let's select this object which is by the name of IVY. Open this up, so select the first LOD, then click on select material. This is the material. Let's change this to transparent as well. Okay, and you can smooth this as well, and also if you want to remove this white thing, as you can see it is showing some white type of thing like a glass. So for that just simply uncheck that box. Okay, so it will be removed as you can see. Okay, you can do the same with this one as well. As you can see there is this white square type of thing. Okay, so select it, the fall leaves, and click on select material, click on it, and then uncheck that as you can see. Okay, now let's check these trees. Okay, we need to set these trees as well. So select the trees, make sure that you open it up and select the park material. I think the park material is okay, but we need to select this leaves material, and let's change this to transparent, and let's uncheck that, and now as you can see the tree is looking perfectly fine. Okay, so in this way you can change all of the materials and you can set the leaves and other things as well. Okay, so now I think our environment is all set up, as you can see. Now the next thing which we will do is to add the character and the parkour obstacles. Okay, as you saw in the introductory video, at this location we have some obstacles. Okay, so we will be importing that obstacles and also our character, but we will do that in the next video. So in the previous video we have set up our environment. Okay, we have set up all of the materials, as you can see. Okay, so since our environment is ready, now we need to go ahead and add the obstacles. For the obstacle, we are using this free pack from Unity Asset Store, which is by the name of Barrier and Traffic Cone Pack. This is a free asset, as you can see, so you can just go ahead and open up your asset store and then add this to your assets, and then just simply open this in your Unity project. Okay, now let me tell you one thing more, that I will be providing this barrier pack as well. Okay, for example, if the package is removed from the asset store or anything happens, okay, so that's why I will be providing this barrier pack as well. So you can just go ahead and download the barrier pack from the course. Okay, the link will be available. Now once you download this pack, okay, it will be inside a zip file, so we need to unzip this. So if we click on WinRAR, then we will click on this extract to barrier pack. As you can see, here is the folder. Inside the folder, let's double click on this barrier pack. It will open up our parkour game. As you can see, it is now preparing the package, and now here is the package. Now what we will do is we will just simply click on import, and after importing it will be showing these two errors, which is the type of or namespace name Cinemachine could not be found. Okay, because our project is missing the Cinemachine package. Okay, I was thinking to import this package later in our videos when we will be working on our player, but as you can see that it is showing this error. So what we will do is simply import this package in this video. So just simply click on package manager, okay, then click on right here, okay, packages, and change this from in project to Unity registry, and right here search for Cine Machine. As you can see, here it is. Just simply click on install, and it will be installed inside our project. Okay, now it is giving these other errors inside all of these files. So now what we're gonna do is just simply click on this barrier pack, okay, and these are the scripts. So what we will do is simply delete this scripts folder. Click on delete. Okay, now it is showing all of these errors. So these errors are actually inside our Steam City post-processing folder, then editor, then monitors, etc, etc. So let's open up our Steam City editor. Actually it is inside the post-processing, as you can see right here, post-processing, then editor, then models, and inside we have all of these scripts. So what we will do, we will simply delete these models folder. Okay, as you can see, all of the errors are gone. Now we have just these fours. So now post-processing, editors, monitors. Okay, so post-processing editor, now we have this monitors folder, so let's delete that as well. Okay, so now we have post-processing editor. Now right here we have error in this script, which is by the name of post-processing inspector. Okay, this is the script. Let's delete this as well. It is now showing errors in I think all of these scripts, so let's just delete all of them as well. Okay, there are few bugs, or you can say errors, in this package, but as you can see, all of them are now fixed. Okay, if we click on the player, this is the player created by the asset developer. Okay, so since all of the errors are now gone and we have the barrier pack right here, okay, let's click on this prefabs, and in here we have all of the things right here set up, as you can see. Okay, so now let's add some few barriers right here, as you can see. And since the player is set up already by default, let's play the game and let's take a walk in our environment. As you can see, okay, we can walk. Okay, this is the barriers. Okay, and this is our environment, as you can see. You can also sprint by holding down the shift button. Okay, as you can see. Let's stop the game, and with the barrier pack added, okay, now we are set up for the environment. But now what we're gonna do is we will just simply select all of this thing, okay, and to select this city scene, then right click, then click on this create empty parent. Okay, and as you can see, now everything is inside this game object, and let's rename this game object to environment. That is it. So now inside the environment we have all of this environment. So with these things set up, now let's end this video right here. Okay, so in the previous video we have set up our environment and we have added the barrels and crates package as well. Now in this video what we will do is we will add our player. So for the player character, I am using this adventure character, which is available free on the Unity Asset Store. So you can just go ahead and search for adventure character, and then you can import this inside your Parkour game. Okay, but also I will be providing the zip file for that character as well. So if you want, you can download that zip file, and after downloading it, just simply extract this to adventure character folder. And once it is extracted or unzip, it will give you this folder, and inside this folder we have this adventure character Unity package file. So let's double click on it. It will open up the import Unity package window by default like this. Okay, and then just simply click on import. And now as you can see, it is showing importing package. Right here, as you can see, adventure character, this is the package. Okay, so if we open up the prefab right here, if we select the main one, okay, this is the main one character, but actually we will be using this main 4, okay, this one with all of the clothes, but feel free to use any of the character from this. Okay, I will be using this main 4. So before adding this character, what we will do is we will delete this player. Okay, so let me first of all unpack this completely, and then let's just simply delete it. Okay, then let's close the environment, and then right here before creating any game object, let's first of all drag our character right there. Okay, make sure the player feet are on the ground like this. Okay, just simply drag and drop it and the feet will be on the ground. Okay, and as you can see, it is showing main 4. So let me just move the main 4 down, and then let's click on prefab, unpack completely. Then let's rename this to player. Okay, and as you can see, the animator is already attached and also the avatar for this character. Okay, so make sure that all of these things are by default added. Okay, then if we click on our game window, as you can see, it is showing no camera rendering. This is because we deleted the player from here. Okay, and inside that player we have our camera, which is also deleted. So what we will do is we will simply right click right here in the hierarchy and then click on camera. Okay, this is the camera. Let's name this as main camera. Okay, and let's move this at the top. Okay, and as you can see now, this camera is capturing, or you can say rendering, this character. Let's pull the camera backwards so that you can see the character fully like that. Okay, so here is the character. Now our character has been added. Now in the next video, what we will do is we will add our camera controller. Okay, so when we play the game, then we should be able to rotate the camera around the player. So we will do that in the next video. Okay, so now let's go ahead and add our camera. So in the previous video we have added this main camera right here. Okay, now what we will do in this video is we will create a camera which will be able to rotate around the player. Okay, we will create a third person view. So for that purpose we will be using Cinemachine camera. And as you guys know that in the starting videos we have already added the package, okay, the Cinemachine package. So if you didn't add the package or miss that step, then let me tell you again that just simply click on window, find package manager, then make sure that you are in the Unity registry, and then in the Unity registry just simply search for Cinemachine, and it will show the Cinemachine package like this, and just simply install it. As I have already installed it, so it is showing the remove button. Okay, after this what we will do now is to add an actual Cinemachine camera. You can create a camera from here. Okay, from the game object Cinemachine you can create a camera for yourself right from these options, but that will be lengthy and time taking. So what I did is create a third person Cinemachine camera, and I will be providing that third person Cinemachine camera to all of you guys. Okay, so just simply go ahead and download this zip file by the name of Cinemachine cams. Okay, and just simply extract this folder, and then just simply drag and drop this inside your game like this. Okay, just simply drag and drop this inside this assets folder, and as you can see, here is the Cinemachine. Okay, and if you are confused with this option, then just simply select your assets folder, then right click on this show in explorer, and it will open up this. Then just simply open up the assets. Okay, and then minimize this, then just simply cut or copy this from here and paste it inside your assets folder. Okay, you can do that as well. So now since it is inside our project, let me now delete these two from here. If you want, you can delete it as well. Then just simply click on Cinemachine cams, and in here you will find this third person Cinemachine. Okay, what we will do is we will simply drag and drop this inside our hierarchy right there. and then if you selected it will show these options right here. So in the follow and look at, just simply drag and drop the player like that. But if we click on the player, okay, as you can see right here that the player, this player main game object is right here in the middle of the player body, as you can see. So we don't want the third person camera to look at that position. So what we will do is we will open up this player main game object, then right click, and we will create a empty game object in here, and let's name this as look point. Okay, then as you can see the look point is in the player feeds. Let me just drag and drop it right here to the head of the player like that, and then click on third person cinemachine, and now in the look at we will add the look point like that. Okay, then what we will do is we will simply click on the main camera. Okay, and let me minimize that. On in right here on the main camera we will add this component which is by the name of cinemachine brain. If you can't find it, then you can just simply type cinemachine and it will show this cinemachine brain. That is it. And now right here, as you can see, live camera is the third person cinemachine. So now the main camera will follow this third person cinemachine view angle, as you can see. You don't need to change any other values of this third person cinemachine. Okay, you can change the options from here if you want the camera here and there, but I have already set up all of these values. But if you want, you can change them according to your game need. Okay, so once the cinemachine is added, now if we play the game, you will notice now that our camera is working perfectly fine, as you can see. Okay, now after this, the next thing which we need to do is we want the player to move. Okay, so we will be adding some player movement in the upcoming videos. So with our camera added, let's end this video right here. So in this video what we will do is we will create a basic player movement. For now we just have the third person camera and our player character. Okay, so for adding the third person player movement, what we will do is right here in the assets folder we will create a new folder by the name of scripts. Then in here we will create a new folder by the name of player controller, and then inside the player controller we will create a C# script by the name of player script. You can name this player controller if you want, but we already named the folder player controller, so then I'm gonna name the script as player script, or you can name this just player if you want. Then click on the player and just simply drag and drop the script right there at the top. Okay, then just simply double click on the script and it will open up in your text editor. For example, I am using Visual Studio Code, so it is opened in Visual Studio Code. Okay, and right here let's remove the start and update function. Then right here at the top what we will do is we will create a header and we will name this header as player movement. Okay, then right down below we will create a public float by the name of movement speed. Let's make the movement speed as 4. Okay, then after that what we will do is we will create a function by the name of player movement, or you can say a method by the name of player movement, and in here we will create a float by the name of horizontal. and this will be equals to the keyboard input. So we will say input dot get axis, and we want to get the horizontal axis. Okay, after this we will create another float by the name of vertical, and this will be equals to input dot get axis, and we will call the vertical axis from the Unity input system. Okay, and guys, I am sorry for the typing mistake, because as I told you, I was sick for the past 6 months. Okay, so my typing speed is a little bit messed up, but it will get back in form really soon. Okay, now you guys will be thinking that where this horizontal and vertical is coming from. So if we open up Unity, then click on edit, then project settings, then if you click on this input manager, and then in the axis you will find this horizontal and vertical right here, as you can see. So as you can see that the vertical is set onto the down arrow key and up arrow key, and then the S and W. Okay, and the horizontal is set to the left right arrow key and then the A and W key. Okay, so we are just accessing this horizontal and vertical. Okay, so now once we have the input, now after that what we want to do is we want to move the player. So for that we will create a variable by the name of, let's just say, movement input. This will be equals to new. Let's create a vector 3, and now in here for the vector 3 x y z we will pass the horizontal and vertical. So for the x we will pass the horizontal input, then for the y we will simply pass 0, and then for the z we will pass vertical. Okay, then we want this movement to be smooth, so at the end we will say dot normalized. Then after this we want to move the player game object in the direction of the inputs. Okay, for example, if the player presses the WS key, then we want the player game object to move in the forward and backward direction, and then if the player which is playing the game presses the A and D, then we want the player game object to move to the left and right. Okay, so in order to do that we will say transform dot position plus equals to movement speed, and we will multiply that by the, actually we will say movement input. Okay, because first we want to get the input, then when we get the input, for example if the input is in the forward or backward direction or in the left and right, okay, then to that input we want to add the movement speed. Okay, so we will multiply that by the movement speed, and we want the movement to be time dependent, or you can say frame dependent. So at the end we will need to multiply that by time dot delta time. Okay, so this is just a simple script. We created a float which is a movement speed of the player, then right here we get the horizontal and vertical inputs, then we simply normalize that inputs, and then right here we moved the player game object according to the movement input and speed. Okay, and then we multiply that movement by time dot delta time in order to make it time dependent, or you can say frame dependent. Okay, then now at last what we will do is we will create a update method, and in here we will be needing to pass the player movement method right there, okay? So that this player movement is called every second by the update function or method, okay? Now simply save the script and get back to Unity. And now if we click on player, as you can see, we have the movement speed right there. And guys, let me tell you the reason we use this transform.position, because this player script is already attached to the player game object. So that's why we just simply get the position of the player by using the transform.position, as you can see right here. Now let's simply play the game. As you can see, here is the player. Now if we press the forward key, as you can see, the player is moving forward. Don't worry, our player is going inside the stairs because the player don't have any colliders, but we will be adding colliders in the upcoming videos. But now as you can see, the player move forward, backward, and to the left and right, as you can see. Okay, but now if we rotate our camera to the left side and press the forward key or the W key, as you can see, the player is still moving forward. Okay, we actually don't want that. We want the player to move in the direction where the camera is pointing, okay, just like in most of the third person games. Okay, so we will be adding that functionality in the next video. As you know that in the previous video we have added the basic player movement. Now as you can see, the player can move forward, backward, left and right, okay? But now as you know that the player is not facing the left right side. As you can see, when we move to the left, the player just simply drags to the left side. The player is not rotating to the left or right side, or not to the forward and backward, actually the backward, as you can see, okay? So we're gonna fix that before making the player to move in the direction in where the camera is pointing, okay? That will be our next video. So now let's rotate the player to the left, right, forward and backward direction. For that, right here in the script, we will create a float by the name of movement amount, okay? And this movement amount will be equals to mathf.abs absolute, you can say. And right here we will pass the horizontal inputs. Then we will do the same for the vertical as well, but let me make the M capital right there and simply copy this, paste it right here, then change this to vertical. Okay, then right here, as you know that we are moving the player in the movement direction. Now right here we will also now rotate the player in the direction according to the inputs. Okay, so first of all we will create a if condition, and in that we will say if the movement amount is greater than 0, it means that if the player is moving the game player, okay, or you can say the person which is playing the game is pressing the input buttons, okay, then what we will do, we first move the player in that direction. Now we will also rotate the player. So after this, right down below, we will say transform dot rotation, okay, and this will be equals to quaternion dot look rotation, and we will pass the movement input. Okay, so now if the player presses the left movement key, then the game player will look to the left, and if the person which is playing the game presses the right button, then the player will look to the right side, and the same for the forward and backward. Okay, Now before going back to Unity, let me explain once again these two line of code. Right here we are just checking the movement, okay? If the person which is playing the game is pressing any keys or not. Okay, so if the player is pressing any keys, then right here what we did is according to that inputs we are moving and rotating the player. Okay, simple as that. Right here in Unity, if you check, it is showing the error on line 27, which is quaternion does not contain a definition for look rotation. Actually we typed that incorrectly, so let me correct the spelling right here. It is look rotation. Okay, then just save the script, get back to Unity, the error is gone. Okay, here is the player. Let's play the game. Now if we move the player forward, the player is looking forward. Now if we press the S key, as you can see, the player is now facing that side. Now player is facing forward. Now if we press the left key, as you can see, the player is going to the left and then to the right, as you can see. Okay, for now the camera is a little bit chunky, as you can see. Okay, but the player is now facing the forward, backward, left and right side. Now in the next video what we will do is we will rotate the player according to the camera pointing position. Okay, and let me check this thing. Okay, so right here inside the body, if we change this to -4 for example, and then let's just play the game. Okay, so there is the player. Now as you can see, the camera is still doing this thing, but we will fix that in the upcoming videos, so don't worry about that. Now just simply change this to -2 and that's it for this video. So in this video we will rotate, or you can say we will move the player to the direction where the camera is pointing. For example, if the camera is pointing there and we press the W key, then the player should move there. And if we are pointing camera anywhere on the Y axis, okay, then we want the player to move to that position. Okay, we don't want the player to move in the upward direction or inside the ground. We just want the player to move to the left and right rotation of the camera. Okay, just like in many of the third person games. So for that what we will do is right here in the scripts folder we will create another folder by the name of camera controller. Let's open this camera controller, and in here let's create a C# script by the name of main camera controller. Then let's click on the main camera and drag and drop this main camera controller script at the top right there. Okay, then let's just open this up, and right here at the top we will first of all create a reference to our Cinemachine third person camera. So we will say Cinemachine virtual camera, and let's call this vcam. And since we are dealing with Cinemachine cameras, so at the top make sure that you add the Cinemachine library. Okay, then as I told you that we will be only moving the player to the left and right side, or you can say the Y rotation of the camera. Okay, not the X rotation or the Z rotation of the camera. We just need the Y rotation. So what we will do, we will create a float by the name of rotation Y. Okay, then we will create a update method. Okay, and in here we will get the current camera state. Okay, so for that we will create a variable by the name of state, and then we will say vgame dot state. Okay, so right here we are just simply getting the current camera state, and after this I want to extract the rotation quaternion from this state which we created right here. Okay, so first of all let's add a comment so that you guys understand what we are doing in each of the code of line. Okay, so we will create another rotation, I mean a variable by the name of rotation, and this will be equals to state. Okay, this state variable, then we will say final orientation, and this dot final orientation is the built-in code which comes with the Cinemachine library. Okay, so now when we extract the rotation quaternion from the state, after that what we want to do is we want to convert that rotation to Euler angles. Okay, so first of all add a comment which is convert the rotation to Euler angles now. So in order to do that we will create another variable by the name of Euler, and this will be equals to rotation dot Euler angles. Okay, and guys, the reason we are typing all of this code in order to get the rotation y from the camera, this is because we are dealing with Cinemachine cameras. Okay, so it is a bit lengthier to extract the values from the Cinemachine camera. Okay, if it was a normal camera then it was not a big deal. Okay, we already created one parkour game with the simple camera controller which is available both on our YouTube channel and Udemy, so you can also check that out as well. It is basically a session grid game clone. Okay, anyways, so after converting the rotation to Euler angles, now it is time to get the y-axis value from the Euler angles. Okay, so add a comment, and then we will say rotation y will be equals to Euler dot y. Okay, actually the y will be small, and in this way now we have the rotation y from the Cinemachine. Now what we want to do is we want to make that rotation smoother. Okay, so in order to do that we will be needing to round this rotation y value to the nearest integer. Okay, so add a comment which is round the rotation y value to the nearest integer, and now let's actually do it. So we will create another variable by the name of rounded rotation y. It will be equals to mathf dot round to integer, and then we will pass the rotation y value, and that will be simply it. Okay, now we will be needing this rotation y value on our player script. So after the update method, let's create a property. So we will say public quaternion. Let's name this as flat rotation. This will be equals to quaternion dot Euler. For the x pass 0, for the y we will pass rotation y, and for the z we will pass 0. As I told you, we just need the rotation y. Okay, so we get the y rotation, then we create a property, and in the property we pass the rotation y. Now we will get back to the player script, and right here at the top we will simply say public, then main camera controller. Okay, we need a reference to our main camera controller script, so let's name this as MCC or main camera controller. Then right here inside the player movement. After this variable movement input, let's create another variable by the name of movement direction. This will be equals to mcc dot flat rotation. This is our property which we created right here. Okay, flat property. So main camera controller dot flat rotation, we will multiply that by the movement input. Okay, and then inside this if condition where we move, or you can say change the player position, now right here instead of the movement input we will pass the movement direction. Okay, and in the look rotation as well, so let's pass the movement direction right there as well. Okay, so let's save the script, get back to Unity, click on the main camera. Now as you can see right here it needs the virtual camera, so let's drag and drop the third person cine machine. Then let's click on the player, and inside the player drag and drop the main camera right there. Okay, and now let's click on this main camera and let's play the game. You will now notice the rotation Y changing. Okay, as you can see, whenever we rotate the camera, the rotation Y changes. Okay, now if we point the camera right there and press the forward key, as you can see now the player is rotating to the camera direction, as you can see. Okay, as you can see it is working perfectly fine, as you can see. Now the next thing which we need to solve right here is to lock this cursor to the screen. So open up the player script, actually the main camera controller script, and then right here let's add a start method, and in here we will say cursor dot lock state. It will be then equals to cursor lock mode dot locked. That's it. Get back to Unity, save the script, get back to Unity. Okay, and now let's play the game. Now if we press the mouse button, any button, as you can see now the cursor is locked to the screen and the player is moving now perfectly fine, as you can see. Okay, now let's unlock the cursor by pressing the escape button. Let's stop the game and let's end this video right here. Hello guys and welcome back. So now from this video onwards we will start adding animations to our game. So before downloading any animation, make sure that your character which you are using in your game, for example if you are using this character, then go inside the character directory. For example, my character is inside the adventure character, and what we will do is we will simply open up the mesh folder, and this is my character mesh. Then check the rig of it, and as you can see the character rig is humanoid and the avatar definition is set to create from this model. Okay, make sure that you have the exact same settings as my character mesh. Okay, if you are using some other character, make sure that you do this. Okay, so now after doing that, then go ahead and open up any browser and search for miximo.com. Okay, from this website we will download our free animations. So just visit this website, log in, because you will be needing a Adobe account. So you can just simply sign up with your Google account, or you can try other ways to sign up. Okay, so once you do that, then just simply upload your character to this website. If you don't know how to upload your character, okay, I will show you. You can just simply click on this upload character. Okay, and right here now we need to provide the fpx, obj or zip file of our character. So for this what we will do, let me show you. In your character, open up your character mesh. Okay, for example this is my character mesh, and as you can see this is .fpx file. Okay, so what I will do is I will simply click on this show in explorer. So this is the fpx file. What I will do is I will simply drag and drop this inside miximo.com. Okay, so just simply drop it right here, or you can actually click on the select a file and you can go ahead inside the directory and select your fpx file. Okay, so now it will take a moment, so let's just wait for it. As you can see, this is the character. Now I will simply click on next, and our character is, as you can see, has been uploaded. Now click next, and then your character will be uploaded right here, as you can see. Okay, so make sure that you upload your character like this. Now we need to find animations for our character, so I will simply click on animations. Okay, and let's search for animation called idle. Okay, we need a idle animation. As you can see, there are a lot of idle animations, so you can download any of it. Let's click on this one. I think this idle animation is really good, as you can see. So if you want, you can download this idle as well, but in the intro video I have used this idle animation. Okay, so I will just simply stick to my own animation. Okay, so I will select this and then just simply make sure to increase the arm space. So let's just make it 69 or 70. Okay, so the hand is now away from the player body, as you can see. So just simply increase the arm space, then click on download, and make sure to change the format to FBX for Unity and change the skin to without skin, and that will be it. Then just simply click on download button and the animation will be downloaded. Now let's search for another animation, which is walk. Okay, we need to find the walking animation from here. Let's actually search for walking. Okay, so here is all of the walking animations. You can use any of the walk. Okay, but as you can see, all of the other walks are not what we need. Okay, so if we scroll up right here, this animation is suitable for our walking. So select that and simply click on this in place, and let's change the arm space to, let's just say 70, just as we did for our idle. Okay, let's decrease it to 65 maybe. Okay, 65 is a good value for this. So just simply click on download. All of the settings will be the same as the previous one. Then after this, we need a running animation. So let's search for running. Okay, there are many running animations as you can see. Let's select this one. Okay, click on in place. And as you can see, this animation is good. Let's change the player arm space to 60. Let's make it 65. Okay, 65 is a good value for this running animation. So make sure that you check the in place box and make the arm space 65. Then just simply click on download, then FBX for Unity, and this will be without skin. Click download. And guys, I just remembered now that some of you guys commented on our videos, okay, that the running in your previous parkour game is a little bit slow. So if you want the running to be fast, then you can just simply change the overdrive value of this animation. Okay, for example, if you change it to 70, now as you can see the player is running fast. Okay, so if you want some fast running animation, then you can just change the overdrive like that. Okay, but I will stick to 50. Okay, so once all of the three animations are downloaded, you can go ahead and open up Unity, and in the assets folder, let's create another folder by the name of animations, and then inside this animations folder you can add these. Okay, so let's add it up right here. Okay, so these are the three animations. What we will do now is select three of them and click on rig, then change the animation type to humanoid. Okay, and let's change the avatar definition to copy from other avatar, and then click on this, and right here we will select this main mesh avatar. Okay, this is our character avatar. Click apply, and it is now applied. If we click now the first animation, which is the idle, now as you can see we can see our player in here. Okay, let's play the animation. As you can see the player is playing the idle animation. Let's click on the next one. This is the running, and as you can see the player is running. Now let's check this one. Whoops. Okay, so now as you can see the player is walking, and this is the running. Okay, so now select these animations. Okay, let's actually select the first one, click on animation, and let's scroll down. Let me do this. Okay, and what we will do right here is we will click on this loop time, then loop pause, and as you can see all of the loops match, so we will just simply click on begin to pause, begin to pause, and begin to pause. Let's change based upon to original, and right here we will change this to original as well, and then click apply. Now select the next animation, and we will do the same for this one. Okay, loop time, loop pause, begin to pause in these three, and change this to original right here. Click apply, and that's it. Okay, let's drag and drop the player in it, and now as you can see this is the player. Let's play it. As you can see it is working perfectly fine. Okay, now let's select the next one. Right here we will change this to loop time, loop pause, Make sure that you bake them into poses and change this to original, click apply, and that will be it. Okay, so now all of the animations are changed. Hello guys and welcome back. So in the previous video we have downloaded these three animations, the idle, walk and run. So now in this video we will be adding these animations to our player. Okay, so whenever the player walks or run, we will play these animations accordingly. But first let me tell you that the running animation is a little bit slow if we play it. Okay, we don't want the running animation to be this slow. Okay, I have tried adding this animation to my player and it was a bit slow. Okay, so what we will do is I will simply delete this animation, this running animation. Okay, then from the miximo.com website we will download this running animation again. So if we search for running, okay, this was the animation. Okay, let's first of all make this in place. Then what we will do is we will change the arm space to 60, or let's just say 65. Okay, now it is good. But now as you can notice, the player is running a little bit slow. So let's increase the override of this running to, let's just say 65. Okay, 65 is a good value as well, but let's just make this 70, or actually let's leave this as 65. Okay, so make the override 65 so that the player run a little bit faster. Okay, you can change these values and try different values. Okay, and then whatever value you like, then just simply download that animation, but make sure that the format is FBX for Unity and the skin is without skin. Then simply click on download, and once it is downloaded, simply drag and drop this inside the animations folder. Okay, this is the running animation. Click on its rig, change it to humanoid, and then copy from other avatar. Select the main mesh avatar, click apply, click on animation, drag and drop the player in it. Okay, this is now the animation. As you can see, it is a little bit faster now. Okay, let's select loop time, loop pose, select this bake into pose in 3 of them, and then select original in this first and last one, and then simply click apply. Okay, just as we did for our other animation in the previous video. So now the running animation is faster. Okay, this is the walking animation. So now once we have all of the animations, what we're gonna do now is to create a controller for our animator component of the player. Okay, so inside the animations folder, let's click on create animator controller. Let's name this as player controller. Okay, and then simply click on player, drag and drop this controller in there. Then you can simply double click on it. It will open up this animator window. If you don't know where to find this animator window, then click on Windows, then animation, and then animator right there. Okay, so you can double click on it, or you can just select the animator window and click on player, and it will open this up. Okay, let's move this entry any state and exit right there. And as you know that in the previous parkour game we use a blend tree for our animation, so we will be using blend tree in this one as well. So right click, then create state, and inside the create state we have this from new blend tree. Okay, let's name this blend tree as basic movement or basic locomotion. Okay, let's double click on it. As you can see, this is our blend value, which is 0 from 0 to 1. Okay, let's change the name of it to movement value. Okay, this will be our movement value. Now let's click on blend tree, make sure that your blender type is also 1D, and then let's simply click on this plus sign and add a motion field. Let's add 3 motion field like this, since we have 3 animations. Then you can notice the threshold value, which is 0, 0.5 and 1. Okay, so when the threshold value is 0, we want to play the idle. When it is 0.5, we want to play the walk, and when it is 1, we want to play running animation. Okay, so according to that, just simply drag and drop the idle. Okay, make sure that you open this animation up like this, then walk, and then running. So now if we play the animation and let's try to increase the value, if it is 0.5, as you can see, the player is walking, and if it is 1, the player is running. Okay, so when the movement value increases, the player will start walking and then running. Okay, and according to this threshold values. And let me tell you guys that you can also change these threshold values to your own liking. You can just simply uncheck that and change these values. Okay, but since we have just 3 animations, so we will just leave this value as it is. So once you have your basic locomotion blend tree created and the movement value float added, now what we will do, we will now go ahead and apply this animation using script to our player. Okay, and right here make sure that you drag and drop this controller in the animator component. Okay, because many of you guys missed these steps and then you got errors. Okay, so now on the player script, what we will do now is right here at the top, we will create a header by the name of player animator, and then in here we will create a reference to our animator. Okay, so we will say public animator, and let's name this as animator as well. Then right down below, we move our player using this movement amount, and as you can see, this movement amount is mathf.absolute both for the horizontal and vertical movement, and this mathf.absolute returns values which are greater than 0, 0.5 and 1. So since our movement value varies from 0 till 1, okay, then we want that movement amount value to be between from 0 to 1. Okay, so how we will do that? For doing that, Unity provide mathf dot clamp 01. Okay, Unity provide this method. Okay, and now this movement amount value will be from 0 to 1. Okay, since by the name of it, which is clamp 01, so it means 0 from 1. Okay, simple as that. And once the movement amount is between 0 and 1, now let's add this movement amount value to our movement value right here. Okay, so that the animation changes from idle to walk and then to run. So right here we will say animator dot set float, since the movement value in the parameters is float. Okay, if you don't know what I'm talking about this movement value. This is a float. Okay, so I've shown you its name is movement value, and to this movement value we will pass the movement amount. Okay, that's it. Save the script, get back to Unity, click on player. Right here just simply drag and drop this animator. Okay, and let's simply play the game. You will now notice that the player is walking, and when we stop, the player is in idle and the player is walking again. But as you can see, the walking speed is a little bit slow. Okay, we don't want that. So let's increase the movement speed to 5. Okay, so I think 5 is a good value for this movement. As you can see, for now we don't have any gravity or collision for our player, so as you can see our player is walking in the obstacles as well. Don't worry, we will be adding that. Okay, but now the issue is, I think, with the player animation. For example, if we stop, you can notice this drag a bit. Okay, when the player stop, there is some drag. Okay, or you can say some slip. Okay, so how we will fix this issue? For this, open up your player script again. First of all, let's change this movement speed to 5 since we change it in the inspector. Now, in order to fix that issue, right here what we want to do is we want some delay between the animations. Okay, so we will add a delay of 0.2 seconds. Okay, and then at the end we will say time dot delta time in order to make this time dependent, or you can say frame dependent. Okay, so just simply do that. And guys, let me tell you in advance that you can set this value to your own liking. Okay, but for now let's check it on 0.2. Okay, so now if we try to run, as you can see now the slip, or you can say that drag, is a little bit lesser. As you can see, the player now simply stops, as you can see. Okay, so this is really good. As you can see, the player now just simply stops right there. Okay, and if we stop the game, as you can see, the movement speed value changes back to 4, because when we change it to 5 the game was playing, so that value didn't store. So now just simply stop the game and change this to 5, and let's play it again. Okay, so now as you can see, the player is running perfectly fine. Now if we stop, as you can see, the drag is now a little bit lesser. Okay, so as I told you, you can change that value to your own liking, but I think 0.2 is a good value. As you can see now, the player stop perfectly fine. So now with these animations added from the upcoming videos, we will be adding gravity and collision to our player. Hello guys and welcome back. So now in this video we will be adding collision to our player. For adding collision, make sure that your whole environment has colliders. If you are using this environment which I am using, then you don't have to worry about that. But if you are using some other environment, then make sure that in your environment you have added the colliders, okay, to everything. As you can see, this thing has box collider. Okay, and once you have all of the colliders, now let's add a collider to our player as well. So for collision, we will be actually using the character controller component. Since this character component comes with built-in collision, built-in gravity, it also handles steps and slopes. And if you want to read more about character controller and what is it, you can check this Unity documentation about character controller. You can just search for character controller Unity and then just visit this website. You can read all about the character controller right here. Okay, and let me tell you one thing more about the character controller is this works as a engine which drives our player around in the environment. Okay, so once you add the character controller, make sure that the gizmos are on for your scene. Okay, you can just click right here and the gizmos will be on. Then let's change the center Y value to 1. Now as you can see, the character controller is out of the ground. And let's change the radius to 0.2. That's it. The height will be 2 as it is. Okay, and as I told you, this character controller comes with built-in gravity, so let's test that as well. So if you actually move the character controller up there and let's play the game, you will notice that the player will automatically comes down to the ground. As you can see, the character simply comes down to the ground. Okay, as you can notice, the character feet are a little bit above the ground. Okay, as you can see. So in order to fix this, you can just change the skin width to something like 0.3 or something like that, and the player feet will be then inside the, I mean on the ground, as you can see. Okay, or you can actually make the height of the character controller a little bit lesser, but I will suggest to simply decrease the skin width to 0.03. That's it. Okay, now we need to move our player using the character controller. For now, if you notice, the player doesn't walk around. Okay, so we need to make the player walk around using the character controller. Right here on the player script, after this animator header, we will create another header by the name of player collision and gravity. Then in here we will create a reference to the character controller, so we will say public character controller, and let's name this as CC or character controller if you say okay. Then after this, right here inside this if condition, instead of this transform dot position, we will simply say character controller dot move, and we will add the code inside this round brackets, and that will be it. Then get back right here, click on player, drag and drop the character controller in there, okay, in the reference, and simply play the game. And now as you can see, here is the gravity, and now if we try to move, as you can see now, here is the collision. As you can see now, the player collides with the thing in the environment, as you can see. And now if we try to jump from here, as you can see, the player goes down, and as you can see, the player doesn't go up on the stairs. This is because the step offset, so let's increase it to 0.5, and now as you can see, the player goes up and down the steps, as you can see. Okay, let's go down. As you can see, the player is moving down. Let's make the step offset as 0.4, and I think 0.4 is a good value for this. Okay, so now we have collision and gravity added. Okay, make the step offset as 0.4, and let's end this video right here. So in the previous video we have added collision and gravity to our player. So if we play the game, you will notice now that the player will simply goes down to the ground, as you can see, and the player can walk in the environment and can collide with objects. Okay, as you can see now, we have the gravity and collision, everything set up. Okay, now the next thing which we want to do is we want to check that if the player is on the ground, or you can say on the surface or not, because before adding parkour we need to check these things, okay, in order to perform parkour actions. Okay, so let's go ahead and check that if our player is on the ground or not. Let's leave the player in the air for now and select the player. Let's take the player as player and let's click on this layer. Right here we need to add some layer, so the first one will be for the player and the second layer will be surface layer. Okay, then let's just click right here, then click on player. Let's add the player layer, click on yes, change children, then open up the player script. Right here in the player collision and gravity, we will create a float by the name of surface check radius. Okay, and by default this will be equals to 0.3. okay, then after this we will create a public vector 3, and let's name this as surface check offset. Then after this we need a reference to our surface layer mask, so we will say public layer mask, and let's name this as surface layer. Okay, then let's create a bool which will be by the name of on surface. Okay, and by using this on surface bool we will know that if the player is on the surface or not. Okay, so now after this player movement method or function, we will create another one which will be by the name of surface check. Okay, and in here we will now create a sphere in the player feeds, and if that sphere touches the surface or ground, then we will know that yes, the player is on the surface, and we will make this on surface true. Okay, so in order to do that, just simply say on surface, this will be equals to physics dot check sphere. Okay, and where we want to create this sphere, this will be on the player feeds, so we will say transform, then dot transform point. The transform point will be the surface check offset. Okay, and then we want to give a radius to this sphere, so we will call the surface check radius, and then we will pass the layer, I mean the surface layer, so that this sphere knows that if it is touching the surface or not. Okay, so if it is touching the surface, then this on surface will be equals to true. Okay, this is what this whole line means. And then we need to call this method in the update function as well. So right here we will call this, and then after this we will print a message in the console. Okay, and that message will be player on surface plus, let's call the on surface bool right here. So if the player is on surface, it will say player on surface true, and the player, if the player is not on the surface, then it will say player on surface false. Okay, and you guys will be confused that how this surface looks, or how we can edit or see this sphere, actually not surface, sphere. Okay, so in order to see this sphere, we will create gizmos for this. Okay, so for that, Unity provide the on draw gizmos selected method. Okay, so what we will do now in here is we will first of all color this sphere. So for coloring it, we will say gizmos dot color, and this will be equals to color dot, you can color this whatever you want, but I will color this as yellow. And then we want to show the sphere radius and also the sphere location, or you can say transform. So we will say gizmos dot draw sphere. Okay, now we are drawing this sphere. So where we want to draw this sphere, right in the location where we are creating the sphere. Okay, so we will say transform dot transform point. We can actually just copy that line and paste it down below. Okay, so now it will draw a gizmo sphere as well, so that we will be able to see it and edit it. Okay, now let's just simply save this and get back to Unity. And now, as you can see, when the script loaded, you can now see the sphere right here. Okay, this is drawing the gizmos. If we turn off the gizmos, we can't see it, but if we turn it on, we are now seeing this sphere right here. Okay, so if we click on this player right here, this is all of the code for this. You can actually decrease or increase the sphere radius. Okay, I will leave this as 0.3 so that it covers the player whole feeds like that. Okay, and right here we need to provide the surface layer, so we will select the surface layer right there. Okay, and now we will be able to know that if the player is on the surface or not. But before playing the game, we need to provide or add this surface layer to our whole surface right here. Okay, so let's select this area. What's this called? This is by the name of floor. Okay, so let's search for floor. Okay, so as you can see, this is the whole floor. We actually need to select just the floors, as you can see. So select the last one and let's scroll up, hold down the shift button and select the first one, and in this order you will select all of the floor. Okay, and then simply click on that and select surface. Okay, that is it. Now our player will be able to check if the player is on the surface or not, but also if the player is walking on the stairs or on this dirt or on these stairs, we also want to make the on surface true because that is also the surface. So let me actually select this. This is called river down. Okay, so let's search for river. Okay, and let's select the whole river thing and let's make this as surface. Yes, change children. Okay, we actually make this fence pillar as surface as well, but let's just ignore that. Okay, and now what we want to do is, now as you can see the surface layer is added. Now we want to add this surface layer to the stairs as well. So what this called, this is called river ladder, and I think it is added to this river ladder as well. Let's check this one. Okay, we need to add it to this one because the layer is not added. So it is called bridge end. Let's search for bridge end. Okay, let's select all of this bridge end. Okay, so select the surface layer. Yes, change children. Okay, the surface layer is added to that areas as well, but we can just leave this as it is. Now let's check this one. What's this called? This is called street ladder. Okay, here it is, street ladder. Okay, select the street ladders and add the surface layer mask. Okay, that is it. You can add this layer marks to different areas where you want the player to know that the player is on the surface. Okay, you can just add it in all of that areas. Okay, we need to add it on the sidewalks as well. So let's search for sidewalk. Let's select all of these sidewalks, add surface layer, and I think that will be it for now. Okay, we will be adding this surface layer to different areas in the upcoming videos where we require. Okay, so now as you can see the surface layer is added in these areas where we want the player to walk. Okay, so in this way you can add your own as well. And now let's simply check. Okay, everything is set up. Let's play the game. Okay, so now as you can see the surface layer was false when the player was in the air, but now the surface is now true, as you can see. Okay, and when we walk, as you can see, it is still true. And if you try to jump from here, now as you can see it was false and now it is true. Okay, when the player doesn't touch the surface it became false, you will notice it. Okay, if we jump again from that point, you can now notice the player on surface false is 378, but if we now jump, as you can see it is now 469, and now the player is again on surface. Okay, as you can see it is working perfectly fine. Okay, in all of the areas we now know that yes, the player is on the surface, as you can see. So now once we know that yes, the player is on the surface, now let's end this video right here. Hello guys and welcome back. So as you know that in the previous video we have added collisions and gravity. Now in this video we will be manually applying a falling speed and velocity to our player, okay? Because we will be using that values in our parkour system, okay? So that's why we are manually doing it as well. For now we have the gravity and everything works perfectly fine. The player comes down to the ground whenever the player is in the air, okay? But we don't have any values in order to access it. So that's why in this video we will be adding a falling speed and velocity to our player. So in order to do that right here, after this bool, we will create a float by the name of falling speed. Okay, let's make this a serialized field. In order to access this in the inspector, after that, right here in the player movement, we want to remove this cc.move, okay, where we move our player using the input buttons, okay. The reason we are moving this outside this if condition is we want whenever this player movement is called, we want the player to move down to the ground, okay? We don't need to press the buttons in order to call this player movement function and try to move the player down, okay? Or you can say we don't want to apply the falling speed whenever we press the buttons, okay? We want the falling speed to be constant automatically. So we will move it outside, and then in the update method, okay, right here we will add a if condition, and we will say that if the player is on surface, so if the player is on surface, it means that the player is on surface, but if the player is not on surface, then we will apply falling speed and velocity. So first of all, let's apply velocity. So right here we will create a variable by the name of velocity. This will be equals to the movement direction, and let's multiply that by the movement speed, okay, and then we will say velocity dot y, and this will be equals to falling speed, okay, this falling speed float. Then right here we will say that if the player is on the ground, then the falling speed will simply be 0, okay, because the player is already on the ground. But if the player is not on the ground, then we want to apply gravity in order to move the player down to the ground, okay. And that movement from the air to the ground will be called velocity. Because if you check the velocity definition, as you can see, velocity is the directional speed of an object in motion as an indication of its rate of change in position as observed from a particular frame. Okay, so falling speed will be plus equals to physics dot gravity dot y, and then we will multiply that by time dot delta time in order to make this time dependent, okay. And the reason we are doing this is because the update function is called multiple times in a second, okay, but we want to apply the falling speed every second, okay, so that's why we are making it time dependent. Okay, so we have now the falling speed and the velocity, and if you guys thinking where this physics dot gravity comes from, the gravity is already defined in Unity. If I show you in the project settings, then physics, right here you can see the gravity value which is already defined as minus 9.81, okay. And right here you can see this error, which is the name movement direction does not exist in the current context. Right here in the player movement method, as you can see, the movement direction is a private variable in it, okay, so that's why we can't access it right here in the update directly. So let's access it in a different way. Right here, create a serialized field. Okay, and let's say vector 3. Let's name this as move dir. Okay, and then if we scroll down right here after this if condition, or you can just do it after this cc.move, but let's do it right here. So what we will say is movement direction equals to move dir or move direction. Okay, and then we will copy this move direction and paste it right here. So move direction multiply by movement speed. Okay, as you can see, simple as that. Now we have the falling speed, the movement direction. Now if we play the game, you will notice that a falling speed will be applied to our player, and when the player touches the ground it will become 0. So play the game. As you can see, the falling speed was applied and then it become 0. Okay, let me show you guys again. Let's open up the game window and you will notice the falling speed is being applied, and now as you can see the player is on the ground and the falling speed is 0 since the player is already on the ground. Okay, so now we have the falling speed as well, but there is one issue. You guys, I think you guys didn't notice that issue, but I did. If we click on the scene, let's focus up on the player. Okay, I have turned off the gizmos so that I can show you guys that the player feeds after adding the velocity and falling speed. As you can see, it is a little bit in the air. Okay, it doesn't seems like right here on the game, but on the scene we can see it. So I think in order to fix this, you can actually make the skin width to 2, for example. Let's walk the player. Okay, now let's check it again. As you can see, it is now on the ground. Okay, so you can just simply decrease the skin width and the player will just simply touching the ground. I mean the player feet will touch the ground. And if that doesn't work for you, you can also decrease the height of the character controller, and then you will be good to go. Okay, so now let's end this video right here. Okay, so now in this video we will be creating our environment checker script in order to check for the obstacles in our environment in order to perform parkour. So for that, on the scripts folder right here, click on it, and then inside the scripts create another folder by the name of parkour, and then inside the parkour we will create a new C# script by the name of environment checker. Make sure that you spell that correctly. After creating it, click on player, and what we will do, we will simply drag and drop the environment checker right there. Now let's open this up. Now after this, let's create a method by the name of check obstacle. Inside this check obstacle, now we will be creating a raycast, but first of all let's create a variable by the name of ray origin, and this will be basically the position of the ray. Okay, so as you know that we want to create a ray on the player feeds, so first of all we will say transform dot position, and then as I told you we want to create that on the player feeds, so we will add the ray offset with the transform position. Okay, then let's create a ray. So for creating it, we will type physics dot raycast. Now this needs some parameters. So the first parameter is the place or origin where we want to create this raycast. Okay, so that will be the ray origin. Then in which direction we want this ray to move, so that will be the forward direction, so we will say transform dot forward. Okay, then we want to store the information of whatever that this ray hits. So right here you can create a raycast hit by the name of hit info, and inside this hit info we will store the information. But in order to keep our code clean, what we will do is we will cut that from here and actually paste it in here. Okay, we will remove the semicolon, and at the start we will simply type out raycast hit info. Okay, and whatever then this raycast hit, it will be stored inside this hit info. Okay, then we want to limit this raycast, so we will add the ray length, because we don't want the length of this ray to be unlimited. Okay, we want to limit it by the ray length. And then what we want this ray to only detect whatever objects that are on the obstacle layer. That's it. So now whatever this raycast hit which is on the obstacle layer, okay, if we detect that obstacle, then what we want this bool, which will be by the name of hit found, to be true. So we will say bool hit info equals to all of this code. Then what we want is we want to create a line in order to visualize this raycast, because we will not be able to see this raycast. Okay, so in order to visualize that, we will say debug dot draw ray. We want to draw a ray from the ray origin. Okay, and then in the forward direction, so we will use this transform dot forward right here, and then we will multiply that by the ray length. Okay, and then we created this bool hit found, so whenever we hit something that is on the obstacle layer, this will be equals to true. Okay, so we will say that if, okay, this means if this hit found is true, then what we will do, we will color this ray as red. So we will say color dot red. Okay, actually this is else, this question mark considered as if. Okay, so if this hit found is true, then the color will be red, else the raycast color will be green. Okay, simple as that. So I hope you understand what this code means. Okay, we are just simply creating array from the player feeds, for which we set up this ray origin and in the forward direction, and then whatever that ray hits will be stored inside this hit info. We limit that ray by the ray length, and then we only want to detect whatever that is on the obstacle layer, and then right here we visualize that ray. Okay, now we will not be calling this function on this environment checker. For this right here in the Parkour script, we will create a C# script by the name of Parkour controller. Make sure that you name this correctly. Okay, Parkour controller script. Okay, let's open this script. And on this script, what we will do is we will create a reference to our environment checker script. So we will say public environment checker. Let's name this as environment checker, but make sure that the E is small. Okay, then right down below, we will create an update method. Let me actually remove this code. Okay, and then inside the update method, what we will do, we will say environment checker dot, we want to call the check obstacle method right here, and that is simply it. Okay, in check obstacle, that's it. Save the script, get back to Unity right here, click on player. As you can see, here is our environment checker. Let's drag and drop the Parkour controller script as well right here. And in the Parkour controller script, drag and drop the environment checker, and on the obstacle layer make sure that you provide the obstacle layer, okay? And on the objects right here make sure that you also apply the obstacle layer and a collider as well, okay? Now let's play the game, and you will not see the raycast. This is because on the game window we didn't turn on the gizmos, so click on this gizmos, and now as you can see there is this green color ray which is showing above the player feeds. Let me show you on the scene right here. If we turn on the gizmos as well, as you can see above the player feeds we are creating a raycast. For now it is green because the raycast didn't deduct any obstacle since we type it in our code right here. As you can see, when nothing is detected it will be green, but if some hit is found then its color will be red, okay? So now let's go ahead in front of any obstacle, and you can now notice the raycast is now in red color because it is detected this obstacle, okay? And if we check this one, as you can see it is red. If we get right here, as you can see it is in red color now, okay? So what this means is we are checking for obstacles in our environment. And now guys, before ending this video, let me tell you one thing more, that for example if we start walking there is a little bit delay, okay? The idle animation stay active for a few seconds, as you can see, okay? There is a little bit drag, and when we stop the player there, the player is also stopping a little bit slow. As you can see, when we start walking the player doesn't walk instantly, as you can see, okay? So in order to fix this, we will select our idle animation. Okay, this is the idle animation. So what we will do, we will click on animator actually, and then if we see everything is set up right here, but there is a problem with our idle animation. So if we click on animations now, right here we want the length of this idle animation to be a little bit shorter. So let's move it to this position. Okay, the start will be 0, the end will be 30. Then simply click apply, and now if we play the game, now if we start walking, as you can see now the player walks instantly, as you can see. Okay, so I think it looks good now. As you can see the player start walking instantly, as you can see. So in this way you can overcome that problem. And now with this done, let's end this video right here. Hello guys, welcome back. So now from this video onwards we will start working on our parkour system. In our parkour system, first of all we will be working on the parkour actions, which are for example climbing up on this obstacle or this one, and also we will be adding the fence jumps, okay, so that the player perform the fence jump right here, or for example on these seats right here, okay, and on these fences right here as well, okay? Or you can add whatever object you want. So for performing parkour, first of all we need the environment checker, and what that environment checker will do is it will search for the obstacles, or you can say the parkour obstacles, on which the player will be able to perform parkour. For example, consider this a fence and this is a box, and imagine that this is inside our environment, just like these fences on this sides, or you can say this one or this box, okay? So consider that the box and fence. So we will create an environment checker using the Unity raycast system, You can read more about Unity Raycast on the Unity documentation, but let me tell you what this raycast is when we cast a ray from some position. For example, in our case, we will be raycasting invisible ray from the player feeds, okay? And if that ray touches with the fence, okay, then we will detect that in front of the player is a fence, and then according to that fence we will perform the parkour action. Or for example, if the player is walking around in the environment, we will be constantly creating a raycast, and if that raycast hits this box, okay, then the player will know that in front of the player is a box, so then we will perform the specific parkour for the box, okay. And as you saw that in our introductory video, we perform different types of parkour actions according to different types of objects, okay. So as I told you, when the raycast hits some objects, we will store data about that object, that yes, in front of the player is a box, this is the height of the box, this is the width of the box. We will store all of that data, and then according to that we will perform a parkour action, okay. It is simple as that. If you read the parameters of the physics raycast, as you can see, the first is the origin. This is the origin from where the raycast will be created. As you can see, the starting point of ray in world coordinates. So the starting point, or you can say the coordinate, will be from the player feeds, and it will be in the forward direction, okay. So in the direction we will apply the forward direction, and then we can add the maximum distance and also the layer mask, okay. And in the layer mask, what we will do is we will apply a obstacle type of layer mask to all of these obstacles on which we want to perform parkour. And then you can read all about the physics raycast right here. So I hope you understand how this environment checker will work. Now, before ending this video, let's go ahead and set up the obstacles, okay. So as you know that we have set up the obstacles right here. So first of all, let's select these chairs, or you can say benches. And what we will do on this benches is, as you can see on this bench, we already have the box collider, okay. So what we will do, we will now right here search for bench. So search for bench. So as you can see, these are all the benches, okay. So what we can do, we can select all of them, and now we will add a layer mask to them. So right here, click on layer, then add layer, and create a layer by the name of obstacle, okay. Then let's select all of them again and add the obstacle layer. That's it. Now the next thing which we want to apply the obstacle layer to is the barrier pack. So let's open up the models. In here you will find all of the models. We actually need the prefabs, okay. So let's go ahead and set them up as well. So let's drag and drop this one right here, okay. Then we need this one as well, so you can add that one as well right there. Let's put this one right here, okay. Let me make this 0, and also what we want to do is select the first one. Let's make the scale of it a little bit smaller, so 0.8, 0.8 and 0.8, okay. Then let's select the second one. Let's add 0.8 to this one as well, okay. Let's actually make the length of it as it is, Okay, now let's do this one. Alright, so we will perform parkour on these three as well. So just select all of them, add the obstacle layer, yes, change children, and drag and drop them inside the environment, okay? And now let's select this box from here. This is the crate. So let's move this crate right there, where we will be performing all of the parkours. Okay, so on this crate, add the obstacle layer. Box collider is already added. You can duplicate this and let's move it somewhere right here and increase the size to 2. Okay, that's it. And now with the obstacle layer added to all of the objects on which we want to perform the parkours, so you can also do the same as well. Okay, and when you add the layer, let's end this video right here. Hello guys and welcome back. So in the previous video we have created the environment checker script in which we can now detect if the raycast hit any object that is on the obstacle layer or not. Now in this video what we will do is we will detect the information about that object. So for example, if we hit this big crate right here, then we will access the information about this crate. Okay, for example, the crate name, the crate position, location, etc, etc. Okay, so let me tell you now how we will do that. First of all, open up your environment checker script. Okay, and right here on the environment checker script, as you can see that we have the code for creating a raycast, but as you know that whatever information stored inside this hit info, we can't access this information outside this check obstacle method. Okay, so what we will do, we will create a struct for this check obstacle in order to access the information stored in it. Okay, so right here we will create a public struct. Okay, and let's name this as obstacle info, and actually we need to create this struct outside the main class. Okay, outside here. Okay, so now what we will do is we will say public bool, let's name this as hit found, and then create a public raycast. So what we're gonna do, we will just simply cut this from here and paste it right here. Okay, so now we have a struct. Okay, what we're gonna do now, instead of this public void, we will say obstacle info. Then inside this method, what we will do, we will create a variable by the name of hit data, and this will be equals to new obstacle info. Okay, now since we have a bool for hit found and we have a raycast for hit info, so we will now remove this bool from here. Okay, which is by the name of hit found, since we have a hit found right here, and now we can access this hit found and the hit information anywhere inside our project. Okay, so now what we will do, we will now say hit data dot hit info. Okay, we can now access this hit info right here, and also on the parkour controller script and whatever script we want. Now in here we will also right here now say hit data dot hit info. Okay, we will now call this raycast hit info right here like this, and in here as well. So let me just copy that, and instead of the hit found we will say hit data dot hit found. Okay, and since this is a struct, so it don't need these round brackets, so make sure that you remove these round brackets. Okay, and one thing more right here, instead of the hit data we type hit info, we should type this boolean name. Okay, hit found. So if this hit found is true, then we will know that yes, there is some obstacle in front of the player. Okay, so make sure that you change that as well, and right here as well. Okay, hit found. So if the hit found is true, then it will be red, and if it is not, then it will be green. Okay, so make sure that you type hit found in these two areas and hit info just right here. Okay, and now we need to return this data. Okay, this hit found and this hit info data, since we have a struct now. So right here we will say return hit data. Okay, make sure that you also return this data, and then click on the Parkour controller script. And now right here inside the update method, we will create a variable by the name of hit data, and this will be equals to environment checker dot check obstacle. Okay, and from right down below we will remove that. We will now add a if condition, and now we will say we if the raycast hit found anything, so we will say hit data dot hit found. Okay, so if we found any object in front of the player, then for now, as you know that we don't have any parkour action. Okay, we don't have any parkour animations as well, and we didn't create any parkour action as I told you. So for now we will just simply show the name of that obstacle, okay, instead of performing parkour. So we will say object founded, and then we will say plus hit data dot hit info dot transform dot name. That's it. So as I told you, in this video we will be gathering information about that object, whatever we hit, or you can say whatever we detect. So you can also you can also show the object transform, for example the position, rotation or scale, but for now we just want to show the object name. Okay, so if we click on player, as you can see the scripts are in its place. Let's play the game. Okay, so the player is on the surface, it's true, but now if we, for example, if we come near this crate, as you can see, it shows object founded, and then it show crate 4, because this crate name is crate 4. If we get in front of this, now it is showing object founded crate. If we get right here, now as you can see, object founded painted barrier. Okay, so now we are deducting objects with the objects information. Okay, we are now gathering information about the objects. Now in the next video, what we will do, we will also now measure the height of the object in order to perform parkour actions. Okay, we will measure this crate height, and according to this height we will perform a parkour action, or you can say according to this height. Okay, so let's end this video right here. In the previous video, as I told you that we will be measuring the height of the obstacle in the upcoming videos. So this is the video now for measuring the height of the obstacle. Okay, and once we have the height of the obstacle, then according to that height we will be performing a parkour action. So as you know that for now we have a raycast for detecting the obstacles. As you can see, when we come close to this obstacle, the red turns red, and it gives us information about that obstacle. Okay, so now what we want to do right here in order to measure the height of this obstacle is from the point where the raycast hits the obstacle, from that point in the upward direction we will be creating another ray, and then by using that ray we will measure the height of this crate, and then we will perform a parkour action. Okay, so let me tell you visually how we will do that. So consider this the crate. Okay, then when our ray detect that in front of the player is a crate, okay, then from this point, okay, this point we will create another ray in the upward direction, which will be our height ray, and then by using this height ray we will detect the height of this obstacle. Okay, so now open up the environment checker script, and right here at the top create a public float by the name of height array length, and this will be equals to 6 by default. Okay, then just as we did for detecting the obstacle, okay, we created a struct in which we have the hit found bool and the raycast hit by the name of hit info, so that we can access these two anywhere. So in the same manner we will be creating a bool for our height. So we will say public bool, let's name this as height hit found, and then we will create a public raycast by the name of height info. Okay, then as I told you, when we detect a obstacle, after that we will be detecting the height of that obstacle. So we will say that if hit data dot hit found, it means that if we found any obstacle that is on the obstacle layer, okay, just as we did right here. Okay, so if we found any hit, then what we want to do, we want to set now the direction of our height ray length, or you can say the origin. So as I told you, the origin of the height ray will be from this point where the obstacle detection ray hits the obstacle. From this point in the upward direction we want to create the height ray. Okay, so for that we will say var, and let's name this as height origin, and this height origin will be equals to hit data dot hit info dot point. Okay, so this hit data dot hit info dot point is this point, and then from this point in the upward direction we want to create a ray. Okay, so let's set up that direction in the upward route. Okay, so we will say vector 3 dot up, okay, plus vector 3 dot up. So this will basically tell the ray to go in the upward direction, and then we want to limit that ray by some height. Okay, so for that, as you know, that we have created this height ray length, so we will pass height ray length so that the ray doesn't go infinity in the upward direction. So now when we have the height origin, now let's actually create a raycast. So for creating a raycast we will say physics dot raycast. Okay, first of all it needs the position from where we want to create the raycast. So as you know that we have already set the position of the height raycast, which is stored inside this height origin. So we will pass this height origin, then we will say vector 3 dot down, because from this down position in the upward direction we want to go, so that's why we use vector 3 dot down. Okay, and then in the out we will store the information, so we will say hit data dot height info. Okay, and then as I told you we will be limiting our ray by the height ray length, so we will pass now the height ray length, and then in the end we will pass the obstacle layer, because we only want to measure the height of the objects that are on the obstacle layer. Now after this we want to visualize this ray so that we understand it more perfectly. Okay, so as you can see that right here we visualize our detection ray. So now we will be using that code for our height ray, but we need to do some changes right here. Instead of the ray origin, now we will pass the height origin, and then instead of the transform dot forward we will use the vector 3 dot down. Okay, and instead of the ray length we will pass the height ray length, and then right here instead of hit data dot hit found we will say hit data dot height hit found. Okay, and as you know that we don't have any code in order to make this height hit found true or false, so right here, just as we did for our obstacle detection ray, now we will do the same for our height ray. So we will say that if the hit data dot height hit found will be true if we found any obstacle that is on the obstacle layer. Okay, so if we found anything, then we will set this height hit found to true. Okay, so now if this hit data dot height hit found is true, then we want the color of this height rate to be blue, or else if we don't find any obstacle, then the color will be, let's just say, green. Okay, it is simple as that. Now we can simply save our code and get back to Unity. If we click on the player, we have the height length right there. Okay, so let's actually play the game, because we will see our height length right here now. So as you can see, for now we just have the obstacle deduction there. So now if this obstacle deduction ray deduct any obstacle, and as you can see, when we deduct, we now have a blue ray in the upward direction from where the obstacle deduction ray hits. As you can see, from this hit point in the upward direction, we now have a height ray length, as you can see. Okay, just as I show you right here, when the obstacle deduction ray hits the obstacle, then from that point in the upward direction we will create a height ray length, and as you can see, we have a height ray length. Okay, so now once we have this height ray length, now we will be able to perform parkour according to the obstacle heights. Okay, but we will do that in the next video. So in the previous video we detect the height of the obstacles. Now in this video we will be performing parkour actions. Okay, so I have created this small box out of this one, so you can actually select this one and duplicate it, and then change the scale XYZ to these values 0.8, 0.5 and 0.8, because we will be performing a different parkour action on this one and then on this big crate as well. Okay, so as you know that for performing parkours we will be needing animations. So first of all, on the miximo.com website, make sure that you uploaded your character. I have shown you guys in the previous videos how to upload character to miximo.com. After that, search for jumping, and then in the fourth line right here you will see this jumping animation. Just simply click on it and your character will start playing this animation. Okay, so what we will do, we will decrease the step height of this animation since our crate height is smaller. So I think the step height 30 is good value for this animation. So now just simply click on download, change this to FBX for Unity and the skin to without skin. Okay, click on download, and once it is downloaded, open up Unity, and inside the animations folder we will be adding this animation. So just simply drag and drop this inside the animations folder like that, then click on jumping. This is the animation. Okay, change the rig to humanoid, avatar definition to copy from other avatar, and in here select the main mesh avatar, click apply, then click on animation. Let's drag and drop the player. As you can see, this is the animation right here. So now what we will do, we will change the rotation based upon to original, and right here the position X and Z, change this to original as well. Click apply, and that is it. So this will be animation for this box. Now let's download a different animation for this box, since the height of this box is a little bit higher than this one. On miximo.com, now let's search for running jump. and select this animation, which is by the name of running jump. So click on it. Okay, let's see the animation right here. Okay, so this is the animation. Now what we want to do is we want to trim this animation. Okay, so from the start we will make the value 22. Okay, and then from the end we will make the value as 70. So now if we play the animation, okay, as you can see our animation will start from this position. So when the player keep hand on the big crate, okay, then this animation will be played like this, and when the player stands up, then after this we will be playing the basic locomotions again. Okay, so make sure that you trim the animation like this, and when you trim it, just simply click on download. The settings will be the same. Click on download. Now let's drag and drop it inside our Unity. So drag and drop it right here. Okay, so this is the running job. Let's click on the rig, change it to humanoid, then copy from other avatar, select the main mesh, click apply, then click on animation, and let's drag and drop the player. So if you notice right here, this is the animation. Okay, scroll down right here. What we will do now is on the rotation we will say bake into pose, change the based upon to original, and right here change based upon to feet, and click on bake into pose, and that's it. Click apply, and now if you see it, as you can see, here is the animation. Now as you can see, the player is not rotating. Okay, now if we click on animator, let's first of all add the jumping animation and then our running jump. Okay, let's change the name of this jumping to jump up, and then this one to high jump up. That's it. Let's make a transition from jump up to basic locomotion, and then from high jump up to basic locomotion as well. Now with our two animations set up, in the next video we will continue creating our parkour actions. Hello guys and welcome back. So now from this video onwards we will start working on our parkour actions. So as you know that in our environment we have these two boxes of different heights. Okay, so now according to the height of these boxes we will be performing these two parkours. We will be adding more parkour actions in the upcoming videos. Okay, so don't worry about that. We don't have just two parkour actions, but for now we have these two things and two animations right here. So we will be performing each of this animation according to the height of the obstacles. So first of all, let's create a script inside the parkour folder. Let's name this as new parkour action. Let's open this in Visual Studio Code right here. Let's remove this start and update method, and this script will not be a mono behavior, it will be a scriptable object. Okay, and then at the top let's create a asset menu. So we will say create asset menu. Okay, and then in the round brackets we will give this menu a name. So we will say menu name equals to. Okay, so first of all we will type parkour menu, and then inside the parkour menu we will be having an option to create new parkour action. Okay, so make sure that you do this, then save the script, get back right here. Okay, so this is our new parkour actions. We created a asset menu in it. So now if we right click right here and click on this create, and now right here you can see the parkour menu, and inside the parkour menu we now have this option which is create new parkour action. So as I told you that we will be having more than two parkour actions, so that's why we created this menu specifically for adding more and more parkour actions according to the needs, okay? Instead of just hard coding and creating a different script for each of the parkour, okay? We now just have a simple parkour menu in which we can create a parkour action like this, okay? So for now we don't have anything inside our new parkour action, so let me actually delete this, and inside the new parkour action script what we will do, we will create a serialize field, and this will be of type string. Let's name this as animation name. Then after this we will create two more serialize field. The first one will be of type float by the name of minimum height, okay, and then the next one will be of type float as well, and this will be maximum height, okay. So now if we get back right here inside the scripts folder, let's create a new folder by the name of parkour actions, okay, and now inside this parkour actions let's create a new parkour action, okay, and let's name this as jump up, okay. And now if you see the jump up right here, it needs a animation name, the minimum height and the maximum height. So if we click on this animator right here, we have a animation which is by the name of jump up as well. So guys, don't confuse in these two. This is the parkour action name and this is the animation name, okay. So right here let's type this jump up name right there, and we can set the minimum and maximum height for this jump up parkour action. So then when we play our game and then whatever object that is on the obstacle layer matches this minimum and maximum height, then the player will automatically perform the jump up animation on that, or you can say the jump up parkour action, okay. So this is the main reason why we created this parkour action menu. Okay, so now I will tell you how to set up this minimum and maximum height. So if we click on our player, then open up this character controller right here, our step offset is 0.4. So make sure that the minimum value right here is 0.5 now, and the maximum should be, let's just say, 0.9. So now whatever object matches this height value, the player will perform parkour on that obstacle, okay. For now we don't have any code for performing the parkour, okay. We will be adding that code, but for now I am explaining to you how our parkour actions will work, okay. So we have created a parkour action for our jump up animation. Now let's create a new parkour action for our high jump up. So we will also name this as same, so high jump up. You can name this whatever you want, but then make sure that the animation name you type it exactly like this, okay. So we will say high jump up, okay. And for the high jump up, which is this one, now the maximum, I mean the minimum value should be higher than this one, this maximum value of the jump up. So right here we will say minimum height should be 1 and maximum should be, let's just say, 1.5, okay. So now whatever object in our environment matches this minimum and maximum height, then we will play the high jump up, okay. So now these are the parkour actions which is set up. Now what we want to do is to type a code for these parkour actions so that the player can perform it in the game. So now in the next video we will be performing parkours, okay. Let's end this video right here. Hello guys and welcome back. So in the previous video we have created these two parkour actions Now in this video we will be performing these parkour actions according to the minimum and maximum height. So for that, open up the new parkour action script and write down below we will create a method in which we will check for the minimum and maximum height of the obstacle. Okay, so we will say public bool, let's name this as check if available, and this method will need two parameters. So the first one will be obstacle info by the name of hit info, and then the transform of the player. So we will say transform and let's name this as player. That's it. Then add curly brackets, and in here we will create a float by the name of check height, and now we will check for the obstacle height. So how we will check that? We will simply minus the point y position by the player y position. For example, where the obstacle layer touches the the obstacle ray touches the obstacle. Okay, so from this position, okay, we will minus the y position of the player, and then in this way we will get the height. Okay, so let me tell you how we will do that. We will say hit info dot height info, okay, then dot point dot y, and this will be equals to, we will minus it, not equals to, so minus player dot position dot y. Okay, so in this way we will get the height. Then we will say that if the check height is less than minimum height, or if the check height is greater than maximum height, then what we will do, we will return false, else we will return true. Okay, so now we are checking for the height. Now what we want to do is we want to play parkour actions that according to this height. Okay, but first of all we need to make this animation name public in order to access this anywhere. Okay, because we will be needing this animation name on our parkour controller script in order to play the animations. Okay, so let's make a property for this. So we will say public string animation name, and this will be equals to animation name. Okay, so make sure that you type this like this. Okay, animation name, right here the a will be capital, and then it will be equals to this string animation name. That is it. Now if we click on our parkour controller script, okay, right here, instead of now debugging that object found, now we will perform parkour when we found any object, or you can say obstacle. But first of all, at the top we need to create a boolean by the name of player in action. Okay, and then we need a reference to our animator, so we will say public animator. Let's name this as animator as well, and then right down below let's create a header first of all by the name of parkour action area, and in here we will create a list, and that list will be of type new parkour action. Okay, just like our script name, because that will be of that type. And let's name this as new parkour action, but make sure that the n right here is small, okay, or else it will give you an error. Then as you know that we will be performing parkour on our shift key. Okay, so what we need to do right here is add a if condition, and we will say input dot get button, and the button name is jump. Okay, then we will say and if the player is not in action. I will be telling you what this means, but let me first of all do this thing right here. Okay, now, so what this means, okay, it means that when we press the jump button, we also want to make sure that the player is not in action. It means that the player is not performing any other parkour, or the player is not doing anything. Okay, in that case we will then perform parkour. Now in here, as you know, that when we found any obstacle on which we can perform parkour, we type this message object founded, but now we don't want this. Now we want to perform a real parkour action. Okay, but first save the script. Okay, and get back to Unity, and then if you click on your player, you will find the animator reference right there at the animator reference, and then right here we have this list, okay, which we created right here. Okay, and inside this list we will be adding our two parkour actions. So we have these two parkour actions right here. If we actually lock that and then select these two parkour actions and then simply drag and drop it in there, and as you can see, both of them are added. Make sure that the jump up is at the top. Now let's unlock the inspector, click on player. So now as you can see in the list, we have these two parkour actions. Okay, and in the starting of this video we now have a code for checking the height. Okay, so now what we want to do is, according to the height, we will be picking the animation from this parkour action and then performing that parkour action. Okay, so for checking inside this list for the parkour actions, we need a for each loop. So we will say for each. Now for each action in the new parkour action collection. Okay, so new parkour action. In here we now want to check for the parkour action, so we will say if action dot check if available. Okay, this is this method check if available, and as you know that this check if available needs the hit info and the player transform. So for the hit info we will pass the hit data, and this hit data is coming from the environment checker. Okay, so now we pass the hit data in which our object information is stored, and then we want to pass the player transform. So for that we will just simply type transform, since our parkour controller script is stored on our player game object. Okay, so now when we pass these two things, now right here we want to perform parkour action. So for performing parkour action, after this update method, let's create a enumerator method by the name of perform parkour action. Okay, and this perform parkour action will require a new parkour action which will be by the name of action. Okay, we actually name this as action. This new parkour action is the type and this is the name. Okay, so this is actually a property of this perform parkour action. Okay, and the reason we did this is, as I told you, we will be having many parkour actions. Okay, so instead of hard coding and typing each of the parkour action name and the animation name again and again, we just created a parameter right here which is of type new parkour action, and As you know that on our new parkour action we have the animation name, the minimum height and maximum height already set up. Okay, so as I told you, we don't have to type the animation name and all the information about it again and again, okay, because that will make our code lengthy and hard to understand. Okay, so as I told you, in this method we will be performing parkour actions. So before performing the parkour action, we will make the player in action as true, because yes, the player is now in action performing a parkour. And then what we want to do is we will call the animator right here. We will say animator dot crossfade. Okay, and in here we will pass the animation name, that which animation we want to play. So we will just simply say action dot animation name, and then we will pass 0.2. Okay, this will be a delay in our animation, and then after that we will say yield return null. Okay, so now as I told you that we don't want our code to be lengthy. Okay, so now what this action dot animation name will do, it will play that animation according to the maximum and minimum height. Okay, for example, let me show you. If the player is in front of this, okay, then we will measure the height of this obstacle, and then according to this height, as you know that we have these parkour actions on which we have the minimum height and maximum height. So if this minimum height and maximum height matches this box height, then we will perform this jump up. Okay, and then if the minimum height and maximum height get equals to this, okay, then we will play a different type of parkour on this object. So that is the reason we did all of this. Okay, now as you know that right here on the animator, when the game will be playing, then the player will be inside this basic locomotions. Okay, so when the player is inside the basic locomotion and we want to perform the parkour action, then as you know that there is no link back to our base layer. Okay, so we want to create a link to our base layer in order to perform this jump up and high jump up, because in our basic locomotion we don't have the jump up and high jump up. It's right here on our base layer. So in order to get back to our base layer, we will create a variable by the name of animation state, and this will be equals to animator dot get next animator state info. Okay, and right here we will pass 0 since our animations are on the base layer, and as you know the base layer is our first layer. We don't have any layer which comes before the base layer, so that's why we use 0, because in programming our numbers start from 0 1 2 3. Okay, like that. So we will pass 0 right here, and if your animations are in some other layer, then you can pass a number according to that layer. Okay, for example, if our animation were inside this basic locomotion, then we will have to pass 1, but it is on the base layer, so we will simply pass 0. Okay, so this will basically play the animation. Now we also want to make sure that if the animation name which is inside our parkour action doesn't match the animation name right here, okay, then we want to debug a message in which we will say that the animation name is incorrect, because right now we don't have any option for that. So we will say that if the animation name dot is name, okay, if the animation name is not correct, okay, that what this sign means. Okay, it means if not. Okay, so if that is the case, then we will say debug dot log and we want to say that animation name is incorrect. You can type whatever message you want, but I will just leave this as it is. Now at the end, we want to wait for the whole parkour animation to finish, okay? So for that, we will say yield return new, wait for seconds, and right here we will say animation state dot length, make the L right here small, and then after this we will set the player in action to false, because when the animation finishes and the parkour action finishes, now the player is not in any action, so we will set that to false. Now before testing this out, let's call this perform parkour action method in here. So as you know, it is of type enumerator, so in order to call enumerator type function, we need to type start coroutine, and then in here we will say perform parkour action, and as you know it needs action, so we will pass action in there, then semicolon at the end, and then we want to break the loop, because when we find any action, okay, and then we perform that action, then we want to break the loop, okay, because we don't want to check for other parkour animations then. So make sure that you break the for loop like this. Now before saving the script right here, change this from animation name to animation state actually, okay? And then in the state we will check for the animation name, okay? And if that is incorrect, then we will print this message. Now if we save the script, get back to Unity, click on player, make sure that you added these two parkour actions and you added the animator right there, okay? Everything is set up. Let's click on scene and let's play the game. So if we press the shift button, as you can see, I mean the space button, as you can see, we can now only see the raycast in the green color, as you can see, because we set that in our code that whenever we press the jump button, then we only want to perform the parkour. And as you can see now in front of us, we don't have any object on which we want to perform the parkour, so it is green. But now if we get in front of this and press the shift button, as you can see it is red, but we are not able to perform the parkour action, and this is due to the jump up minimum height and maximum height. So let's make this as 0.1 and 0.5, okay, and let's click on this jump up and let's change this from 0.5 to 1, okay, and these values might be different for you guys, so you can just change these values according to your own game, okay, because these values must be equals to the object heights, okay. So now if we press the button, as you can see now the player can perform the parkour action, okay. If we test it out again, as you can see the player is performing the parkour, and now if we try it on this one, as you can see the player is performing the parkour action. But if you notice, the player is not getting on top of this obstacle. This is because the player has the character controller, because if you notice right here, the character controller is stopping the player to go on top of the obstacle, because the character controller doesn't move up. As you can see, the character controller stays the same, only the player body perform the parkour action, as you can see, okay. So we actually don't want this. So in the next video we will fix this issue, but now as you know that our parkour actions are working perfectly fine. And guys, let me tell you that you can add even more parkour actions. Just simply create a new parkour action and download an animation for that parkour action. Okay, then drag and drop it right here, give it a name, type that name right here, add the minimum maximum height, and that will be it. Okay, then you will be able to perform that parkour as well, and you will not be needing to type any code for that because we already have all the code set up right here. Okay, we just now need to add a parkour action right here, and it will be played automatically according to the height values. And as I told you in the videos at the start that I am sick, so actually now I am getting headaches, so I will just end this video right here, and then we will continue our work from the upcoming videos. Hello guys, and welcome back. So in the previous video, as I have told you that in this video we will be solving the issue with our parkour action. So for example, if we perform the parkour action on this box, as you can see, the player moves down to the ground. Okay, the character controller of the player is preventing the player to go on top of the obstacle. So we need to type a code in order to fix this. Okay, we will be disabling our character controller when we are performing parkour. So for that, just simply open up your player script, and right here in the player movement we will create a bool by the name of player control. Okay, then after this, if we scroll down, after this on draw gizmo selected, right down below we will create another method by the name of set control, and this set control will have a parameter which will be of type bool. Let's name this as has control. Okay, then in here we will say this dot has control will be equals to the player control. So what this means that we will be changing this player control bool according to the has control. Now right down below we will say CC or character controller. Okay, we have a reference right here to the character controller. So this character controller dot enabled will be equals to has control. So if the has control is true, then the character controller will be enabled, or you can say true, and if the has control is false, then the character controller will be disabled. Okay, then after this we will create a if condition, and we will say that if the has control is not true, then what we want to do, we want to make the movement value 0. Let me show you. This movement value will be 0 when the player is performing any parkour action, and the reason we are making that 0 is when the player is performing any parkour action, then of course the player is not moving, so we want this value to be 0. Okay, so we will say animator dot set float, and its name is movement value, set it to 0, and then after this we will say required rotation, and this will be equals to transform dot rotation. That is it. Now if we open up our parkour controller script, right here at the top, first of all we need a reference to our player script. Okay, so we will say public player script. Let's name this as player script as well. And now what we want to do right here is when the player is performing any parkour, then we will set this control to true. Actually, when the player is performing any parkour, then we will be setting it to false. So as I told you that when the player is performing any parkour, then the set control will be false because we will not be giving the player any control. And if when the player is done performing the parkour, then we will set the set control to true. Okay, so now that's why we created a reference to our player script, since the set control is on the player script. Then right down below in the perform parkour action, When the player is in action, or you can say when performing parkour, then we want the set control to be false. So we will say player script dot set control. Let's pass false, okay, to this parameter, and then when the player is done performing the parkour, then we will set the control to true. Okay, that is it. Now if we get back to the player script, right here at the top, by default we will make the player control to true, because when we play the game the player should have control. Okay, because when the game is start, the player will have control since the player is not performing any parkour action. Okay, so make sure that you do that. Then simply scroll down right here in the update method. At the top we will say if the player doesn't have any control, so we will say if the player control is false, okay, then we will simply say return, so that no, or this code is not executed. Okay, but we just want the player movement to be executed, so we will move this at the top right here. Now after this, one changes now we want to make in our set control method is, instead of the hash control telling the player control to be true or false, now we will make the player control to tell the hash control if it is true or not. Okay, so make sure that you do that change. Now if we get back to Unity right here on the player game object, make sure that you provide the player script in the parkour controller script reference. Okay, and then after that let's go ahead and play the game. Now right here, if we try to perform parkour on this object, as you can see the player go on top of the object, but the player then just simply falls inside the obstacle, as you can see. And if we try to perform parkour on this one, as you can see, the parkour action is a little bit messed up. So what we want to do now right here is, first of all, stop the game, then click on animation, and let's select the running jump animation. And right here as you can see, for the position Y we make this back into pose, so remove this checkbox. Okay, and click apply, and then let's go ahead and play the game. And now if we walk towards the obstacle, now let's try to perform the parkour action. Now as you can see the player is jumping on top of the obstacle. Okay, so let's do it again. As you can see, but if you notice there is a little bit issue with the player feet. Okay, the player feet gets inside the obstacle. Okay, but we will be fixing that when we add target matching to our project. Okay, so in the upcoming videos we will be working on target matching and all of these issues will be fixed. Hello guys and welcome back. So now in this video we will make the player look towards the obstacle while performing parkour. I will show you what I mean, but first of all make sure that you select both of the crates, okay, and make the crate size, or you can say the scale of the crate, as 3 0.52, and change this one to 3 1 and 2. Okay, then after that if we play our game, so now if we try to perform parkour from the side, as you can see the player just move to that side. Okay, and if we perform it right here, as you can see the player perform parkour on the side. But what we want, that whenever we are in this direction, or you can say the player is facing the right or a left side, and then if we want to perform parkour, we want the player to look towards the obstacle like this, and then perform the parkour like this. Okay, from the front if we perform it right here, as you can see. Okay, so we want to perform the parkour while the player looking at the obstacle. Okay, so let me now close the game and open up text editor, and on the parkour controller script right here, now we will remove this wait for second, because we will now be delaying our method by using the while loop. Okay, and between that delay we will make the player look towards the obstacle. Okay, so for creating a while loop, first of all we need to create a float by the name of timer counter, and this will be equals to 0f, or you can say 0. Then we will create a while loop in which we will say that if the timer counter is less than equals to animation state dot length, then what we will do, we will make the timer counter plus equals to time dot delta time. Then after this we will make the player look towards the obstacle, and then at the end we will say yield return null. That is it. Then on our new parkour action script, right here at the top, let's create a serialized field. This will be of type bool by the name of look at obstacle. Then right down below we will create a quaternion by the name of required rotation, and this will be get, and then we will say set. Then after this if condition, we will create another if condition, and in that we will say if look at obstacle is true, then what we want to do, we will say required rotation equals to quaternion dot look rotation, and then we will say minus hit info. Okay, this is this obstacle info, which is by the name of hit info, and then we will say dot hit info dot normal. Okay, and this hit info dot normal is coming from the environment checker. So what this whole code will do is it will basically get the player current rotation, and then it will change, or you can say it will set that rotation to our desired rotation, or you can say the rotation we want, which will be the rotation in which the player will look towards the obstacle before performing parkour. Okay, and if you guys are confusing between this hit info because it's the same name, so what we will do in here is we will change this to hit data actually. Okay, so let's change that to hit data right here as well, and then right here as well. Then right here, as you know that the look at obstacle is a serialized field and we can't access this look at obstacle outside this new parkour action. So what we want to do is we will create a property for this. So we will say public bool. Let's name this as look at obstacle as well, but the L in this look at obstacle will be capital, and then this will be equals to look at obstacle. Okay, that is it. Then if we get back right here to the parkour controller script, right here we will create a if condition in which we will say action dot look at obstacle. Okay, this is this property which we created. So if action dot look at obstacle is true, then what we want to do, we want to rotate the player towards the obstacle. So for that we will say quaternion dot rotate towards, we want to rotate the transform dot rotation towards the action dot required rotation. Then we want to limit this rotation by the rotation speed, which is on the player script right here, rot speed. And as you know that we already have a reference to the player script on the parkour controller script, so we will simply say player script dot rotation speed, and let's multiply that by time dot delta time. That is it. And right here at the top, make sure that you set the transform dot rotation of the player to this line. Okay, that is it. So just simply save the script, get back to Unity, and now if we click on our scripts folder, then in the player parkour actions right here you will see these two action, and on them we have this look at obstacle box. So now to whatever parkour action you want to add this look at obstacle functionality, just simply check this box, okay, on that parkour action, and then this functionality will be added to that parkour action. And when the player perform that parkour action, the player will rotate towards the obstacle before performing the parkour. Okay, that is the reason we created this look at obstacle bool right there. And then according to this look at obstacle bool, we are simply rotating the player towards the obstacle before performing the parkour. Okay, we now have a while loop to delay the execution and make the player rotate towards the obstacle. Okay, so just simply select your parkour actions on which you want to look at the obstacle. Then when you check that, then simply play the game. And let's get closer to the object right here. And now if we perform parkour while looking there, as you can see, the player rotate towards the obstacle, as you can see. Okay, if you notice it, as you can see, the player first of all rotate towards the obstacle, as you can see. Okay, and if we check it right here, as you can see, the player is looking towards the obstacle. Okay, the player fell down, but don't worry, as I told you, we will be solving this issue when we add target matching. But now as you can see, the player first look at the obstacle, then perform the parkour, and now the player is right there. Okay, so in this way you can add this look at obstacle functionality. Hello guys and welcome back. So now in this video we will be adding target matching to our game. So for now, if you notice, when we perform parkour, the player feet gets inside the obstacles, as you can see. So we need to fix this issue with our parkour actions. Okay, so for that let's close the game, and first of all let me tell you what target matching is. And if you want, you can also read the Unity documentation on target matching, but let me clear it out to you guys in simple words what it is. So if you click on the animations folder right here, let's find the jumping up animation. So what target matching will do is, for example, when the player jump right here, okay, you will notice the player right feet is in the air, or and as you know that in game this right foot gets on top of this obstacle. Okay, so from this point, okay, you can see the percentage right here of this animation from 55.3, or you can say from 42.1. We will start target matching till the end of this animation. Okay, and in the target matching we will type a code in which the player feet will be then on top of the obstacle, okay, instead of going inside the obstacle. And we will do the same for the other animation right here, which is for example this jumping up. So if you play this animation right here from the 10.1 percentage till this point where the player stands up, we will do target matching, okay, in order to make the player feet stay on the obstacle. Okay, so enough with the explanation. Let's click on our new parkour action script, and right here now we need to create some variables for target matching. But first of all, right here let's create a header by the name of checking obstacle height, and then let's move this look at obstacle down below, and let's create a different header for this, which will be by the name of rotating layer towards obstacle. Okay, then right down below now we will create a separate header for target matching. So let's name this as target matching as well. Then first of all, let's create a serialize field by the name of allow target matching. This will be of type bool, okay? And the reason we create this allow target matching is we will not be doing target matching on every parkour action. As you know that in this game we will be having a lot of parkour action, and as you know that we don't want to perform target matching on all of the parkour actions, okay? We just want parkour action on the step up or jump up or climb up parkour action, okay, which we will be adding in the upcoming videos. So that is the reason we created this pool, and when this is true on some parkour action, then we will be performing target matching, or else we will not be doing anything, okay? If I show you right here, if we click on parkour action, as you can see now we have this allow target matching, which will be true by default, okay? And on which parkour action on which we don't want to perform target matching, then we will simply uncheck it. But on these two we will be allowing target matching, okay? And also we created headers for every variables in order to make our code neat and clean, okay? So make sure that you also use headers like this. Okay, so after this pool we will create another serialize field, and this will be of type avatar target, and let's name this as compare body part. And let me now tell you that what this avatar target is. So if you open up Unity documentation and search for avatar target, you will notice that this avatar target give us some properties, okay? These 6 properties: root, body, left right foot, and a left right hand, okay? And the reason we are using this avatar target is we will perform our target matching on that body part of the avatar, or you can say of the player. For example, if we click on our jumping animation, okay, and move this a little bit right here, as you can see, the player puts the right foot first on the obstacle, okay? So in this animation we will use the avatar target right foot in order to perform the target matching on the right foot, okay? And if you check the other animation, in this one the player also use right foot. As you can see, the player puts the right foot first, okay? So we will be target matching on the right foot as well. So that is the reason we use this avatar target, okay? Then after this we will create another serialize field. It will be of type float, and let's name this compare start time, okay? This will be the time, or you can say the percentage of the animation from where we want to start our target matching, okay? Then let's create another serialize field which will be of type float as well, and this will be compare end time, and this will be the end time, or you can say the end percentage of our animation, in where, or you can say in which time we want to end our target matching, okay? Now once we have all of these fields, and as you know that these are all serialized fields, so what we will do, we will be creating references for all of them in order to access these values anywhere in our scripts, okay? So first of all, let's give some space right there, and then down below let's say public pool. Let's name this as allow target matching. This will be equals to the allow target matching which we created right here, this bool, okay? Then let's create another one for our avatar target. This will be by the name of compare, then body part, and this will be equals to the compare body part, okay? And guys, make sure that you name them as similar to mine, okay? I make the change right here, which is this A, and in here which is this C, okay? The first letter are capital, and in this one, as you can see, the first letter are small, okay? You can notice right there, okay? Now after the compare body part, now let's do it for the compare start time. So we will say public float, let's name this as compare start time, and then let's copy this and paste it down below. Let's name this as compare end time, and at the end we will now type compare start time, then compare, where is it, okay, compare end time, and make sure that you add semicolon at the end. Now after this, at the top, let's create a public vector 3, okay, and let's name this as compare position, and this will be similar to our required rotation, so we will say get set. Okay, and what this compare position will do is, if you have noticed, when we perform parkour, okay, on any of this obstacle, our player a little bit slide on this obstacle. Okay, when we perform parkour right here, the player moves to this area or this middle point. Okay, so now what that compare position will do, we will type a code in which the player will perform parkour and stay on the edge of the obstacle. Okay, so now in here, after this if condition, we will now say if the allowed target matching is true, then what we will do, we will say compare position. Actually this spelling is incorrect, so make sure that you correct it. Compare position, okay, this is this vector 3, so compare position will be equals to hit data dot height info dot point. Okay, and this will basically will do our work. As I told you, the player will jump perfectly fine onto the obstacle edge. Okay, not on the edge but a little bit away from the edge. It will look perfectly fine once we will be testing it. Okay, you will notice. Now after this, get back to the parkour controller script, and right here, as you know, we perform parkour action. Now right down below this method, we will create another method for target matching. So we will say void compare target, and this method will require a parameter which will be of type new parkour action, and let's name this as action. And the reason we are doing this is to access these values from here. Okay, so once you do that, then in here we will say animator dot match target. Okay, then in here what we will do, we will say action dot compare position. Okay, then after this we will pass the rotation, so we will say transform dot rotation. Then we will pass that body part on which we want to perform target matching, so we will say action dot compare body part. Okay, and then we will say new, then match target weight mask. Okay, and in here we will create a new vector 3, and inside this vector 3 now we will pass the position. So as you know that we only want to perform the target matching on the Y position. Okay, as you know that the player feet get stuck inside the obstacle. Okay, so we need to make that feet move a little bit up from the obstacle surface. Okay, so in the upward direction we will be performing target matching, and as you know it will be the Y position. Okay, so in the vector 3 for the X we will pass 0, for the Y we will pass 1, and for the Z we will pass 0. Okay, and then after this, the next thing which this match target required is the rotation speed. So for that we will simply pass 0. Actually this 0 will be inside this one. Okay, in the match target with mask brackets. Okay, so pass 0 right there. Then outside this bracket we now need to pass the compare start time and end time. So we will say action dot compare start time, then action dot compare end time. Okay, so it will then start the target matching from the compare start time till the end time. Okay, and then make sure that you add the semicolon at the end, and that will be it. Okay, you can check this line right here. Okay, pause the video and type all of this code. So now once we have the target matching, now after this if condition in which we say look at obstacle, okay, in which we make the player look at the obstacle. Now let's say if action dot allow target matching, okay, which means that if this allow target matching is true, then what we want to do, we want to call this compare target method, okay, in order to perform target matching. And inside this compare target we will pass the action. Okay, that is it, everything is set up. Now if we save the script and get back to Unity, okay, now if we check our parkour action, now you will notice that on every parkour action we now have the body part, the compare start time and compare end time. Okay, so now as I told you we will be performing target matching on both of these. So let's start from the jump up. Okay, let's set up the jump up. So yes, on the jump up we want to perform target matching. Now it needs the compare body part. So if we see the animation for the jumping right here, okay, as you can see the body part will be the right foot. So get back to the parkour action, click on this jump up and select right foot. Now we need the compare start time and compare end time. So for that we will be getting back to our animation, and if we move this animation to 0 point, I think 0.5, okay, so from 0.5 till 0.9 where the player puts both of the feet, okay, on 0.9. So from 0.5 you can see the percentage, which is 50.9. So from 50.9 till 96.2, or you can say 98.7. Okay, from this position to this one we will be now target matching. So if we select the parkour action, guys, make sure that you see the percentage according to your own animation. Okay, so now according to my uh, animation, the start percentage is around 50. Okay, so if it is 50, then in here I will type 0.50. Okay, or actually I will make this 55. Okay, and if your value is, for example, of 10 percentage or 20 percentage, then right here you can type 0.10 or 20 or 30. Okay, and as I told you we will be adding the end time as 0.97 since our percentage was around 90. Okay, it was above 95, but I will right here type 0.97. Okay, because that will be a good value, or you can type 0.98 as well. Now let's do it for the high jump up parkour action. So in here we also want to use the right foot. Now let's test the start and end time. So if we select this animation running jump, okay, so we want to start the target matching from this 10. As you can see on 10, or you can say on 8 or 9, the player put his right feet, and then to which point, to 95 or 97. Okay, till that point we want to do target matching. So now how we will type this in our high jump up start and time. As you know, the start was on 10 percentage, so we will type 0.10, or let me actually put 19. Okay, and then the end time was 97 percentage, so we will type 0.97. Okay, and the reason we put 0 at the start is because on the target matching documentation you will see right here this line that note in this case it is 14.1 percentage, or you can notice this or, which is 0.141. Okay, so we type the percentage like this. Okay, we first add 0 and then type the percentage value like this. Okay, you can read the target matching documentation, you will understand it even more perfectly fine. Okay, as you can see right here in the compare start time and end time, they use the 0.141 and 0.78. Okay, but we have floats, okay, a float variable for these two. Okay, we are not hard coding for these two values. We have right here the compare start time and end time, and then we use the compare start time and end time right here at the end, as you can see. Okay, because we have a lot of parkour action and we can't type this compare target function again and again for each of the parkour actions, so that's why in our new parkour action we created these values for each of the parkour action. Then we set up that values for each of the parkour action, and then the player will perform it perfectly fine. Okay, so now once you set up the target matching variables, now let's just simply play the game and let's test out our target matching. So if we run towards the obstacle now, let's perform it. As you can see, the player performed the parkour action perfectly fine. Now the player feet doesn't get inside the obstacle. As you can see now, the player feet are not getting inside the obstacle that much. In the previous videos, if you noticed, the player feet were going inside the obstacle a little bit more than this, but now as you can see it is perfectly fine. Hello guys and welcome back. So now in this video we will be adding the climb up parkour action. So for that, open up unity.com and make sure that your character is uploaded, and after that click on animation, and right here let's search for sprint to wall climb, and right here you will notice this animation which is by the name of sprint to wall climb. Click on it, and as you can see it will start playing like this. Okay, so let me get closer right here to the player. Okay, so this is the animation which we will be needing. So just simply download this animation without skin and make sure the format is FBX for Unity. Click download. Then after this, let's search for one other animation which is by the name of crouch to stand. Okay, you will find this animation crouch to standing. Click on it. Okay, and as you can see this is the animation. Just simply click on download, and the format and skin will be the same. Click on download, and once these two are downloaded, let's rename the first one to, let's just say, stand. Okay, and let's rename the second one to climb up. And once you rename them, let's now drag and drop it inside Unity. So inside the animations folder I will drag and drop them, and as you can see here is the animations. Now let's select the stand, click on its rig, change it to humanoid, then the avatar definition will be copy from other avatar, and let's click main mesh, click apply, and if you go inside the animation now, drag and drop the player. Now if we play the animation, as you can see this is the animation. Now let's select the climb up and click on its rig, change it to humanoid, copy from other avatar, and select main mesh, click apply. That is it. Okay, let's drag and drop the player now again in there, and as you can see this is the animation. Now we will be needing to trim this animation. Okay, we want to trim the starting part from this animation, okay, for example this running, okay, if you scroll down right here, first of all, let's change the root transform rotation to original, and let's make this bake into pose, okay. Then right here the position Y will be changed to feet, and then simply click on apply, and let's now select this animation again. Now you can notice the player is not rotating, okay. Now let's go ahead and trim this animation from the start, because as I told you, we don't need this running part of this animation. So from the start we will trim the first 7 frames, okay. We just need this climbing part, okay. If you notice from this 7 right here, actually we need to move it forward from here, okay. If you notice from 7 the players start climbing, okay, and at the end we will cut the last 4 frames, so we will make this 50, okay. And if you notice now, this is our climbing animation, and we will be joining this climb up animation with our stand, because if you notice at the end the player doesn't stand up, okay. So that is the reason we downloaded this stand animation. So now before doing anything, first of all click on apply, then click on the stand animation, and right here make the start as 3 and the end to 15, okay. And in this way our standing animation will be faster, if you notice, okay. Click apply, and then let's change the rotation to bake into pose, and change this to original, change the position Y to feet, and then click apply again. And now if we select our animation again, now if you notice the player is not rotating. Now if we click on our scripts folder, let's create a parkour action for our climb up animation. But before creating the parkour action, let's go ahead and click on animator now, since our animations are ready. So first of all, drag and drop the climb up animation, then the stand animation, okay, and let's change their name to climb up, and then this one to stand, or let's just actually change this to climbing up, okay. I think climbing up is more a good name for this animation, and change this stand to standing, okay, because we don't want these names and the names of the animation right here the same, okay. You can leave it as climb up and stand, but I will change this to climbing up and standing, okay. Then what I want to do is to make a transition from climbing up to standing, and then from standing to basic locomotion. And now if you select this transition and play the animation, you will notice that now this is a fully climbing up animation. As you can see, the player climbs up and then stands, okay. Now let's go ahead and create a parkour action for this. So if we click on scripts, then go inside parkour actions right here, let's create a new parkour action, and let's name this as climbing up, okay. In here the animation name will be this climbing up, so let's say climbing up. And now let's set the minimum and maximum height. So guys, for the high jump up, let's make the maximum height as 0. Let's just say 7, okay. And then if we click on climbing right here, make the minimum height 1 and the maximum height as 0.2 or something like that, okay. So make sure that you do that. Then right here we want the player to look at obstacle as well. We will also allow target matching, and as you know that in our climbing up animation right here, if you notice the player puts the both of the hands on the obstacle, as you can see. But if we see our parkour action right here, we don't have the option for adding these two hands on our target matching, but we will just simply use the right hand actually, okay. So this will also work perfectly fine. Now we need the start time and end time. So if we go ahead and click on our animation again, okay, let's play it. And now what we will do is we want to start target matching from this point where the player starts moving the hands till the point. Let me show you right here. When the player puts the hand on the obstacle, okay, 0.28, or you can say 28 percentage. From 28 to 30 you can put this value, okay. So now if I click on parkour action, let's select this, the start will be 0.08 and the end time will be 0.28. Okay, that is it. Then if we go ahead and click on our player right here, now change the array size to 3. I think this is the list. Okay, so change the list size to 3 and then simply drag and drop the climbing up parkour action right there. Then if we go ahead and see our crate, okay, this crate right here, if we click on it, okay, let's change the scale wide to 3, okay, because we want to increase the size of this since we now have a climbing animation and that animation is for big obstacles. Okay, so now let's minimize that after changing the scale size. And then guys, I have already played the game and test this animation out, but we need to do some changes in our minimum height and maximum height values in each of these three parkour actions. Okay, these values might be different for you, but if you want to add the correct values, then just simply play your game and try changing the minimum height and maximum height values, okay, again and again. And when some values works perfectly fine for that parkour action, then leave that values as it is. Okay, for example, for my jump up parkour action, the minimum height value will be 0.1 till 0.6. For the high jump up, it will be from 0.7 to 1, and then for the climbing up it should be 2 and 5. Okay, so if you are using the same things as mine, then these values will work perfectly fine for your game as well. Okay, so after doing that, now let's go ahead and test it out, our parkour actions. Okay, so here is our player. Now let's go ahead and perform the first parkour action in order to test it out. And as you can see, it is performing these two parkour action perfectly fine. Now let's go ahead and perform this one. And as you can see, the climbing animation is working fine as well. But if you notice, the player hands and body is going inside the obstacle, but we don't want that. So now let's go ahead and fix this quickly. So if you select any parkour action, actually if we open up this new parkour action script, okay, so let's go ahead and open up this new parkour action, and right here we have the compare position. Okay, so let's now click on parkour controller script. Okay, so here is our compare position. Right here we passed it, and at this line at the end, if you check, we have this vector 3. Okay, and this vector 3 is set to 0, 1 and 0. And the reason we type it as 0, 1 and 0, for the x it was 0, for the y it was 1, and for the z it was 0 as well. So the y was 1, that is because when we were playing these two parkour action, we were making the player move up a little bit and land on this surface perfectly fine. Okay, and for the second parkour action we were doing the same because our player feet were getting stuck inside the obstacle. But now we have this third parkour action, and in this one we will be moving the player in the upward direction, but also we will be moving the player a bit outside this obstacle. Okay, so we now need to make the z value 1 as well, but we can't make the 0 1 like this, okay, because in the upcoming videos we will be having more parkour action and we can't hard code this like this, okay, because for some of the parkour action it should be 0. So let's go ahead and click on new parkour action now right here. After this compare end time, let's create a serialize field, and this will be of type vector3. Let's name this as compare. Make sure it is in small letters. So compare position weight, and this will be equals to new vector3. And now let's go ahead for the x pass 0, for the y pass 1, and for the z pass 0 as well. Then if you scroll down, let's create a reference for it. So after the compare end time, right here we will say public vector3. Let's name this as compare position weight, but make sure right here this c is capital, and then at the end this will be equals to compare position weight. Then click on Parkour controller script, and now right here we will remove this, and we will type action dot compare position weight. Okay, make sure that you call this capital C. Okay, compare position weight. That is it. So save the script, get back to Unity, and now you will notice we have this compare position weight right there. Okay, and for these three animation, the y will be 1 because it will be the same for them. Now for the climbing up, make the z as 1. Okay, then if we go ahead and play the game, now let's go ahead and test out our climbing parkour action. Let's perform it now. If you notice, the player body is not going inside the obstacle, as you can see. Okay, it is now playing perfectly fine. Okay, if we try it again right here, as you can see, the player is performing the parkour action perfectly fine. Okay, now let's try to perform the other one. As you can see, this one is perfectly fine. If we select this one, it is as well. So now all of the parkour actions are playing perfectly fine. Okay, and guys, if the player body of your player is still going inside in these obstacles, okay, or you can say in these other two parkour action, the jump up and high jump up, then you can also go ahead and select them and change the z value to 1 like this. Okay, and then test it out again, and then it will be all perfectly fine. So now, whoops, now if we go ahead and test it out again right here, as you can see, it is playing this animation perfectly fine if you notice it. Okay, and now let's test this out. Okay, so now all of the three parkour actions are working perfectly fine. Okay, and I will leave the values as it is. Okay, and with this done, let's end this video right here. Hello guys, and welcome back. So now from this video onwards, we will start adding our barrier jumps, or you can say wall jumps. Okay, so for that, as you know that we have these barriers right here, so make sure that you add the barrier pack in your project as well, and then select this barrier, and let's decrease the box collider to this side because we want the player hands to be on top of this surface. Okay, but if you notice, the box collider was a little bit wider, so make sure that you move the box collider close to the upper surface of this barrier, then from this side as well. Okay, so once you do that, then let's do the same for this one as well. So as you know that this one has two box collider, the first one is right down below. So what we're gonna do is we will remove the first box collider, and then let's edit this second one, but actually this second one is fine. Okay, but we just need to move this second one a little bit down below to this point. Okay, so let's move it right down there. Okay, and once you do that, now let's select this one, and let's click on this edit collider. Okay, and let's move it to there, then from this side as well. Okay, so as you can see now, it is looking good. And then what I want you to do is to select these barriers, and then what I want you to do is add a tag right here. So click on add tag, then let's name this as barrier, click save, and then select these three again and simply add the barrier tag right there. After this, on the mixamo.com, search for jumping, and right here we have this jumping animation, so let's click on it. Okay, so this is the animation. Let me rotate. Okay, so this is the animation which we need for our barrier jump. So let's click on download, change it to FBX for Unity, then without skin, click download. After this, if we scroll down, you will notice this animation jumping. So you can select this one as well. Okay, because we will be adding different vault actions. Okay, you can add as many vault action you want. Okay, so I will download that too. Then let's select this one as well. If you want to use this vault action, then you can also use this one as well. Just simply download it, and that will be it. Okay, if you want, you can search for more jumping animation and use them as well. Okay, so once you download these three animations, let's now drag and drop them inside our animations folder. So select that, then let's go ahead and drag and drop them in here. Then let's see where it is. Okay, so this is the jumping, not that. I think this is the one. So jumping, then jumping 2, and let's find the other jumping. Okay, so let's select this one. Okay, the jumping one, all of the names are the same, but as you know that on this animation we don't have the rig set up, so let's set up the rig, copy from other avatar, and select main mesh avatar, click apply. Let's click on animation now, and let's drag and drop our player. Let's see which animation is this. Okay, this is this jumping. Now let's select the next one. Let's do the same setting. So click humanoid, copy from other avatar, and select main mesh, click apply, then simply drag and drop the player. Okay, this is this one. Now let's select the next one, change this to humanoid, then copy from other avatar, and let's select main mesh avatar, click apply. Let's click on animation, drag and drop the player. Okay, so this is our jumping animation. Okay, now let's rename them actually. So we will type jump 1, then let's select the second one. Okay, let's rename this to jump 2, then let's select this jumping animation. Okay, and let's now rename this to jump 3. Okay, now let's select the jump 1, and now we need to trim this, but before trimming, make the rotation back into pose, the body orientation original, and change this root transform y to feet. Okay, then click on apply, and now if you notice the player is not rotating. Okay, now the next thing which we will be doing is to trim this animation. So from the start, trim the first 4 frames, and from the end it is perfectly fine. Now if we play it, as you can see, it is now only playing the vault jump, as you can see. Okay, so in this way you can trim this animation, and make sure that you click apply, because we didn't click apply, so it shows that save option. So make sure that you click apply before going anywhere. Okay, now if we click on this animator, let's drag and drop our jump 1 right there, and we will change its name to vault jump, for example, and then make a transition from this to basic locomotion. And now if we play this, as you can see, it is now a fully animation. Okay, the player jumps, then gets back into the basic locomotion idle state. Then let's go ahead and create a parkour action for this. So inside our parkour actions, let's create a new parkour action and let's name this as vault jump. Okay, and now we need to add the animation name. The animation name is vault jump as well, so make sure that you type the name correctly. And then we need the minimum height, maximum height, the look at obstacle, and the other things. Before now setting these values, we need to add some few option in our parkour action data. Okay, and that option will be to add a barrier tag option, because these vault jumps will be different from our other parkour actions. Okay, and the reason we are separating them from the other parkour action is, for example, the height of this obstacle and this barrier is the same. Okay, so if we didn't make a difference between these parkour action, then the player will perform the wall jump on this barrier, or you can say this object, and also the player will maybe perform the high jump up on this barrier. Okay, so we don't want to mix that up. Okay, so that is the reason why we created the barrier tag, and now we need that barrier tag inside our wall jump parkour action data. Okay, so for that, simply open up the new parkour action script, and at the top after the animation name, let's create a serialize field. This will be of type string, and let's name this as barrier tag. Right here, make the b small, then right down below in our check if available, let's now check for the barrier tag as well. So what we're gonna do is let's add curly brackets right here. Okay, and then at the top before this float, we will now check for the barrier tag. So we will say if string dot is null or empty. Okay, then we will pass the barrier tag, and we will say, sorry, type and. Okay, and hit data dot hit info dot transform dot tag is not equals to the barrier tag. Okay, then what we will do, we will say return false. Okay, so now what this means, it means that if the barrier tag is not empty. Okay, so if the barrier tag is not empty or null, and also the tag, okay, the tag of the obstacle is not equals to the barrier tag, then we will simply return false. And you will be thinking that where this tag will come from. As you know that this hit data dot hit info is on our environment checker. Right here inside this obstacle info, we store all of the information about the obstacle that is in front of the player. Okay, so as you know that we stored that inside our hit info, so that is the reason right here we say hit info dot transform dot tag, because right here inside this hit info, when we create a raycast, it stores the information about the obstacle. Okay, it stores all of the information, the position, rotation, scale, the tags, and everything about that obstacle. Okay, so now after this if condition, let's go ahead and save the script. Now if you click on wall jump, as you can see right here, it needs the barrier tag. Okay, you don't need to apply the barrier tag to these three parkour actions. Okay, we just need to add the barrier tag on which parkour action it is needed. So as you know that the barrier tag is by the name of barrier, because if you check this, as you can see, the tag is barrier. Okay, you can type your own barrier name. Then for the minimum height, we will pass the same values as our, let's just say, as our high jump up. So it is 0.7 and 1. So we will say 0.8 and then 1.1 maybe, something like that. Okay, we might change these values when we test our game. Okay, but for now we will leave this as it is. Click on this look at obstacle. We will also allow target matching, and in the compare body part, let's see our animation. Okay, this is the animation. If we check it, the player puts the left hand first, as you can see. Okay, the left hand first. So right here we will select left hand, then the compare start time. Let's check that out as well. So we want to start target matching from this point where the player puts, I mean move the hand in the air right here on this 12 percentage. Okay, and then to which point, let's move to this position, this 31 position. Okay, from 12 to 31. Okay, from here to, let's just say 31 or maybe 32, but we will type 31. Okay, so now from 0.12 to 0.31. Okay, and make the z1 and then save this. Now let's click on player and let's make the list number as 4. Now drag and drop the wall jump and move this wall jump right here above this high jump up. Okay, because we want to prioritize our wall jump. Now let's play the game and test it out. Okay, so here is our player. Okay, let's move right there. So I think the player is not jumping on that, but if you notice, the player is jumping on this obstacle and also on this one. Okay, I think there is an issue with our minimum height and maximum height. Maybe let me test this one. As you can see, this one is also perfectly fine, but the player is not jumping onto this one. Okay, so let me go ahead and fix the values. So as I told you, in order to fix the values, you just need to select wall jump. Let's change this to 0.6 maybe, and let's test it. Okay, it's not working. Let's make this as 0.9 maybe, not 9.9. Okay, it is still not working. Let's make this one. Okay, it is not working, and the reason the player is going inside this obstacle because the collider of this obstacle is smaller. Okay, so that is the reason why. Guys, I will stop the recording and change these values. Okay, and test it out on which values this works perfectly fine, then I will show you that values. Okay, so I have tested the values and we just need to increase our maximum value to 1.6 and minimum value to 0.6. Okay, and now if we go ahead and test it out, as you can see, the player is performing the wall jump perfectly fine. But if you notice, when we perform it, the player stays in air for a while. As you can see, the player is in the air. Okay, and that it not looking good. Okay, so we need to fix this issue with our wall jump. Okay, and we also want to add the other wall jumps as well, but first of all we need to fix this issue. So what we're gonna do is we will end this video right here since our wall jump is working, and in the next video we will fix the issue with our wall jump. Hello guys and welcome back. So in this video we will be fixing two issues with our game. So the first issue is that when we perform this climbing up parkour action, and if you hold down the W key, you will notice that there is a slide in our animation. As you noticed, okay, there is this sliding, if you notice. Okay, and the second issue is with our wall jump. When we perform wall jump, the player, as you know, stays in the air for a while. So we need to fix these two issues. So for that, open up the new parkour action script, okay, and after this look at obstacle. We will create a new serialized field. It will be of type float, and let's name this as parkour action delay. Okay, then let's create a reference for this parkour action delay right down below after this. So we will say public float. Let's name this as parkour action delay as well, but the P will be capital, and this will be equals to the parkour action delay which we created up there. Then on our parkour control script right here, before giving control to the player, now right here we want to add some delay, and that delay will be the parkour action delay value. So we will say yield return new, okay, and then we will say wait for seconds, and then we will type action dot parkour action delay. And the reason we created a separate float for our parkour action delay is because we have a lot of parkour action, and not all of the parkour action requires a delay. So that's why we right here didn't type the value directly. For example, we want to wait for 0.5 seconds before uh, after playing the climbing parkour action, okay. So that's why we created this parkour action delay. And now if I show you the parkour actions right here, click on climbing up. Now as you know that we have this parkour action delay right here, and now we can add delay to a specific parkour action. Now right here we just want to add the parkour action delay to our climbing up, so we will add a delay of 0.5 seconds. So if we click right there and add 0.5, okay, so now after playing the climbing up parkour action, it will wait for 0.5 seconds before going back into the basic locomotion and giving back the control to the player, okay. So now just simply play the game, and right here if we now perform our parkour action, as you can see now after 0.5 seconds the players start walking. Let me show it to you guys again. As you know, right here 0.5 seconds, and after that the players start walking again, okay. So in this way you can add parkour action delay to your own parkour actions. Now let's fix the second issue. For the second issue, if we check the animator right here, if we open up this transition, okay, and if we play this transition, as you know that while playing this animation there is this gap, okay. We don't want to play this whole gap right here, okay. If you notice the parkour controller script right here, as you know that we wait for the whole length of the animation, and we basically don't want that for all of the parkour action animations. So what we're gonna do is after this if condition, which is action dot allow target matching, after this we will add another if condition, and in this one we will say animator dot is in transition, okay. Then right here we will pass 0, and then we will say if the timer counter is greater than 0.0.5, then what we want to do is we will simply say break. That is it. If we save the script and get back to Unity and let's play the game. But guys, before let's playing the game, let me stop the game, change back to scene view right here. Make sure that you make the collider of this down to the ground, since our ray will be coming from the player feeds. So as you know there is this gap and the ray will not be able to catch this, okay. So make sure that you move this collider down to the ground like this, okay. And then what I want you to do is click on the player and make the player height to 1.9. If your height was 2 of the character controller, then make it 1.9 and then play the game. Now let's go ahead and test it out. Okay, Now let's test this one. Now as you can see, the player doesn't stay in the air that much longer. As you can see, the player simply gets down to the ground immediately. Okay, let's test it out again. As you can see, the player doesn't stay in the air that longer now. Okay, so in this way you can fix this issue as well. So with now both of the issues fixed, in the next video we will be adding the other vault actions as well. Hello guys and welcome back. So now in this video we will be adding the second vault jump. Okay, so you can select any of this vault jump. For example, I will try to add this jump 3, okay, because this looks cooler than the vault jump 2. Okay, so now let me show you how you can create different type of vault jump. So first of all, select the animation on which you want to perform the parkour action. I will select this one. Okay, right here make this back into pose, select original, and then right here select the feed, then click apply. Then if we play the animation, as you can see now the player is jumping in the straight line, if you notice. Okay, and also we don't need to trim this animation since this is just the jump animation. As you can see, the player only jump. But if you are using this second animation, okay, from this animation you need to trim the starting part. Okay, I mean this part a little bit. Okay, and also from the end make sure that you trim the end part as well a little bit, but I think the end is good, so you don't need to trim that. Okay, so now let's add this animation to the animator right here, drag and drop it, and let's name this as vault jump 2, or let's just say vault jump 1. Okay, and now before creating another parkour action for this, first of all, as you know that we now have two vault jump action and we want to play that two parkour action on these obstacles. Okay, so as you know that on this obstacle we will play the vault jump parkour action, and then on this one we want to play the vault jump 2. Okay, so on this obstacle we need to change the tag. Okay, so for example we will click on this add tag, let's add another one, and this will be by the name of barrier 1. Okay, so add barrier 1 and then add that tag to this one, barrier 1. Okay, and once you add a new tag for this obstacle, now let's go inside our scripts parkour action, and right here let's create a new parkour action, name this as vault jump 1. Now in the barrier tag, first of all add the barrier 1 tag, and in the animation it is vault jump 1, so vault jump 1. Then we need to set the minimum height and maximum height, so it will be basically similar to our vault jump, okay, which is 0.6 and 1.6, so 0.6 and then 1.6. That's it. We need to make this as look at obstacle. We will also allow target matching. As you know that in this animation the player puts both of the hands. Okay, in our parkour action we can't use both of the hands, so we will just simply use the left hand or right hand. Okay, then we need the start and end time, so let's click on our animation again and let's see the start time. So when the player start to put the hand, okay, if you notice it right here, so maybe from 35 to 50, okay, 35 to 50 we will make the time, or okay, or let's just say 55. Okay, so 35 and 55. So if you click right here we will say 0.35, then right down below 0.55. okay, we might change these values but for now let's leave this as it is. Make sure that you add 1 in the Z, just as we did for our first one. Okay, so now everything is set up. Let's click on the game and play it. But before playing it, let's actually click on the player and make sure that you add the wall jump one in the parkour actions. So let's add the fifth one now. Drag and drop the wall jump one right there and make sure that it is right there, okay? And once you add that, then click on the animator and right here make a transition to basic locomotion from wall jump 1 since we didn't add the transition. So now when the player perform this, the player will go into basic locomotions, okay? So make sure that you do these two things. The first one is to add the wall jump 1 right here and then make the transition. Now let's go ahead and play the game. So now if we get closer to this, as you can see the player is performing that one and this one as well. As you can see it is performing that animation perfectly fine, okay? Or you can say the parkour action. As you can see, okay, the player puts both of the hand on the obstacle, okay, if you notice it right here. So now we add a new vault action, and now if you want you can add the second vault action as well. I've shown you how you can add that vault action. So just simply make the rotation back into pose, click on paste upon, set it to original, and right here change this to feet, click apply, then go ahead and create a parkour action for this, okay, and add a different type of tag for this. And if you want that the player perform the first one and the second one on the same obstacle, then just leave the tag, okay, the barrier tag as barrier, okay. So then it will choose one of the parkour action from that one, okay. So just simply create a parkour action, add the animation like this, and then add that parkour action right here, and then you will be able to create your own wall jump, okay. I've shown you in this video how you can create your own wall jump, so just follow these steps and add another wall jump. Now let's end this video right here. Hello guys and welcome back. So now from this video onwards we will start working on our jump down parkour action. For now if you notice we only play the jump up parkour action, but if we move towards the obstacle edge, as you can see the player just simply walks off the edge, okay. So we actually don't want that. So for now from this video onwards we will start adding the jump down parkour actions as well. So let me tell you now how our jump down parkour action will work. First of all, on our environment checker script, we will create a method for checking the obstacle ledges. Okay, so for example, this is the obstacle and the player is right here, for example, okay, and then the player walk towards this ledge of the obstacle. Then right here we will detect this ledge. Then we will tell the player that you are on the ledge, and after that we will simply perform the jump down parkour action, okay. And we will detect the ledge by using a method. So for example, if the player moves to this area, then from here in the downward action we will cast a ray, and then if that ray touches the surface, then the player will know that now after this point there is no more obstacle, there is only the surface, and then we will know that yes, this is the ledge, okay. So now let me close this and let's do it using programming. So right here on the environment checker script, what we will do is we will create a header by the name of check ledge. Then in here we will create a serialize field. This will be of type float, and then we will name this as ledge ray length. This will be by default equals to 11f. You can increase this ledge ray length according to your obstacle, okay, how big your obstacle are, okay. Then after this we will create another serialize field. It will be of type float as well, and let's name this as ledge ray height threshold, and this will be equals to 0.76. Okay, now once we have these two variables, then after this check obstacle, let's create a new method now for checking ledges. So we'll say public void, let's name this as check ledge, and this check ledge will need a parameter which will be of type vector3, and let's name this as movement direction. And the reason we will be needing the movement direction is because we will be checking for ledges in the direction which the player is moving. So for example, from here the player is moving to the right side, okay, then we will check ledges in that direction, and in the player is moving forward, then we will check ledges in that direction, okay. So that is the reason we need the movement direction. And guys, before moving forward, let's open up the player script, okay. And we did a mistake right here in our starting videos, which is we typed this move dir on the right side, okay, and this move dir should be on the left side. So right here move dir will be equals to movement direction. So in this way, whatever that is stored inside the move direction will be moved to the move dir. And as you know that the reason we created this move dir is in order to access the movement direction from this player movement in our every script, okay. So make sure that you do this as well, okay. Then if we get back to the environment checker right here, now let's check for ledges. So we will say if the movement direction is equals to vector3 dot 0, and guys, don't get confused, this movement direction is this vector3, okay. It is not this movement direction which is on our player script, but we will be passing this movement direction from the player script to our environment checker, but it will be later in this video. Okay, so if the movement direction is equals to vector3 dot 0, it means if the player is not moving, then we will simply say return false, okay. Then after this we will create a float by the name of ledge origin offset, because now we will be giving our ledge raycast origin. And as I told you in the starting of this video that the origin of the ledge ray will be from this obstacle ledge in the downward direction, okay. So since this is the offset, we will give offset of 0.5, and then now let's set the ledge origin. So we will create a variable by the name of ledge origin, and this will be equals to transform dot position plus movement direction, and then we will pass the ledge origin offset, okay. Then once we have the ledge origin, let's now create a physics raycast. So actually right here we will say physics dot raycast, and as you know, in the raycast we first need to add the origin from where we want to create a ray, so that will be the ledge origin, okay. This is the ledge origin, okay, this area, this red circle. Then as I told you, from that position in the downward direction, so we will say vector3 dot down, and then whatever that ray hits, we will store it inside our raycast hit type variable hit, okay. And then we need to limit this ray by the ledge ray length. And guys, in our ledge ray length, make sure that the L is capital at the end, okay. Change it right there, and then right down below here as well. And right here in this vector3 dot down, you need to type the down in small letters, okay. And then At the end we will pass the obstacle layer. Okay, now at the start we will add a if condition, and then we will store all of this code inside the round brackets. Okay, so what this means, it means that if the raycast is creating, then what we want to do now, we will first of all create a float by the name of ledge height, and this will be equals to transform dot position dot y. Okay, and then we will say minus hit dot point dot y. Okay, then we will say that if this ledge height, okay, this ledge height is greater than the ledge height threshold, then it means that we are creating a ray, so we will return true, and then after this if condition we will return false if there is no ray casting. And right here make sure that you remove this void and type pool. Okay, once you do that, then you know that this check ledge now needs the movement direction, and the movement direction is on our player script. So right here after this main camera controller reference, let's create a reference now to our environment checker. So you will say public environment checker. Let's name this as environment checker. Okay, then right here in the update method, right here when the player is on the surface, inside this if we will say environment checker dot, let's call the check ledge method. Okay, so check ledge, and in here we will pass the move dir, or you can say the movement direction. And as I told you, the movement direction which is inside the player movement is equals to this movement dir. Okay, and we can access this movement dir outside this player movement, so that's why right here we will type move dir. After this we now want to print a message in our console to know that if the player is on the ledge or not. So for that, after this on surface pool, let's create a public pool which will be by the name of player on ledge, and in here we will add curly brackets and say get and then set. Then right here we will say player on ledge will be equals to this. So if that is true, okay, we will say if player on ledge, then what we will do, we will say debug.log, and in here we will say player is on ledge. Okay, and make sure that this is inside this round brackets inside double quotes. Now after this, let's save the script and get back to the environment checker, and right here in the check ledge we create a raycast. Okay, so for now if you play the game you will not be able to see this raycast, so we also want to show this raycast in order to understand it more perfectly. So inside this if condition we will say debug.log, and in here we will pass the ledge origin, and then we will type vector 3 dot down just as we did right there. Then we will multiply this by the ledge ray length, and at the end we want to color this ray. So as you know we already use the red and blue, sorry, the red and green ray, so now we will just simply color this as blue. Okay, so at the end type color dot blue, and right here it should be debug dot draw ray. Go ahead and save the script and then click on player. Right here now we have the ledge ray length and the threshold on our player checker. Now let's open up the player script as well, and right here on the player script we need to add the reference for the environment checker, so drag and drop that. Now before playing the game, make sure that right here on the surface layer you also provide the obstacle layer, because when the player is on the obstacle layer, then it means that yes, right down below the player there is something that the player is standing on, and we don't want to apply the falling speed. Okay, so make sure that you apply the obstacle layer right there as well. And then right here on the obstacle layer, choose also the surface layer as well. Okay, and when you do that, now let's go ahead and play the game. Now if we go ahead and walk towards the obstacle, okay, let's go ahead on top of this and let's see the console for a while. And now if we get closer to the ledge, as you can see, it is showing that the player is on ledge. Okay, if you notice it, the player is on ledge is now increased to 47, and now if we move again to the ledge, as you can see, now it is 66. So it is now detecting that the player is on ledge. Okay, hello guys and welcome back. So in the previous video we detect the ledges. Now in this video we will be adding the jump down parkour action. So for that, open up the miximo.com website and make sure that you have added your own character. Okay, then right here search for jumping and you will find this jumping up animation. Okay, make sure that you download this. So let's click on download. FPX for Unity, the skin will be without skin, then click download. Once you download this animation, now let's go ahead and search for hard landing and you will find this hard landing animation. Okay, click on download. The setting will be the same for this one as well. Click download. After this, let's go ahead and now search for jumping and you will find this jumping animation. Okay, this is the description of the animation. Click on download. The setting will be the same for this one as well. Then after this, search for fall a landing to idle and you will find this animation. Download this one as well. Then after this, our last animation will be by the name of falling idle. As you can see, this is the animation. So make sure that you downloaded this last animation as well. Then after downloading all of the animation, let's click on the animations folder and right here we will create another folder by the name of jump down animations. Let's open this up and in there let's drag and drop these downloaded animations now. So drag and drop it right in here. Then what we will do, we will change the rig of all of these animation to humanoid, then copy from other avatar and then select the main mesh, click apply. If we check the animation now, drag and drop the player in there, as you can see the animation is looking perfectly fine. Now let's do it for the other ones as well. So humanoid, copy from other avatar, select main mesh, click apply. Then for this one as well, click apply. Then right here and then we have this last one, so just simply select the main mesh and click apply. So once you do all of that, now if we click on player, as you can see these all animations are working perfectly fine. Now what we need to do is to select the animation which is by the name of jumping. Okay, this one, because first of all we will be adding the jump down parkour action for these small obstacles. Okay, so now if you select this animation, what we will do with this is, as you know, the loop match is a green sign, so we will click on bake into post, change it to original, and then right here in the root transform Y we will change this to feet and then click apply. And if you notice, now the player is not rotating and also the animation is set to feet as well. Okay, and once you do that, we need to trim this animation as well. So from the start we will trim the animation to 25, and from the end we will trim it to 48. Okay, and the reason I know the exact values is because I have already checked this animation. Okay, from this animation we just remove the running part. Okay, we just leave the jump up part. As you can see, the player now on the jump in this animation. Let me tell you guys that we will be joining these animations in order to create a fully animation. Okay, so this will be our first animation when the player jump off the obstacle. Now we need a animation in which the player will be in air. So for example, this falling idle. Okay, so what we need to do with this falling idle is we will be playing this animation till that point in which the player is in air. Okay, so we will change this to loop time loop pose, change this to original back into pose right here as well, and change this to original as well. Then click apply. That's it. Now the player jumps off the obstacle, the player is in the air. Now we need a animation in which the player will stand on the ground. So if you notice this fall a land to standing idle. Okay, we now need to set this animation as well. On this animation from the end we will cut the frame till 17. Okay, because we don't need the part in which the player goes down to the ground. As you can see, the player heads goes down a little bit. Okay, we don't need that part, so that is the reason why we will be just cutting the end 17. Right here, click on back into pose, select original since this is a green sign, and right here we will change the position Y to feet only. Okay, click apply, and that will be it. Okay, so now when the player moves down, and as you can see the player moves up again, so now when the player moves up, then after that we will set the player back to basic locomotions. Okay, when we set this animation you will understand it even more perfectly. So now let's go ahead and click on animator, and right here we need to add this animation. So the first one will be this jumping actually. So let's drag and drop this right here. Okay, then after the jumping we need the in air animation. Okay, which is this falling idle. Okay, so let's add the falling idle right here, and then we need the landing. So this is the landing animation. Let's drag and drop that at the end. Okay, then from jumping make a transition to falling idle, then from falling idle to the third one, and then from the third one it will be then to the basic locomotion. And then if you select this, as you know, when the player lands the player will get back into locomotion. And now right here when the player is in the air, we want the player to know that yes, you are in air. Okay, and also when the player reaches the surface we will be letting know the player that you reaches the surface. Okay, as you can see this transition from falling idle to landing. Okay, right here we will know the player that now you are on the surface. You can now stop playing the falling animation and just simply play the landing animation. So how we will do that? Right here in the parameters we will create a bool, or you can say boolean, by the name of surface. Actually it's on surface, and then in this transition we will simply add a condition, and in this condition we will make the on surface true. Right here remove this as exact time. Now after this, if you go inside the scripts, then parkour actions, right here let's create a new folder by the name of jump down actions, and inside this jump down actions we will be adding our jump down actions. Before creating any jump down parkour action, let's click on this jumping, and let's change its name to jump down. Okay, then inside this jump down actions what we will do is we will create a new parkour action by the name of jump down, action, or let's just say just jump down. Okay, same as our animation name. Then in here we just need to provide the animation name, so the animation name will be jump down, and that will be it for this jump down parkour action. We don't need to apply all of the other things. Now after this, go ahead and open up your parkour controller script, and now we will be performing our jump down parkour action. But before doing that, let me tell you one thing, that we will be having just two jump down parkour actions, so we don't need to create a new list for our jump down parkour action and then add them to the list and type all of that code. Okay, what we will do, we will just simply create a reference on the parkour controller script for the jump down parkour action. Okay, then we will attach that right there, and then we will perform this jump down parkour action. Okay, so first of all, right after the player script reference, let's create a serialize field. Okay, and this will be of type new parkour action, and let's name this as jump down parkour action. Then after this if condition, we will add another if condition, and in this one we will say that if player script dot player on ledge, it means that if the player is on ledge, okay, and also the player is not in action, okay, it means that if the player is not performing any parkour action, then what we want to do, we want to play the jump down parkour action. So first of all, we will need to set the player on ledge to false, so we will say player script dot player on ledge equals to false, since the player is not on the ledge now, and when the player is not on the ledge, we need to perform now the jump down parkour action. So for that we will say start coroutine, and then we will call the perform parkour action method, and as you know it needs a parkour action, so in the round brackets we will pass jump down parkour action, and that will be it. Then as you know that when the player lands, before landing, actually, so before landing we need to make the on surface bool of our animator, we need to set that to true. So in order to do that, click on the player script, and right here above this debug.log we will say animator dot set bool. We want to set the on surface bool, so we will say on surface, and we will set this to on surface. Okay, so if the on surface is true, then the animator on surface bool will also be true, and if it is false, then the on surface of the animator controller will also be false. Now if we save this, get back to Unity right here. Okay, as you know that now we need to provide the jump down parkour action, so what we're gonna do, we will just simply drag and drop our jump down action in there. Then let's go ahead and play the game. Let's now go ahead and test out our jump down parkour action, and when we play it you will notice that there will be a bug. Okay, because if we move, as you know, the player is performing it again and again, and now as you can see when the player jumps down the animation is playing perfectly fine, but if you notice there is this bug. Okay, so in the next video what we will be doing is fixing this bug in our jump down parkour action. Hello guys and welcome back. So in the previous video we have added our jump down parkour action, but now if you try to perform it, as you can see the player start jumping while on the obstacle as well. So we're gonna fix this issue with our jump down parkour action. So how we will fix that, let me tell you. So when we are on some obstacle, okay, then what we're gonna do is from the player feet, okay, in the forward direction we will check that how many distance are in between the player feet, or you can say the player and the ledge. Okay, so we're gonna measure that distance, and when the player keep coming close to the ledge, then we will deduct that ledge, and then from that ledge point we will jump down. Okay, so now let's go ahead and close the game and open up your text editor. and make sure that you open up the environment checker script. Then inside the checkledge method, after this debug.drawArray, let's create a variable by the name of surface raycast origin, and this will be equals to transform dot position. Then we will say minus, or actually we will say plus movement direction, then minus new vector 3. Inside the vector 3 x value we will pass 0. For the y we will pass 0.1f, and then for the z we will pass 0. Okay, so this will be our surface raycast origin. Okay, because we want to create a ray from the player position and then in that direction in which the player is looking. So for example, on top of the obstacle is a player. If the player is looking in the forward direction, then we will create it in the forward. Then if the player turns to the left or right, then in that direction we will create a ray to check for the ledge. Okay, so once we have the origin, let's create a raycast. So we will say physics dot raycast. Okay, then the raycast first of all need the surface raycast origin, and then after this we will say minus movement direction. Then we will store the information, so we will say out raycast hit actually, and then we will name this as surface hit. Okay, then we will just simply pass the length of this ray as 2, and then at the end we will pass the obstacle layer. Okay, and then what we will do, we will move all of this code inside this if condition. Okay, so once we have the raycast, now we want to measure the distance, or you can say the angle between the player and the ledge. Okay, so how we will measure that angle between the player and the ledge? We will simply take the player forward vector and the normal of the ledge. So let's go ahead and do that inside this if condition. When the ledge height is greater than the ledge height threshold, then in here we will say vector 3 dot angle. Okay, then in order to retrieve the player forward, we will say transform dot forward, and then surface hit dot normal in order to get the normal of the ledge. Okay, now in order to get this angle, or you can say in order to retrieve this angle from this check ledge, let's create a struct right here. For that we will say public struct, let's name this as ledge info. Okay, then in here what we will do, we will create a float by the name of angle. Then we want to save the height, so we will create a float for the height as well. Then after this we will create a raycast as well, so we will say raycast hit, and let's name this as surface hit. Okay, now let's go ahead and assign the angle height and the raycast. So in the check ledge right here at the top, we will create a variable by the name of ledge info. Make the I in info capital. Okay, then this will be equals to new ledge info. Okay, this is the struct which we created right here. So once we have that, now right here in order to assign the angle at the start right here, we will say ledge info dot angle, and this will be equals to this. Okay, then in order to assign the height, we will say ledge info dot height, and this will be equals to ledge height. Okay, then after this we will say ledge info dot surface hit, and this will be equals to the surface hit. And this surface hit, it is this ray cast, okay, right here. And this surface hit is right here in the struct, okay. So whatever information stored inside this surface hit will be passed to this surface hit, okay, which is in the struct, and then we can access these three anywhere. And let me tell you guys, in order to access these three anywhere in our project, what we're gonna do is we will return that three variables, okay, the angle, height, and surface hit. So in order to do that, right here at the top we will say out ledge info. Make sure the L is capital in this ledge info, okay, and we will say ledge info after that, but the L will be small. Then in here we will remove this variable from the ledge info, and then this will be equals to new ledge info. Now save the script, get back to the player script then, and if you scroll up right here in the check ledge, we have added the move direction. Now we need to add the ledge data as well. So first of all, let's go ahead and create a property for our ledge. So after this player on ledge, we will say public ledge info, and we will name this as ledge info as well. Okay, then we will say get, then set. After this, right here inside our check ledge, after the move direction, now let's also add the ledge info. So we will say out ledge info, then ledge info again, and then inside the if condition, when we say debug.log player is on ledge, now before this we will say ledge info equals to ledge info. Then after this, if we open up our Parkour controller script right here inside this if condition, we will now say if player script dot ledge info dot angle is less than equals to 50, then we will say player is on ledge false, and we will perform the jump down parkour action. Then if we open up the environment checker right here, remove this round brackets because we don't need round brackets when we are creating a struct, okay, and also make the h right here capital. That's it. Save the script, and if we get back to Unity, as you can see, it shows this error which shows ledge info does not contain a definition for surface hit, okay, which is on line 59. So on our environment checker, if we check the line 59 right here, as you can see, the H is capital, but if we see our struct right here in the struct, we type the H as small letter, so we will change it to capital H. Then what we will do, we will right here click on Parkour controller script, and now at the top right here, we will say input dot get button down. If that button is the jump button, then we will jump from the obstacle, okay. So now if we save the scripts and get back to Unity, play the game. Now let's go ahead and perform the parkour action, okay. So if we jump on top of this, as you can see, the player is jumping. Now if we get closer to the edge and if we press the jump button, or you can say the space button, the player will simply jump, okay, as you can see. Now if you go ahead and perform it again from this side in front, okay, so if you go ahead and press down the jump button, as you can see, the player is jumping down. And if we try to perform it from here, okay, so if we perform it, as you can see, the player is performing the jump down parkour action. But if you notice, when we are performing the jump down parkour action, we still have the controls. Okay, we can still move the player. If you notice it, as you can see, we can still move the player, okay, to the left right side. So we don't actually want that. When we are performing the jump down parkour action, we want the player controls to be false, okay. And also, if we get on top of the obstacle, okay, and now if we didn't press the jump button and try to move to the ledge, okay, you will notice it will show that the player is on ledge, but as you can see, the player is now not performing the parkour action. So in order to fix this, what we will do is whenever the player is on the ledge like this, okay, we will not allow the player to move in the forward direction, okay, because in many parkour games, if the player is standing on top of some obstacles, the player didn't jump automatically, okay. So we're gonna add that as well, and also we will stop the movement while performing the jump down parkour action in the next video. Hello guys and welcome back. So in this video we will be adding the ledge movement, in which when the player move to the ledge, okay, we will stop the player right there, okay. We will not allow the player to walk off the ledge like this. We will only allow the player to jump off the ledge using the space button like this, okay. And also there is one issue with our jump down parkour action, which is, for example, if we jump down, as you can see, the player has movement, okay. So what we want right here is when the player is performing the jump down parkour action, we will not allow any player movement, okay. So for that, let's first of all close the game, and let me tell you how we will achieve the ledge movement, in which we will stop the player when the player reaches the ledge. We can achieve this by measuring the angle between the normal vector of the ledge and the movement direction in which the player is trying to move. So for example, this red line is the normal vector and this blue line is the direction in which the player want to move, okay, and this circle is the player, and this box, okay, I mean this square is the box, and on top of the box the player is standing, okay. So if the player want to move in this direction, the angle between the movement direction and the normal vector right here will be less than 90, and when it is less than 90, then we will not allow the player to move in this direction. But if the angle between the normal vector and the movement direction is greater than 90, in this case we will allow the player to move, okay. So what this means, it will basically prevent the player from moving forward to the ledge, or you can say it will prevent the player from falling off the obstacle. The player can only move in the backward direction or to the left or right, okay. We will only allow the player to jump if the player presses the space button. Okay, so now let's go ahead and click on scripts, then click on player controller folder. Let's open up the player script from the folder, okay, and right here, right down below after this surface check, let's create a new method which will be by the name of player ledge movement, and inside this method we will create a float by the name of angle, okay. And as I told you, we will be finding the angle between the ledge normal and the move direction. So in here we will say ledge info dot surface hit dot normal, and then at the end we will pass the movement direction, okay. So once we have the angle, then we will say that if this angle is less than 90, okay, it means that if the player is now on the ledge, then as I told you, we will not allow the player to move, and also we will not allow the player to rotate us. Okay, so what we will do, first of all, right here at the top where we have the variable velocity, okay, let's remove this var from there, and then let's move right here to the top. After this movement direction, let's create a vector 3 and let's name this as velocity, because we will be needing to make the velocity 0 right here when the angle is less than 90 in order to stop the player from movement. Okay, so now we will say velocity equals to vector 3 dot 0. Now after this we need to make the movement direction 0 as well, but we can't directly make the move direction 0 right here, okay, because it will stop the player from rotating when the player is not performing any parkour action. So actually what we will be doing is, after this movement direction, we will create a serialized field. It will be of type vector 3 and let's name this as required move dir or move direction. Then if we scroll down to the movement direction method right here, we need to now apply the required movement. So now instead of this variable movement direction, we will say required movement direction. Then in here, instead of this movement direction multiply by movement speed, we will say velocity multiply by time dot delta time, and this move dir will now be equals to required move direction. Now let's go ahead and make the move dir to 0. So in the player ledge movement, first of all right here, now remove this move dir and instead of this type required move direction. Okay, and then after this let's copy this velocity equals to vector 3 dot 0. Now the move dir will be equals to vector 3 dot 0. Now if we scroll up and right here where we say if the player is on ledge, okay, now right here we will pass the player ledge movement method. And guys, make sure that on the parkour controller script at the end you added this input.get button down jump. Okay, we added this line of code in the previous video so that whenever we press the jump button or the space button, the player will then only jump from the ledge. Okay, so now let's go ahead and save all of this, get back to Unity, and I think on line 79 we forgot to remove the movement direction. So let's change this to move dir. That's it. If we get back right here and play the game, and now let's test it out. Okay, so if we climb on top of this obstacle, okay, and now let's try to jump down. As you can see, it now stopped the player from jumping down unless we press the jump button, as you can see. Okay, if we try performing it again, okay, as you can see, actually it rotates the player to the other side, but we will be fixing that, don't worry about that. But now, as you know, the player is not jumping automatically, so now let's try to press the space button. As you can see, the player is now jumping. Okay, so with this ledge movement added, now in the next video we will be stopping the player movement while performing the jump down parkour action, and also we will be stopping the player walking animation when the player is on the ledge. For now, if you notice, the player is still moving, as you can see when on the ledge, as you can see. Okay, and also the player is rotating, but don't worry, we will be fixing that and this walking issue as well. Hello guys and welcome back. So in this video we will be fixing two issues with our jump down parkour action. The first issue is that we still have the player movement when we are performing the jump down parkour action. For example, if we try to perform the jump down parkour action, as you can see, we can still move the player to the left and right and also in the forward direction. So we actually don't want that. In order to fix that, open up the player script, okay, and we will cut this from here, and let me paste this after this if condition. We will remove this move direction multiply by movement speed, and instead of that we will type vector 3 dot 0 and then paste that again right here and leave this as it is. Then after that, in the else condition, we will paste that once again, and let's change this to transform dot forward, multiply that by the movement speed, and let's divide that by 2. So what this basically means that if the player is on the surface, then the player will be able to move left, right, forward, backward, but if the player is falling, then we will not allow the player to move. Okay, save the script now, get back to Unity, and let's play the game. And now if we try to jump from this ledge, as you can see, we don't have player movement unless the on surface becomes true. Okay, let's try it again. So if we try to jump from this point, okay, as you can see, we can't now move the player unless the player reaches the surface. Okay, now we have another issue, which is, for example, if we move right there, as you can see, the player is rotating by itself and not facing the side which we want to face, and also on the ledge the player still has this movement, okay, this animation playing. So let's fix these two as well. So on the player script, if we see our player movement method right here, and in here we have this quaternion dot look rotation in which we pass the move dir. So what we will do in this if condition right here is that we will say move direction dot magnitude. If that is greater than 0.2 f, then we will set the required rotation to the move direction. Okay, save this, get back to Unity, let's play the game now. And now when the player is on top of the obstacle, and now if we move the player to that direction, as you can see, the player is now no more rotating and looking to every direction to which we want the player to look, as you can see. Okay, now the next thing which we want to fix is this movement animation. Okay, we want to stop this movement animation. So for that, on the player script, let's remove this animator.set float line, just cut it from there, and right here when the player is on the surface, let's paste it in here, and instead of this movement amount, now we will say velocity dot magnitude. And as you know that our movement amount is a float and its value will be from 0 to 1 and in points as well, and this velocity dot magnitude will not return a value from 0 to 1. So in order to make this velocity dot magnitude return a value from 0 to 1, we will divide this by the movement speed, and that will be it. And now before playing the game, make sure that you guys type this code, okay, above this velocity dot y equals to falling speed. Okay, make sure that this is down below this line. So now if you go ahead and open up Unity, and now let's play the game, and make sure that you save all of your scripts. Okay, now if we move towards our obstacle right here, let's perform the jump up parkour action. As you can see, it is working fine. And now if we move to the ledges, as you can see, the player is no more moving, and also the player can rotate as well. Okay, and now if we try to perform the jump down parkour action, as you can see, here is this next issue. Okay, so if we try to perform it, as you can see, it is performing that twice. Okay, if you notice, the player is actually stucking right there. Okay, and now if we try to press it again, as you can see, in the second time the player performed the jump down parkour action. Okay, so the problem right here is the player is not actually deducting the ledge fully. Okay, as you can see, the player deduct the ledge a little bit away from the ledge, as you can see. Okay, and now the player is actually on the ledge, and if we perform it, as you can see, it is performing the jump down parkour action. So we need to fix this. So it has a really simple fix. In the environment checker script, we have this check ledge method. Okay, right here when we set the ledge origin. Okay, in our previous videos we forgot to add vector 3 dot up right here. So make sure that you type plus vector 3 dot up in our ledge origin, and this will fix the issue. Okay, now if we get back to Unity again, okay, our game was playing. So let's stop the game and play it again. Okay, so now if we walk towards the obstacle now, okay, let's perform it. Now as you can see, the player is reaching the actual ledge, and now from here if we press the W and space button, as you can see, now the player is performing the parkour perfectly fine. Okay, if we try it again, as you can see, the player is performing the parkour perfectly fine. And if we perform it from here, as you can see, from here it is working perfectly fine as well. Hello guys, and welcome back. So in this video we will be fixing these small two issues. So the first one is that when we try to jump from here, as you can see, the camera goes inside this obstacle, as you can see. Okay, so we want the camera to not go inside the obstacle. And the second issue is that when we perform the jump down parkour action, the player still has control. Okay, in our previous video we tried to fix it, but we still have that problem. Actually, as you can see, the player can rotate to left and right. So first of all, let's close the game and click on our third person say machine, and right here in the collide against, we will say everything except the player. Okay, click on save. Now if we play it, and now let's go ahead inside the game, and if you notice, now if we try to move the camera inside the obstacle, as you can see, now it is colliding with this obstacle. Okay, so in this way you can do that and fix the issue. Now if we try to jump, as you can see, the camera is now not going inside this obstacle. Now after this, let's fix our second issue. So for that, first of all, in our scripts folder, then inside the parkour folder right here, we will create a new C# script by the name of control falling movement. Let's open this up, and this script will actually be a state machine behavior. Okay, and we will remove the start and update method from there. And now in order to control the player movement, or you can say the player control while performing the jump down parkour action, we will be adding this state machine behavior script to our animation, which is this one. Okay, in which the player land on the ground right here. If you notice, if we click on this add behavior, we now have this option which is control falling movement. Okay, this is the script which we created. So we will be now controlling the player movement like this. Okay, so now inside the script we will be typing code for controlling that. But first of all, on our player script, right here in the set control, we have this player control which is equals to has control. Okay, so if you check this player control, this is not a global variable. It means that we can't access this outside the script. So what we're gonna do, we will make this player control global. So for that, right here we will say public bool has player control. Okay, in here we will say get, we want to get the player control, then we will say set, and we will set it to the player control, and this will be equals to value. Then after this, on our control falling movement, we will create a on state enter. Okay, here is the suggestion, press enter. Okay, this is our on state enter. So in here what we will do, we will say animator dot get component, then we will say player script, then we will add round brackets, then we will say dot has player control, and we will set this to false. Okay, it means that whenever the animation is played, we will set the has player control to false. Okay, then after this we will say on state exit, and when the animation is finished, or you can say the animation is done playing, then what we will do, we will set this to true. So we will just copy that, paste it down below, and set this to true. Okay, and guys, if you are not getting the suggestion for this on state enter and on state exit, then you can type this as it is. And if you want to get the suggestion, then make sure that you are using Visual Studio Code, and also right here in the extensions you have this C sharp extension added, then this C sharp XML document and C sharp snip. Okay, you have these extension added. Okay, this is just an extra step, you don't have to do it, but if you want to get the suggestion, then make sure that you have installed that. Okay, so with this done, let's get back to Unity. Now, as you know that on this animation we already have added this script, so what we will do, we will now just simply play the game. And now if we go ahead and play this jump down parkour action, you will notice that we will not be having that issue again. Now if we jump, as you can see, the player doesn't have any movement. Okay, because of the camera we can't see it perfectly, but as you can see, the player doesn't move forward, not to the left and right. Okay, you can just test this out for your own. Okay, so as you can see, it is working perfectly fine. Hello guys and welcome back. So in our previous section we have completed our parkour action system. Now from this video onwards we will start working on our climbing system. Our climbing system will use the same code and the same methods as our parkour system. Okay, first of all we will be taking control away from the player, then we will be playing the animation, and while the animation is playing we are rotating the player, we are target matching, and then after that we give back the control to the player. Okay, so in the similar way we will be typing the code for our climbing system. Okay, so what we're gonna do now is, instead of typing all of this code again for our climbing control or climbing system, let's just make this code reusable so that we can use this for our parkour system and also for our climbing system as well. So what we're gonna do with this is, we will copy both of these methods, the compare target and then the perform parkour action. Okay, so copy this to from here, then click on the player script. Right here, after this on draw gizmo selected, we will give some space and then we will simply paste it like this. Okay, right here, make this a public method now, and also let's change the name to perform action. We will remove the parkour since we will be now using this for our climbing as well, so there is now no need for the parkour word right there. Okay, and also we will remove this parameter which is new parkour action, and we name it as action as well. We will be not needing this since we will be getting all the parameters individually, for example the animation name. And if I show you in Unity, okay, all of these parameters, the animation name, the tag, the minimum height, then maximum height, etc, etc. Okay, so in here, let's first of all create a parameter for our animation name. So we will say string, and let's name this as animation name. Okay, so once you create that parameter, you don't need the action dot right here. We can now just simply type the animation name as it is, like that. Then after this, we need the required rotation. So let me copy that, and right here we will say quaternion and then required rotation. Okay, and once you do that, remove this action dot from there. That is it. Then after this, we will change this look at obstacle. So if we click right here, now we will create a bool which will be by the name of look at obstacle, and by default this will be false. Okay, and once you create that, let's remove this action from there as well. Okay, and also right here, as you know that we have created a string for the animation name, so we don't need this action right here as well. Okay, so after this, if we check our compare target method right here, we don't need this action as well now, because as I told you, we will be now using this for our climbing system as well. So what we will do, we will create a new class for this compare target to store all the target matching parameters. Okay, so right down below this has player control, we have this curly bracket, and right down below here we will say public class, and let's name this as compare target parameter. Okay, and in here, first of all, we will be creating a parameter for our position. If we see right here in our compare target, we have the position, then the rotation, the body part, and then the start time and end time. So right here we will say public vector3, and let's name this as position. Then after this we will say public avatar target, let's name this as body part. Then after this we will create a vector3 for the position weight. So we will say position weight. Then after this we will say public float, and let's name this as start time. And then we will create another one which will be a float as well, and this will be the end time. Okay, now if we scroll up to the compare target, right here we will now remove this new parkour action from there, and instead of this we will type match, or actually compare target parameters, okay, which we created right here. Then we will name this as compare target parameter, okay. Then in here in the animator dot match target, first of all we need the compare position. So for the position we will type now just position, so compare target parameter dot position, okay. Then for the rotation we will leave this as transform dot rotation. Then for the compare body part we will say compare target parameter dot body part. Then after this, instead of this compare position weight, now we will say compare target parameter dot position weight, okay. Then we need the start and end time, so we will say compare target parameter dot start time. Then we will copy this, paste it right there, and change this to end time. That is it. Now let's go ahead and create a parameter for this compare target. So if we scroll up now to our perform action, now right here we will simply paste that, and now instead of this, okay, we will change the name of it so that you guys don't confuse it with this one, okay. So this time let's name this as compare target parameters, okay, CTP. Then what we will do right here, we will now remove this action dot allow target matching, and instead of this we will type CTP if that is not null. Then we will target match, so instead of the action now we will simply say CTP, okay. Now instead of this player script dot rotation speed, we will just type rotation speed, since we are already now on the player script, okay, and the rotation speed is right there, okay. So you don't need the player script or rotation speed right there. Now after this we need to create a parameter for our parkour action delay. So if we scroll up right here in the perform parkour action, what I will do is first of all I will press enter right here to see the code like this, okay. And then right here after this, look at obstacle. We will now create a float which will be by the name of, let's just say, parkour action delay. Let me actually copy this name, paste it right here, and by default this will be equals to 0f, or you can say just 0. Then if we scroll down now from here, remove this action. Now after this, if we check the top right here of the perform action now, if you double click on this player in action, as you know that we don't have any player in action rule on this player script, that is actually on our parkour controller script, okay, if you check it out, as you can see. So what we need to do is we will be actually removing this from here, okay, just cut it from there, then get back to the player script, and right here after this player control we will paste it, and now this time we will be making this player in action a property because we need to access this, or we will be needing this in our project in order to check if the player is in action or not. Okay, for example, we will be needing this player in action in our Parkour controller as well, since we cut this from here, and as you know it needs the player in action right here. So we will be passing this player in action from this player script to our Parkour controller script. Okay, so let's make this a property. So what we will do, we will say public bool player in action, then we will add the curly brackets, and in here we will say get and then private set. That is it. Now if we scroll down to our perform action right here, now the player in action will be true and false, and it will be storing inside this property. Okay, now after this we will be removing this set control from here, because not all of the parkour action, or you can say the climbing actions, would want to take away the control from the player. Okay, so what we will do, we will simply remove this from there and from down below right here. So now after this, if we get back to our parkour controller script now, right here, as I told you, now we will be using whatever is inside the player in action right here on the player script. Okay, this one. So what we will do, we will now at the start of this we will say player script dot player in action. Okay, we already have a reference for our player script right there. Then right down below right here we will also say player script dot player in action. Then in our perform parkour action, what we will do now is we will remove this player in action from top and from the bottom, and then we will remove all of the code in the perform parkour action. We will just leave these two. Then in here what we will do, we will say compare target params, or let's just name this as parameter. This will be equals to compare target parameters. Okay, and this will be by default equals to null. Then after this we will say that if action dot allow target matching. Okay, this is coming from our new parkour action right here, allow target matching, and as you know we have a reference for that right here. So action dot allow target matching. So if this is the case, then in here we will start the target matching. So first of all we will say compare target parameter equals to new compare target parameter. Okay, then as you know that this has properties right here. If you see it, the position, body part, position, weight, start time, end time. So let's assign that. So for the position, okay, we will pass the action dot compare position. Then after this, for the body part, we will pass the action dot compare body part. Then for the position weight, we will pass action dot position weight. So let me copy this from here and paste it right here. Okay, and at the end we actually need to remove that. Okay, remove the semicolon. And now after this, for the start time, we will pass action dot compare start time. Then after this we have the end time, so for that we will pass action dot compare end time. Okay, then right here add the semicolon. Then after this we will say yield return player script dot perform action. Okay, then right here we will say action dot, let me check right here. Okay, so action dot animation name. So we need to pass the animation name. Okay, we are passing the animation name, this one, okay, from our parkour action. Then after that we need to pass the compare target parameters. Okay, since at the second option it needs the CTP, so for that we will simply say compare target parameters. Then we will say action dot, now we need to pass the rotation, so for that we will say required rotation. Then we need to pass the rotate to obstacle, or actually it is by the name look at obstacle. Okay, and as you know that we have created a reference for this which is by the name of look at obstacle. Okay, the L is capital, so make sure that you type that right here. Then after this we need the action dot parkour action delay, since it needs the parkour action delay, as you can see. And after that we have nothing, so we will just now at the end add a semicolon right there to end it, and that is basically it. Now our code is reusable. Okay, we can now use the perform action both for our parkour actions. As you can see, we are now using it to perform parkour actions, and in the same manner we will be now using this for our climbing actions as well. And by using this you can add even more actions. Okay, for example sliding actions or whatever actions that are inside a parkour game. Okay, so now just simply save this. And now if we get back to Unity, let's now perform all of the actions. As you can see, the player can jump perfectly fine on these. Now let's jump right here as well, as you can see, and now let's climb this. As you can see, the player is climbing and also jumping down from this. Okay, so all of our parkour actions are working perfectly fine. Okay, and if you try to perform it right here, as you can see, it works as well. Okay, so now all of the parkour action works just as we created them in our previous sections. And now, as I told you, from this video onwards, now we will be working on our climbing system. So this was the first video for that. Now from the next video we will start adding some climbing actions. Hello guys and welcome back. So first of all I will say that don't judge my painting right here. Okay, this painting is just for your understanding. So in this video what we will do, we will detect the climb points. As you saw in the introductory video, if there is any climb point on which the player will jump, okay, we need to detect that climb point. So for detecting the climb point, what we will do is, for example, if this is our wall, okay, this circle, and on this circle we have this climb points, okay, you can imagine this as some bricks or some area to hold on in our environment, okay. And in order to detect this climb points, what we will do, from the player neck area we will create raycast in the upward direction like this, okay. And if that ray, or you can say any of that ray, touches a climb point, then we will detect that climb point, and then according to the height, or you can say the distance to that climb point, we will perform a jump up parkour action, or you can say a climb up parkour action, okay. So this was just a visualization. Now let's go ahead and do this inside our game. So first of all, let's say we will start climbing from this point, okay, or you can select any area inside the game where you want to perform the climbing. So what I will do here is, first of all I will select this gate entry, okay. And what we're gonna do actually is, let's just remove that. Let's create a empty game object right here, okay, and let's name this as climb points, okay. And then inside this climb points we will create a climb point. So if we click on this 3D game object and then click on this cube, okay, this is the cube. What we will do with this is, we will change the scale XY to zero point 0.1, zero point 0.1, or actually let's do 0.2, okay. And once you do that, let's move this. Actually let me control Z and let's select the whole climb point, okay, and let's move it right here, okay. Let's move it a little bit down below so that it matches this area, okay. Let's move it inside, okay, and let's move it a little bit up here, okay, like this, and then make sure it matches this area fully, okay, like this. And when it matches this area, what we're gonna do now is select our cube and let's name this as point 1, and then we will disable the mesh renderer, okay. Or for now we can actually enable it so that you guys can see what is happening with this point 1, okay. Then what we will do is, we will create a different layer for this, okay, just as we did for our obstacle. So let's create a layer by the name of climb, okay. You can name this whatever you want, but we will keep it simple. So select climb on this point 1, and right here actually guys, let's change the scale of this to 1.2, okay. We want it a little bit wider like this, okay. And let's move it a little bit to this side so that the player don't touch with this thing, okay. I think right here it will be perfect. So once you created this climb point, now let's go ahead to the scripts folder, and right here we will create a new folder. Let's name this as climbing system, okay. And inside this climbing system we will create a new C# script by the name of climbing controller, okay. Let's open this up, and before working in this climbing controller, what we will do, as I told you, we will first of all detect the climb point. Okay, and in order to detect things, for that we have a separate script, which is the environment checker. Right here we check for ledges, and we also check for obstacles. So now what we're gonna do right here, we will also now check for climb points. Okay, so after this check ledge, we will create a new method for checking for the climbing points. But first of all, we need some variables. So what we're gonna do right here, we will create a header, and let's name this as climbing check. And inside this climbing check, what we will do, we will create a serialize field. Whoops. Okay, serialize field. This will be a float, and let's name this as climbing ray length. Okay, let's make the L capital right here, and this will be by default equals to 1.6. Okay, then after this we will create another serialize field. This will be of type layer mask. I don't know why it is printing this private with it. Okay, with our serialize field. Okay, so it will be of type layer mask, and let's name this as climbing layer. Okay, just as we did for our obstacle layer, we will name this in similar manner. Now after this, let's go ahead and create a method for this. After this, check ledge. Okay, let's say public bool, and let's name this as climbing check, or let's just say check climbing. Okay, because if we see our other methods, as you can see, we say check ledge and check obstacles, so we will name this as check climbing. Okay, and this will require two parameters. The first will be of type vector3, and this will be the direction. Okay, because we will be needing the direction in order to create raycast in that direction, okay, in which the player is looking. And the next one is the raycast. So we will say out raycast hit and climb info. Okay, now in here what we will do, we will say ledge ray length. Actually, not that, we will say climb info, and this will be equals to new raycast hit. Okay, then after this we will say that if the direction, or you can say the dir, let's actually name this as direction, so we will click on change all occurrence. Okay, it will change both of that in the at the same time, but let's select the first dir if you don't have that option, and let's change its name to climb direction. Okay, and copy that, paste it right here. Okay, so if the climb direction is equals to vector3 dot 0, then what we will do, we will simply say return false. Then after this, now let's go ahead and create a climb origin. So we will say variable climb origin. This will be equals to transform dot position. Okay, and as I told you in the starting of this video that we will be creating a ray from the player neck, but now as you know that we use this transform dot position, And if we check our player, I think the ray will be now created from this middle point, okay, because right here is the player main body connection part, okay. So transform dot position, now as I told you, we will be creating rays in the upward direction, so we will say vector 3 dot up, and let's multiply that by 1.5 f. Then after this we will create an offset for this, so you will say climb offset. This will be equals to new vector 3. Okay, for the x let's pass 0, for the y let's pass 0.19, and for the z we will pass 0 as well. That is it. When we have the offset, now let's create arrays. Okay, we will not be creating one ray as I told you, because in our game the climb point will be a little bit higher from the player height, so that's why we will be creating multiple rays. Okay, so for that purpose we will create a for loop. But first of all, let's go ahead at the top and right here let's create a public integer by the name of number of rays, and number of rays by default will be 12. Okay, we will be creating 12 rays in the upward direction. Let's copy this name. Now let's get down to the for loop, and what we're gonna do, we will create an integer by the name I, and this will be equals to 0. Then we will say that if this I is less than the number of rays, it means that if not all of the 12 rays are created, then what we're going to do, we will create, so we will say I plus plus. I hope you know this simple programming. Then in here, now let's actually create the rays. So in order to create it, we will say physics dot raycast. Let's pass the climb origin, so we will first of all pass the climb origin. Then after this we will pass the offset, so let's pass the climb offset. Then we will multiply this by I, okay, and then we will pass the climb direction, and after this we will store the information of whatever this ray hits, so we will say out raycast hit, okay, and then we will name this as hit. Then we will pass the ray length of the climb, okay, so climbing ray length is its name, so we will pass that right here. Then at the end we will pass the layer, so we will say climbing layer, okay. And what we're gonna say in the start, if we are detecting any climbing point, then what we will do, we will store whatever this ray hit inside our climbing info, so we will say climb info equals to hit, okay. Then we will say return true. That is it. And if we don't detect anything, then at the outside this for loop we will simply say return false, okay. Now after this, let's get back to our climbing controller script, and now let's call that method right here. So what we're gonna do, we will create a reference to our environment checker script, so we will say public environment checker, and this will be equals to environment checker, okay. And after this, what we will do, we will create a update method, okay. If you want, you can remove that summary, and if you don't have that summary, then just leave it as it is, okay. In here we will say that if input dot get button down, or let's just say get button, because we don't want to press the button again and again, or let's just actually change it to get button down, since we will be pressing it when we are performing the climbing actions. Okay, so if the jump button is pressed, or you can say the space button, and guys, if you are confused where this button is coming from, then if I show you the edit project settings, then input manager, right here we have this jump button automatically set inside Unity, which is the space button. Okay, so if the space button is pressed, then we want to check for the climb points. So we will say if the environment checker dot climb check, actually it is check climb. Okay, so if you see it right here, it is check climbing. So copy that, paste it right here. And as you know that it needs two parameters. The first one is the climb direction and then the raycast. Okay, so for the direction, we will simply say transform dot forward, and then for the ray, we will say out raycast hit. Let's pass the climb info. Okay, and then in here, when we found any climb point, we will say climb point found. Okay, and now if you get back to the environment checker, we need to show these number of rays. Okay, so in order to show these rays, what we will do right here, we will say debug dot draw ray. Okay, we will pass the climb origin, and then we will say plus climb offset, and then we will multiply that by I, and then we will pass the climb direction. So climb direction, that is it. And after this, if we notice this line 79, let's add a semicolon right there because we forgot to add it. Okay, we have these three variables right there, and I noticed this thing that we created this as an integer, this number of rays, but at the end we type f. Okay, make sure that you remove f because this is an integer. Okay, and once you do that, save the script, get back to Unity, and then if we click on the player, let's see the environment checker script. Okay, right here we need to provide the climbing layer, so let's pass the climbing layer. We have the number of rays set up, and I think that is it. Okay, we are ready to test this out, but let's just test it out. I think it will show an error because we didn't pass the environment checker script to our climbing controller script. Okay, for example, if we try to, oops, I think the surface layer is not attached there. Okay, but let's just first of all test it out. If we press the space button, okay, right here, as you can see, the rays are not creating since the environment checker script is not attached to our climbing controller script. Okay, this I'm talking about this thing. Okay, so what we will do actually right here is that we will remove this public from there. Then after this we will create a awake method, and in this we will say environment checker equals to get component, and we want to get the environment checker script, so we will say environment checker, and that is it. Okay, Now let's go ahead and select this area, and to this let's add the surface layer. Okay, yes, change children. Okay, and also make sure that to the point 1 you added the climb layer. Okay, and that climb layer is selected right here in the climbing layer. And after this, let's drag and drop our climbing script right here after this parkour controller script. And when you do that, let's now go ahead and play the game. And when we play the game, and now if we try to press the jump button, okay, as you can see, you can notice these rays right there. Okay, we can't see the rays because we are pressing the jump button again and again. So in order to fix this, let's now actually use just get button. Okay, remove the down keyword from there. Okay, and now if we play it again, let's now press the jump button. Now you can notice there are the 12 frames coming from the player point, as you can see from the player up a little bit down below from the neck. Okay, because we set the offset, okay, for the raise, and the offset is right there in the neck, I mean a little bit down below from the player neck position. Okay, that is the reason why we created a offset for our climb raycast. So now if we go ahead on top of this, and now right here if we press the jump button, as you can see it is not detecting it since the rays are a little bit inside the house. So if we move down a little bit and let's get right here, as you can see now it is showing that climb point found. Okay, as you can see right here, climb point found. If we press the jump button again, as you can see it is showing climb point found. Okay, so in this way you can detect the climb points. Okay, now the last thing which we want to do is to give another color to our rays because we can't see the white color. Okay, so right here at the end we will say color dot red. Okay, I have copy and paste that from here, color dot blue, so you can just paste that right here and change it to red. Okay, and once you do that, let's click on the player right here. Let's increase the width of this player a little bit because it is too small, so we will change this to 4. Actually, let's change it to 3, and I think that will be it. So now if we play it again, now let's try press the space button. As you can see the rays are creating, and if you try to increase the number of rays to, for example, 20, as you can see now there are even more rays. So you can set this number of raise values according to your own need. And now with our climb point deduction ready, let's end this video right here. Hello guys and welcome back. So in the previous video we added a code to detect the climb points. Now in this video we will be performing the jump to climb point parkour action. If we get closer to this climb point and press the space button, as you can see it shows that climb point found. Okay, and now when the climb point is found, let's now perform the jump to climb parkour action. So for that, first of all, we will be needing animations. So on the miximo.com, first of all, make sure that you have uploaded your character and then search for hanging idle. And right here you will find this idle to pressed hang and then this hanging idle animation. Okay, these two. So let's select the first one. As you can see, the player is jumping to the climb point. Okay, so let's go ahead and download this without skin, and then FBX for Unity, click download. After downloading this, let's select now the hanging idle. So when the player jumps to the climb point, then at that point the player will be like this. Okay, so let's click on download. The settings will be the same. Okay, so once this is downloaded, we can now use these animation for our parkour action. But let me tell you guys that if you search for hanging idle and if you can't find this animation, then as you know, this is the animation name, idle to braced hang. So you can just simply search right here that idle to braced hang, and when you click enter, as you can see, you will find this animation right here. Okay, the second one actually, or the first one as well. Sorry, the second one is free hang to braced. I think it is the first one, because if you notice the name idle to braced hang, then this is the animation. Okay, so make sure that you download these two. Then in the animations folder, what we will do, we will create a new folder by the name of climbing animations. Let's double click on it, and in here we will drag and drop these two. So let's drag and drop them right here. Okay, and once you add them, now let's click on the rig of the first one, hanging idle. Let's change the animation type to humanoid avatar to copy from other avatar, and then select the main mesh right there, click apply, and if you click on animation, drag and drop our player in there, as you can see, it is playing the animation perfectly fine. Okay, after this, if we select the second one, let's do the same for this one, humanoid, copy from other avatar, and select the main mesh in there, click apply, and then if in the animation, if we drag and drop the player, as you can see, this is the animation. So what we will do now is select it again, and let's stop this rotation. As you can see, the player is rotating, so for that we will click on this root transform rotation back into pose and set this to original, then click apply. If we select it again, as you can see, now there is no more rotation. Okay, so once you do that, now the next step is to now perform the climb up parkour action. So for that, let's open up our text editor. Right here we have this player script. Okay, and in this player script we have this perform action method in which we perform a different type of actions. Okay, but for our climbing action, what we will be doing is we will be creating a separate method, or you can say a separate function for that, because in our climbing system we will be having different type of climbing actions. Okay, for example, the ledge to ledge jump and the shimmy actions, etc, etc. Okay, so that's why we need a different function for that. So on our climbing controller right here, when we found a climb point, okay, then right here we will be performing the climbing action now instead of debugging this. So what we're gonna do, as I told you, we'll be creating a separate function. So right here, what I will do, I will create a enumerator type function. Okay, and let's name this as climb to ledge. Okay, and this climb to ledge will require animation, so we will say string animation name. Then after this, it will need a climb point transform. Okay, or you can say the ledge transform. So right here we will say transform, and let's name this as ledge point, or you can name this as climb point. Okay, then after this we will say float. Now, as you know that we will be also target matching. So for target matching, first of all we need the start time, so we will say compare start time, and after this we need the end time, so we will say compare end time. Okay, now in here we will create a reference to our compare target parameters in order to pass these parameters. So what we will say in here is first of all, we will create a variable by the name of compare parameters or params. This will be equals to new compare target parameters. Okay. Now in here, it first of all need the position, body weight, position weight, start time and end time. So for the position, we will say ledge point dot position. Okay. Then after this, for the body part, so body part will be equals to avatar target dot right hand, and the reason we are passing the right hand is because if we see our jump animation right here, okay, as you can see, when the player jump, both of the hands are, as you know, will be holding the ledge point, or you can say the climb point. Okay, so as you know that we can't use both of them, but we will only use the right hand, or you can type left hand right here as well if you want. Then after this, it needs the position weight, so the position weight will be equals to vector 3 dot 1, and the reason we are using vector 3 dot 1 is because we want the xyz of this action to be equal. Okay, then after this we will be needing to provide the start time and end time, so we will say start time equals to compare start time, and then end time, so we will say end time equals to, whoops, okay, so end time will be equals to compare end time. Okay, now right here we will add a semicolon, and now when the player is performing the parkour action, then we want the player to look at the point, okay, the ledge point. So what we will do, we will create a variable right here by the name of required ROT or rotation, and this will be equals to quaternion dot look rotation, and in here we will pass minus ledge point dot forward. Okay, then after this we will say yield return, and now we want to return the animation and these compare parameters and this required rotation to our player script function or method, which is by the name of perform action, and as you know it needs the animation name, the parameters, and then the required rotation. Okay, it also needs the look at obstacles and parkour action delay, but as you know that we don't have that in this, so for now we will just return that. So first of all, let me add a reference right here to our player script. Okay, so what I will do here is I will say public player script. Okay, and let's name this as player script as well. Then if we scroll down, now in here we will say player script dot perform action. So let's copy that, paste it right here, and now let's pass the animation name. Then let's pass the compare parameters. Then let's pass the required rotation, and at the end we will pass true. As I told you, we need to provide this look at obstacle as well. So as you know, it is by default false, but right here we will pass true simply because we want the player to look at the point when performing the climb up parkour action. Okay, so once you do that, the player will now jump to the ledge. Okay, but there are two things missing. The first one is we didn't set up the animations, and the second one is that when the player jumps to the ledge, okay, then what we want to do, we don't want the player to perform any kind of movement, and also we don't want to apply the gravity, because if you do that the player will simply gets down to the ground. Okay, when the player climbs to the ledge, from there we only want the player to jump to more ledges and perform more climbing actions. Okay, so when the player is hanging, we will not be doing anything. So for that, right here on our player script, after this player on ledge, let's go ahead and create a property by the name of player hanging. Okay, you will say get set. Then when the player perform the climb to ledge parkour action, we will say player script dot player hanging equals to true. So when it is true, now on our player script right here, we will say if player is hanging, then we don't want to do the other things, we will just simply return from here. Okay, now after this what we want to do is to set up the animation, since we have function now to perform the parkour action. But I have noticed right here that in the position we didn't put the O, so make sure that you add that O right there. And if you save this, get back to Unity, as you can see it is showing this error which is saying that the compare target parameter does not contain a definition for position. Wait, I think we spell wait on our climbing controller wrong. WIGHT. Let me check the player script. WIG. Okay, right here we need to remove this T from there and add it at the end. Okay, we spell that on our player script wrong. Okay, now we need to change this on our other script where we use this compare target parameters. So on the parkour controller script right here on the line 56, we have this perform parkour action. Right here we need to then if you notice we need to change it on the player script 164 line as well. So player script 164 right here, just remove the edge from there and add it at the end. Actually it was correct right there. Okay, so get back, if we scroll to the right side right here we need to change it. Okay, WEIGHT. Okay, position wait, and once you do that all of the errors are fixed now. Okay, and guys, it is a reminder for you guys as well, so make sure that you name your words correctly. Okay, so now as I told you we need to add animations. So what we're gonna do right here is let's create a substate machine. Okay, you can name this whatever you want, but I will name this as parkour actions, or you can say parkour animations or parkour actions, animations, and in here we will put these parkour actions, okay, all of them. So oops, let's select all of them like this and just simply drag and drop this in here, okay. And once you do that, as you can see, all of the transactions are in its place, as you can see. Now if we get back right here, okay, inside the parkour actions, let's move all of them. Okay, so wall jump 1, wall jump 2, then we have the jump up, then we have the high jump up. Okay, let's move this base layer up there. Then we have the end, then we have the entry right there. Okay, so make sure that you fix these as well like this so that you understand it correctly. Okay, let's move it in the center and let's move this one right here and this one right there, and the end state will be at the top. Okay, so once you do that, after that we will leave this as it is since it is not acquiring more space. Now after this we will create a substrate machine for our climbing animations. So let's name this as climbing animations. Double click on it. Let's move the entry right there and move these right there, and the end state will be right there. Okay, now let's add our second animation first of all. Okay, so which is this idle to paste hang. Let's add that. Now let's change the name of this from idle to praised hang to idle to climb, for example, and then you can leave this one as it is. And if you want, you can just change this to, for example, hang idle or something like that. Okay, so now make sure that you remember your animation name right here, idle to climb. Now if we get back to our climbing controller right here, when we press the jump button, now we want to perform that animation. So now we will say start coroutine, and in here we will call this climb to ledge function in there. Then it needs first of all the animation name, so for that we will now type this idle to climb. So idle to climb, then after this we need to pass the ledge point, so for that we will say climb info. Okay, then dot transform, and if you guys hear any blast, okay, I think the children are playing with fireworks outside my house because our Independence Day is coming. Okay, so anyways, after this we need to pass the start time and end time for our target matching. So let's check our start and end time. So if we select our second animation, let's play it. Right here, when the player is moving hand in the air, okay, from this point when the whole hand of the player is open up, okay, so from 40 to 42, okay, then let's move forward. Then when the player right here touches the climb point, as you can see, the player kind of move the hand a little bit forward in order to hold the point. Okay, so from, let's just say from 0.40 till 54. Okay, So once we pass this values, our player will be now able to perform this. But first of all, what we want when the player is performing this climbing animation, what we want the control of the player to be false. Okay, we don't want the player to move to the left, right, forward and backward direction. Okay, we want to disable the movement keys. So for that, what we're gonna do, we will say player script dot, let's check the name, it is set control, so we will say set control, let's pass false to it, that's it. And also, as you know that when the player is on the ground and press the jump button, okay, then we will be performing this idle to climb action. Okay, and when we perform it, then the player is hanging. Okay, this player hanging property will be true. Okay, so what we want to do right here is we only want to perform this idle to climb when that property is false. Okay, if it is already true, then we will be able to understand that yes, the player is already hanging. Okay, and then after that, if the player perform the jump, I mean the player presses the jump button again, then after that we will be jumping from ledge to ledge. Okay, we will not be performing this idle to climb again and again. Okay, so what we will do right here, we will say if player script dot player hanging is not true. Okay, it means that if the player is not hanging to any point, then we will make the player hang to a point, and if the player is already hanging, then right here we will type a code for our ledge to ledge parkour actions. Okay, and also we want to make sure that the player is not in action. Okay, the player is not performing any other parkour action when we are performing this climbing action. So for that, what we're gonna do is we will say if the jump button is pressed and also the player script dot player in action is false. Okay, and get back to Unity. Now if we try to perform our parkour action, you will notice that there will be a issue with it. So if I show you, as you can see, there is an issue with our animation. So in order to fix this, what we will do, if I show you the animator first of all right here, okay, if you click on this transition right here, when the player jumps, as you can see, you can notice the player hand, but when the hanging idle is played, the player hand, as you can see, moves a little bit up. Okay, so what we're gonna do, we will select our first hanging idle animation, and first of all make this loop time loop pose. Okay, and make the position y of set as 0.4. Okay, as you can see, it moves the hanging idle animation down below, and the reason I know the exact value 0.4, I tried changing the values and the 0.4 value matches this. Okay, so just change the position y value to 0.4 and then click apply. Then after that, the second issue was that this animation was playing fully, and then after that it was transitioning to the hanging idle, as you can see right here. Okay, so what we will do from our second animation, okay, which is this idle to placed hang, we will actually trim it. So let's trim this to 20. Okay, make the end time as 20 and make sure that you selected this bake into pose. Okay, then click apply, and once you do that, Now what we will do, we will simply click on game and let's play it. Now let's go ahead and try it out. Now, as you can see, it is looking perfectly fine, and if you notice, the player hands are now down below and it is matching that area. But if you notice, there is still a little bit issue. The player is on the left side, and also if I show you the scene view, okay, you will notice that the player hands are still outside, as you can see. Okay, so there is the escape. So what we're gonna do, we will add some offset. So before setting the offset, first of all, we need to move the forward vector of our point in the forward direction. For now, if you notice, our forward vector is on the right side, okay? And if you check the climbing points, which is the main game object, its forward vector is on that side. So that is why this vector is on that side as well. So what we're gonna do, we will simply delete this, okay? And make sure that you delete this as well. Then what we will do, we will create a empty game object right here. Now as you can see, the forward vector is on that side on the left. Okay, let's name this as climbing points again. Then we need to move the forward vector in the forward direction. So we will change the rotation y to -90, and as you can see now it is in the forward direction. Then what we will do in here, we will create a 3D cube again. As you can see here, it is, make the scale x as 1.2, the y will be 0.2, and the z will be 0.2 as well. Now as you can see, the forward vector is in the forward direction, okay, and this forward vector needs to be in the forward direction, okay. I will be telling you why, but first of all, let me move this right here now, and let's first of all set this up correctly. Like this, okay. The point should be covering the area like this, okay. So when you do that, then make sure to the new climb point, you name it as point as well, just point, okay, and change the layer to climb. Now as you can see, the forward vector are in the forward direction. Now if we go ahead and play it again to make sure that the player is jumping to this point or not. So as you can see now the player is jumping, but now we need to add the offset as I told you. Okay, so in order to add the offset right here on our climbing controller, what we will do, we will create a public float. This will be by the name of in out value, and as you guessed it by the name, this float will move our player in and out on the climb point, okay. And what we're gonna do, we will leave this as it is, since this values will be changed for our other climbing parkour actions, okay, so we can't set it right here. Then we will create another float which will be by the name of up down value, then the last one will be by the name of left right value. That is it. Then if we scroll down, after this climbing to ledge right here, let's create a vector 3, okay, and name this as set hand position, and then right here we will say transform ledge, okay. To this transform ledge we will pass our ledge point, okay. But first of all, let me add the curly brackets, and now let's go ahead and pass it. So now right here, instead of this ledge point dot position, we will say set hand position, and let's pass the ledge point to it, okay. Now right here, what we will do now is, first of all, we will say in out value equals to, for now let's equal it to 0. The up down value will be also 0, make sure that you add f because this is a float, then the left right value will also be 0. Okay, then let's set the offset, so we will say return then ledge dot position plus ledge dot forward. Let's multiply that by the in out value, then we will say plus vector 3 dot up. Let's multiply that by now the up down value. Okay, then we will say minus ledge dot right, and as you guessed it, we will now multiply that by our left right value. That is it. So now when we change the in out value, our player will move in and out, or you can say forward and backward. Then the up down value will move our player up and down according to the climb point, and then the left right value will move our player to the left and right of the climb point. For now it is 0, so the result will be the same, but let me show you how it will look. Okay, so if we play the game and let's try to jump, as you can see the result is the same. Okay, now what we want to do right here, in order to set the offset, we first of all need to move the player inside. Okay, then we want the player to be a little bit right here on the right side to make sure that the player is in the center of the climb point. Then we need to move the player a little bit downward like this. Okay, so if you notice now the player looks good. Okay, we need to move it a little bit outside so that the finger doesn't go inside the climb point like this. Okay, so now as you can see it is looking good. Okay, so now we need to set values in order to make the player look like this. Okay, so on our climbing controller script, if I change my in out value to minus 0.23f, up down value to minus 0.09f, and left right value to 0.20f, okay, if I make my values like this, then my player will look good. Okay, and the player hand will be on the ledge point. Okay, and let me tell you guys that these values might be different for your game, so try changing these values and set the player hand position according to the ledge point. Okay, and if you don't know how to set these values, just simply change these values, go ahead and test the game. Okay, if you want to move the player inside, then you need to make this value in the minus. Okay, just as I did right here, and then for the up and down and for the left and right. Now if I go ahead and play the game, okay, and let's try jump right here. As you can see now the player hands are in perfect position, if you notice it right here as well. Okay, so the player hands are looking fine, and as I told you, you can set these values according to your own game. If I play the game again, okay, let me show you again. If we try to jump, you will notice that our player is a little bit on the right side, so we need to move the player to the left side. So what I will do, I will get back to my controller script, and right here I will change this value from 0.20 to 15. Okay, and when you change that, save it, get back right here. Now you will notice our player will be in the center. Okay, so now if we try to jump again, now as you can see the player is in the center. Okay, so in this way you can change your own values as well, and once you find the perfect value, then that is it. Okay, so with this done, I will end this video right here, and in the next video we will be adding our climbing web. Okay, in which the player will have information that from which climb point to jump to the other one. Okay, we will create some climb points right here, okay, on this whole building, and we will connect all of that climb points. Okay, so see you guys in the next one. Hello guys and welcome back. So in this video we will be creating a climbing web, or you can say a climbing system, in which the player will be able to jump from one ledge to another. Okay, so in order to allow the player to jump from one ledge to another, we need to add information to each of our point, or you can say our ledge. So for example, if this is our first ledge, then on this ledge we will be having a script in which we will be giving the direction to our next ledge. Okay, there will be also more information about that ledge, that what is the connection type, if the connection type is jump or move. Okay, because as you saw in the introductory video, we have a lot of climbing edges on which the player jump on each of them one by one, and also there are moving ledges as well on which we perform the shimmy actions. Okay, but for now in this video and in the next, we will be adding our jump type climbing actions. Okay, so first of all, right here in the climbing system, let's go ahead and create a script by the name of climbing point. Then select the first point and simply drag and drop this script right here at the top. Okay, and once you do that, let's double click on it to open it in your text editor. Now let's remove the default code, and after our main class, which is climbing point, right down below we will create another class which will be by the name of neighbor, and in here we will now define some variables. Okay, and that variables will be our data about our climbing points. So first of all, we will be creating a type climbing point variable which will be by the name of climbing point as well, and to this climbing point reference we will add our climb point. Okay, then after this we will create a vector 3, actually a vector 2. Okay, that will be by the name of point direction. Okay, and this will be the direction to the next climb point. Okay, if the climb point is on the left side or on the right side or up or down. Okay, so this will be that direction. Then after this we need to create a connection type. Okay, as I told you, we will be having two type of connection point type, actually connection type, not point. The first one will be jump, the second one will be move. So right here let's create a enum for that by the name of connection type. Okay, and the first one will be jump, the second one will be move. Okay, so now right here we will say public connection type. Let's name this as connection type as well. Then after this we need to create a boolean in which we will know that if the connection is two-way or not. And I mean by this, if the connection is two-way, then the player can jump to the next climb point and also jump down from that climb point to the previous one. Okay, so we call that a two-way connection. Okay, so let's create a bool by the name of is point two-way. This will be equals to true. Okay, so once you create these variables right here at the top, make sure that you type system dot serializable. Okay, and the reason we type this is we want to show these variables in our inspector of the climbing point script. Okay, so if you save this and get back right here, for now you will not see the variables, because as you know that we will be having multiple connections on our climbing point, so we need to create a list which will be of type neighbor. So right here now in our main class, let's create a public list. Okay, in here we will say neighbor, and let's name this as neighbors. Okay, and the reason we name this as neighbors, because as I told you, we will be having multiple neighbors, or you can say multiple connection on each of our climb point. Okay, so if you now save the script, get back right here. Now on our climbing point we have this neighbors list. If you now click on this plus, as you can see, one neighbor is added, and now it needs the climbing point, the direction, the connection type, and if the connection is two-way or not. Let's make this connection two-way. Okay, and now what we will do inside our climbing system, we will create a new folder by the name of prefab or prefabs, and in here let's drag and drop our point right there. Okay, now we can make more connections. Okay, or you can say we can now create a climbing web. Okay, so after this first point, let's add our second point. Okay, let's move our second point to this position, and let's set this up correctly. Okay, so if we move it right there, then let's move it in the backward direction like this. Okay, so our player will jump from here to that position. Okay, and then from here we will make our player jump to the left side. Okay, we want to cover all of the sides, so let me actually now duplicate this simply, and let's move this right here. Okay, this will be our third point. Then we need a fourth point, so let's duplicate it and move our fourth one right there. We need to set it up, okay, right here on this window. So if we move it to the center like that, let's move it a little bit up, okay, just a little bit, and then let's set it right like this. Okay, so this will be our fourth one. Then from here our player will move to the right side. Okay, so let's create another one. Let's move it right here. Okay, and we need to set this up as well, so let's move it outside like that, and let's move it a little bit up here. That is it. Okay, so all of them are set up. Okay, and all of them will be two-way. Now we need to create a one-way connection as well. So if we select our last one, from here the player will jump to this position, and then from here the player will not be able to jump down. Okay, right here then we will add shimmy actions. Okay, so what we will do, we will duplicate this, move it right here. Okay, let's move it outside, then up right here like this, and that is it. Okay, so this last one will be a one-way connection. Okay, so now let's join them. So let's start from the first one. Okay, just make sure that you follow me step by step right here, or else you will end up messing all of these connections. Okay, so now as you know that our connection from this point to the next one is in the upward direction. So what we're gonna do, we will select the first point right here to the first point. We will drag and drop the second point in here in the climbing point, and then since it is in the upward direction, we will make the y 1. Okay, and this will be of connection type jump, and this will be a two-way. Okay, so the player will know that from here the player needs to jump to that point. Okay, and let me tell you about this point direction. If you want the player to jump in the upward direction, then make the y 1. If you want the player to jump down, then make this -1. And the same for the X. If you want the player to move to the right, make it 1, and if you want the player to move to the left, make it -1. Okay, simple as that. So we have created our first connection from this first one to the second one. Okay, let's now create a connection from this second one to this third one. As you know, this third one is on the left side, so we need to make the X now -1. Okay, the Y will be 0. And also to the second one we need to provide the third one right here in the climbing point. Okay, and leave everything as it is. Now let's select the third one, and right here the third one is right down below this one, so it should be a jump up. Let me actually move it a little bit right here. Okay, so to this third one we will first of all add the fourth one connection, I mean the climbing point right there. Then, as you know, it's in the upward direction, so make Y1 and leave everything as it is. Then let's select our fourth one. If you check the fourth one, as you know, the fourth one is on the left and the fifth one is on the right. So on the fourth one, we will now make the X1 since it is on the right side, and drag and drop our fifth connection in there. Okay, then if we select our fifth, as you can see, the sixth one is right there in the upward direction, so we will first of all add the sixth one, then make the Y1, and that will be it. Okay, and since this is a one-way connection, so we don't need to add the connection down below. Okay, so once all of these are set up, now you guys will be thinking that now we only added a one-way connection. Okay, so for example, if the player jump from this first point to the second, and as you know that this is a two-way connection, so you will be thinking that how the player will now jump from the second one back to the first one, because as you know that on the second one we only move to the left side, okay, not right down below. Okay, so we need to add a connection back to our first one. Okay, and of course we can't do that manually one by one because that will be a really lengthy work. Okay, so what we're gonna do is we will type a code for this, and that code will be like this. If we added a first connection, then the second connection will be added automatically. Okay, so for example, we added our first connection from this first point to the second, then from the second point we will automatically add a connection back to the first one. Okay, so let me tell you now how we will do that. Right here after this list, let's go ahead and create a new function by the name of create point connection, and this create point connection will need some parameters in order to make the connection back to the previous one. Okay, so the first one will be of type climbing point, and let's name this as climbing point. The next one will be a vector2, which will be by the name of point direction. Okay, I am naming them similar to these one. Okay, but these two are different. Okay, these are the parameters of this create point connection. Okay, so after the vector2, the next one will be of type connection type, and let's name this as connection type as well. Then the last one will be of type pool by the name of is point two-way. Then we will add curly brackets, and in here let's create a neighbor. So we will say variable neighbor. Okay, not neighbors, just neighbor. This will be equals to our neighbor class right here. Okay, and as you know that in our neighbor class we have now these variables. So now let's assign the climbing point to this climbing point. Okay, so we will say climbing point equals to climbing point, then the point direction of our neighbor class will be equals to the point direction of our function, then connection type will be equals to connection type, and is point two-way will be equals to is point two-way, and make sure that you remove the semicolon from the end. I don't know why I add that. Add semicolon right here after this curly bracket. Okay, so once we assign the values at the end right here, we will say neighbors dot add, and let's add the neighbor. That is it. Now we are adding the neighbors, but we don't have the code for that thing in which we will only add this neighbor to that point in which the is point two-way is true. Okay, so in order to add the neighbors only to that points in which the point is two-way is point two-way is true. Okay, so for that right here, create a awake method. Let me remove the default code. Okay, and in here let's create a variable by the name of two-way climb neighbor. Okay, and this will be equals to neighbors dot where. Okay, and as you know that this where needs the system dot link directory. Okay, we can't type this like this. Okay, so in order to use this dot where right here at the top, make sure that you type using system dot link. Okay, so now we can use this dot where keyword. So we will say where n is equals to n dot is point two-way. Okay, so now we will create a for each loop in order to check in all of the points where the is point is two-way. Okay, so we will say variable neighbor in two-way climb neighbor. Okay, so now let's only check for that point in which the is point two-way is true. So we will say neighbor dot climbing point dot create point connection, then we will say this, then minus neighbor dot point direction, and then neighbor dot connection type, and then neighbor dot is point two-way. Okay, that is it. Now if we save the script and get back right here, now if we select our first point, as you can see from the first one we have a connection to the second one, and as you know these are a two-way connection, and on the second one we don't have a connection back to the first one. Okay, so now if we play the game, you will notice that the second connection back to the first one will be add automatically. Okay, so now if we play it, you will notice that the neighbor will be equals to 2, as you can see, and the connection back to the first one is added, as you can see right here. Okay, if I show you the scene view, okay, now as you can see from the first one we added the connection to the second one. Now from the second one the connection is now added automatically, and if we check the third one, as you can see in the third one we have the connection added automatically back to the second one, and in the same way we have the connection in all of them. Okay, now if I stop the game, let me select the last one right here. What we will do, actually select the second last right here. As you know, from here we only jump to that point. Okay, so we don't want then the player to jump down again. Okay, so what we will do, we will remove this is point two-way from this second last. Okay, not from the last one. because when the player jump from this one to that one, then we will remove this point 2a so that the player don't jump down right here. Okay, now if we play it, let me select the scene view. Okay, we also have now this exception. It say that object reference not set, because if you notice now right here, we only have a connection to the last one. Okay, I mean the last one, which is the sixth one, and also we automatically have now a connection back to the this position, which is on the left side. Okay, as you can see, okay, -1 is already set and it is back to that one. Okay, and from here the player will jump to the last one, and then from the last one the player can't jump down below. And the reason we are getting this error, okay, object reference not set to instance of an object, is because we didn't set the climbing point right here on this last one. Okay, so on this last one we will not be setting any climbing point, because right here we will add our shimmy actions, and in the shimmy actions we will be having a lot of points, okay, or you can say sub points of this last climb point. Okay, we will only move in play, we will only move player in those points. Okay, so we don't need to add this climbing point. So now in order to set this issue, what we're gonna do in our code right here, we will add a null checker. Okay, so what it will do, it will check for that climbing points which are null. Okay, and if that are null, then it will simply tell the code to cool down. Okay, there is no need to show any exception. So now if we save the script, let's clear that out. Now let's play it again. And now as you can see, we don't have any exception right here. Okay, so once this is done, now what we want to do is, now we want to show the connections between all of these climbing points, because as you know we don't have any gizmos on them, so most of our player will get confused that how these climbing points are connected. Okay, so we will be adding some connections between all of them. Okay, we will be drawing a line from each of this climbing point to the next one. Okay, so for that, after this create point connection function, we will now create on draw gizmos. Okay, and in here we want to draw line from each climbing point to the next one. So for that we will create a for each. Okay, and we will create a variable in here by the name of neighbor, and then we will say in neighbors, which is our list up here, because we want to check inside all of that neighbors. And what we want to do, if any climbing point which is set to is two-way point, okay, then what we want to do, we want to show that connection as green, and whatever connection is not two-way, then we will show that connection, or you can say that line to that connection, in black color. Okay, so we will say debug dot draw line. As you can see, it gives us all of the parameters, so let me remove all of them. Okay, so first of all we want to draw a line from the transform dot position, then we will say neighbor dot climbing point dot transform dot position. Okay, so we will draw a line from the first climbing point to the second one, then we will say that if those two climbing point is two-way, so we will say if neighbor dot is point two-way. Okay, if this is true, then we will color it as green, else we will color it as black. Okay, so if we save the script and get back right here, now as you can see, whatever connection is two-way, it shows the green line, and whatever is not two-way, it now shows this black line, if you notice right here. Okay, so it means it is working. But if you notice right here, it shows that object reference not set to an instance on the fifth one, since right here we didn't add any climbing point. And if we check our code right here, it needs a climbing point. Okay, so we will check for our null climbing points as well right here. So for that we will add a if condition. Okay, and inside this if, we will say that if the neighbor dot climbing point is not equals to null. Okay, if the climbing point on whatever points is not null, then on that points we want to show this. Okay, and whatever are null, then we don't want to show this. Right here, make this C small because it is climbing point. So now if you save the script, get back right here, as you can see we don't have any error now. Okay, and everything works perfectly fine. Okay, now the next thing which we want to do is we also want to draw an array for our forward vector of each of these climbing points. Okay, and the reason we will be creating array for our forward vector is because if we make the forward vector of this first point in that direction, okay, and now if we go ahead and play the game, you will notice now that the player hand position will be changed. Okay, as you can see, it is not looking good. Okay, so in the future, or if you guys by mistake created any point in which the forward vector is not in this position, then all of your climb points will be just a waste of time. Okay, just as we did in the previous video, we deleted our climb point and we created these new climb points. Okay, so we want to avoid that mistake. Okay, so what we're gonna do, we will create an array in the forward direction of the climb point. So we will say debug dot draw array. Okay, we want to draw array from the transform dot position of the point, then that array will be in the transform dot forward direction, and let's color this as red. So color dot red. If we save the script now, get back right here, now as you can see in the forward vector we now have a ray right here. As you can see, it is now showing this ray. You can actually color this ray as blue if you want, since our forward vector is of color blue. Okay, as you can see right here, so you can color this as blue as well, as you can see now. Okay, so now we have a climbing system. Now in the next video we will allow the player to jump, or you can say to climb between these system. Okay, or you can say this web. Hello guys and welcome back. So in this video we will be adding our climbing animations, or you can say climbing parkour actions. So for that, first of all, open up the miximo.com website, because we will be needing the animations for our climbing actions. Okay, and on the miximo.com, make sure that you have uploaded your character. I have shown you how you can upload your own character on this website. Okay, in the starting of this course. So once you have uploaded your character, right here search for praised. Okay, and when you search for it, you will find these animations, as you can see. So what I want you to do is now select this animation, which is by the name of praised hang hop up. Okay, click on it, and as you can see, this will be our animation for moving the player up to the climb point. Okay, so just simply download this without skin, and then select right here FBX for Unity. Click download, And once you download that, now let's select this brains hang drop. Okay, this will be our animation for climbing down. So just simply download this in the same format and skin as well. Then after this, let's select this one, which is by the name of braced hang hop left. Click on it, and as you can see, this will be our animation for climbing to the left side. Download it. Then after this, select this braced hang hop right. Okay, we will be using this animation for climbing to the right side. Download this one as well. We have the animation for shimmy actions as well, but for now we didn't have any code for shimmy action, so we will be leaving this as it is for now. We will download this in our future videos. Now once the animations are downloaded, click on animations, then inside the climbing actions, the climbing animations, what we will do, we will now drag and drop them. Let me actually maximize it and then minimize right here. Let's drag and drop this in our climbing actions right there. Okay, so this is our hang hop right, this is hop up, this is the left, and this is the drop. Okay, so these first four are the animations. So what we're gonna do, we will select all of these four animations, click on its rig, change it to humanoid, and then right here avatar definition will be changed to copy from other avatar, and in here we will select main mesh avatar, click apply. That is it. Now if we check it out, as you can see, this is our animations. Okay, we will also be trimming these animations just a little bit. So let's select the hang hop up animation right here. Okay, and if we play this animation, as you can see right here, when the player moves up, as you can see, there is this space. Okay, so what we want, when the player jumps to the ledge like this, then we want to cut this end part. Okay, so what I will do right here is, from the end right here, I will cut the end 37 frames. Okay, as you can see, when the player jumps, then that is all we want. Okay, right here, go ahead, click on apply. When you do that, let's now click on the braced hang drop. Let me see this one. Right here we will change the rotation to back into pose, and then this to original, and then all of the other things will be the same. Click apply. Okay, we don't want any rotation in this one, so that's why we do that. Then let's select the next one, which is hop left. In this one we will set it to original and back into pose. Click apply. Then let's select the right, or you can say hang hop right, and in here we will do the same. We will select original, back into pose, click apply. Then again, if we select the hang hop up, okay, which we trim, now right here what I want you to do is to change it to original and back into pose, and that will be it for this one as well. Okay, so once you do these two things, trim the animation and then setting the transform to original and back into pose. Now the next thing which we want to do, if you notice these animations, okay, I will start from the first one. Now if I press the right key button, as you can see right here, the transform of the player, or you can say the position of the player, decreases. As you can see right here, the player is on this line, and if we select the next one, the player now drops down, as you can see. And if we select the third one, the player drops down even more, and then the third one, the player drops down even more again. Okay, so what we want to do, we want the position y of all of these four animations to be the same. Okay, since these animation will be connected with each other. Okay, so we don't want the player to move up and down while these animation changes. Okay, so if we select our hang drop, okay, what I will do on this is I will change the position y offset to 0.97, or let's just make it 98. Okay, click apply. Then let's select the hang hop left. We will change the offset of this one to 0.295. Okay, then if we select the hang hop right, we will change this to 0.16. Then the last one is the hang hop up, so let's change this to 0.1. Click apply. Now if we select all of them, now as you can see, there is not that big gap. Now in the first two we have a little bit gap. Okay, the first one is a little bit down. Okay, if you select the first one, then select the second one, as you can see the second one moves a little bit up. So what we will do, we will move this a little bit down, okay, to 0.32. Okay, I have test this value, and now if you notice, there is now no big gap. Okay, now there is just a little bit gap between the first, second and third one. If you notice, this one is a little bit lower than these two. Okay, so what we will do, we will now change this one to 0.185, and if we select the next one, what we want to do now is we want to move this one a little bit down. So let's select it and let's make this as 0.123. Okay, so now if you see all of the animations, as you can see, the player is in the same position. Okay, so you can set these values according to your own animations as well. Okay, like this, just simply select one of them and compare it to the second one, then compare it to the third one, then the fourth one. Okay, and once your player position remains the same, then leave it as it is. Okay, so make sure that you change these values according to your animations. Okay, that is it. Once you do this step, now let's go ahead and type a code and let's implement these animations so that the player can perform parkour on these. So for that you need to open up the climbing controller, and right here we added this comment for ourselves, which is ledge to ledge parkour action now. Okay, so what we will do, we will now actually, let's leave this so that we know where we added our ledge to ledge parkour action jumps. Okay, so in order to perform the jump, now let me tell you that if we want the player to jump up, okay, then we want the player to press the W key and then the jump key. Okay, and if you want the player to jump down, then we want to press the S key and the jump key again, and if you want to move to the left, then we want to press the A key, then the jump key, and the same for the right, we will press the D key and the jump key. Okay, so first of all we need to create a input direction. Okay, so for input, first of all we will be needing to get the horizontal and vertical axis, or you can say the left, right, up, down key. So right here we will say float horizontal, this will be equals to input dot get axis raw. We want to get the horizontal axis, so we will type horizontal. Okay, and as you know that we want to keep this horizontal value between 0 and 1. Okay, so in order to keep this between 0 and 1, what we will do, we will add round brackets like this, and then at the start we will say mathf dot round, and that is it. Now if we copy this, paste it down below, let's change this to vertical, and right here change this to VER DICAL vertical. Okay, now once we have the axis, now by using this axis let's create a input direction. So we will create a variable by the name of input direction. This will be equals to new vector 2. We will pass the horizontal axis and the vertical axis. Actually, the horizontal and vertical inputs, you can say that as well. So now once we have the inputs, now we need the current climb point reference right here. Okay, because we have the input, but what we will do of this input if we don't have any climb point direction, or you can say reference. Okay, because once we have the reference, then we will be able to perform the climb up actions in our horizontal and vertical axis. So first of all, let's get a reference for our current climb point. So if we get right here to the climbing point script, actually not on the climbing point script, I get confused between these two. Actually on our climbing controller right here, we will say climbing point. Okay, this is a reference to our climbing point script, because on this script we have the climbing points. Okay, so we'll say climbing point, and let's name this as current climb point. Then if we scroll down inside this if condition, when we press the jump button and the player is not in action, and then inside this if condition where we perform our idle to climb action right here, now we will say current climb point equals to climb info. Okay, just climb info recast, then dot transform dot get component. Let's get the climbing point, and that is it. So now once we have the current climb point, now we can check that if that climb point has any neighbor in the direction or not. So in order to get the neighbor, let's go ahead and create a separate function for that on our climbing point script. So after the function, which is create point connection, right here we will create another one now. So we will say public neighbor, then we will say get neighbor. Okay, so this will basically return a neighbor, and this is the function name. Now this function will have a parameter of type vector2, and this will be our climb direction. Okay, so in here we will create a neighbor. This will be by default equals to null. Okay, then after this, as you know that we will be performing the parkour action in the left, right, up, down direction. So as you know that we set that direction in our point direction x and y. If the y is 1, it means the player will move up. If this is minus, then the player will move down. And if this is 1, the player will move to the right. And if this is -1, then the player will move to the left. Okay, so we need to set this point direction. So right here we will say that if the climb direction dot y, okay, is not equals to null, it means that if we have assigned the up down direction of the climb point, then right here we will say neighbor. This will be equals to the neighbors list up here. Okay, and then we will say dot first or default. Then right here we will say n equals to n dot climb direction dot y will be equals to the climb direction dot y. Okay, after this let's do it for our x direction as well. So right here we will paste this and change this to dot x, and if that is not null, and right here we will also say if the neighbor is not null as well. Okay, and the climb direction dot x is not equals to 0, then we will say neighbor equals to neighbors first or default, then n dot climb direction dot x, and then climb direction dot x. Then after this if conditions we will simply return the neighbor. Okay, so this will basically give us the climb point neighbor. Okay, so if we are on climb point 1, then after that it will give us the neighbor that the next point is that one, and we check if that point is in the y direction or in the x direction. Okay, so now if we get back right here to our else condition, right here we can now perform our animation since we have the neighbors, okay, the y neighbors and the x neighbors. Okay, so before performing that, first of all, after this we need to set the animations in our animator. So if we get back right here, it is showing this error which is saying neighbor does not contain a definition for climb direction on line 37 and 42. So if we open up our climbing point script, okay, so right here I have made a mistake. This should be point direction. Okay, point direction dot y and then point direction dot x. Okay, this is our vector to point direction. Okay, because on our point direction we set a direction in -1 1, and for the x as well -1 and 1, which moves our player to the left and right side, or you can say which tell our player to that the next point is on the left or on the right or up or down. Okay, so make sure that you type point direction dot y or whatever you name your vector to right here. Okay, so if we save the script, get back now right here. Okay, so now inside the animator we have this climbing animations. What we will do now is we will move this right here. Okay, then let's select our animations. So this is hang drop, let's move it right here. Then we have this hang hop up. Okay, then after this we have the left, then we have the right. Okay, so make sure that you add them like this. Then let's change the name of these animations. So we will remove the braced from the start and name this as climb up, then this one to climb down, then this one to climb right, and as you guessed the last one, this will be climb left. Okay, make a transition from hanging idle to climb up, then climb down, then to the right and left. Okay, that is it. Now we can get back to our script, but first of all let me tell you guys that make sure that you name them correctly and then you remember that animation name. Okay, because we will be typing this animation name now. So if we get back now to the climbing controller, right after this let's assign the neighbor now to our input direction. Okay, as you know we have this get neighbor method now, and if you scroll up right here we have a reference to our climbing point script already, so make sure that you have a reference as well. Okay, so in order to add the neighbor to our input direction, what we will do, we will create a variable which will be by the name neighbor. This will be equals to now current climb point dot get neighbor. Okay, this is our method which we created, and in here now to this vector to climb direction we will pass our input direction. Okay, now what we will do is we will say if the neighbor is null, then we don't want to do anything. Okay, we don't want to perform the climbing action, we will just simply return from here. And now we will say if the neighbor dot connection type is equals to the connection type dot jump. Okay, so what this means, if this neighbor connection type is equals to the connection type dot jump of the point, and also if the player presses the jump button, then what we will do, so right here we will say input dot get button. Okay, and right here we will say jump. Okay, and as you know that the jump is set to our space button. So now if this is the case, then our current climb point will be equals to the neighbor dot climbing point. Okay, and then we will say if neighbor dot point direction dot y is equals to 1. Okay, it means that if the point, okay, which is set in our environment, if on that point the y value is 1, and as I told you, when the y value is 1, it means the player want to go up. Okay, so if the player want to go up, then what we will do, we will play our climb up animation. Okay, so in order to play it, first of all we will right here say start coroutine, and as you know we have a method to perform animation, that is this climb to ledge. So we will pass the climb to ledge right there, and as you know it first of all need the animation name, so we will say climb up. Then we will pass the current climb point dot transform. Then we need the start time and end time for our target matching. So if you get back right here, click on animator, let's see our climb up animation right here. Okay, so what we will be doing right here is, okay, we will target match from here when the player hands are start moving. Okay, when the player hands start moving from some point right here from 35 till right here when the player lands the hand on the next point, as you can see right here. Okay, so right here we will pass the start time as 0.34. Okay, and then the end time will be 0.64. Okay, so when you pass this, now let's copy this and paste it down below. Change now this to else if, and now this time if the y value is -1, it means the player wants to go down. So we will now call the climb down method, and then we need to change the start time and end time for this one as well. So if we select our climb down right here, let's check it out. So from here the player start moving the hand, okay, from this 30 point, and then let's move forward to right here when the player start landing the left hand. Okay, so from 30 till 65. Okay, when the player lands both the hand right here to 69 or 68 for example. So we will change this to, let's just say 31, and this one to 68. Okay, now copy this again, paste it down below. This time we will now do it for our x values, which is the left and right. So if the x is 1, it means the player wants to move to the right. So right here I will say now climb right. This is our animation name. Let's see the start and end time. So if we see our climb right, let's move it from right here. When the player leaves the hand on one edge, okay, so from somewhere 20 till right here when the player lands, okay, so 50 would be a good value because on 50 the player lands both of the hand, okay. So right here we will say 20, and right here we will say 51. Then let's copy this, paste it once again down below, and for the climb left the values of the start and end time will be the same since they are the same animations, okay. So we will leave this as it is. So once you do that, now right here make sure that you change this C to small, okay, climbing point, since it was giving us an error. So when you change that, the error will be gone. Now if we move right here after this input direction, what we will do, we will add a if condition, and we will say that if the player script dot player in action or the input direction is equals to vector 2 dot 0, then we will simply return, okay, because then we don't want to perform the actions of the climbing controller. And after this, if we get back to Unity, let's click on scripts, parkour, let's open up the parkour controller, and right here we will say and player script dot player hanging, okay. So what this means, it means that if we press the jump button and the player is not in action, then as you know we perform the parkour. So now we say that if the player presses the jump button and also the player is not in action, and if the player is hanging, okay, then we will perform the parkour action. Because if you don't add this at the end, then for example if your player is hanging on to some point, okay, and in front of the point there is something that is on the obstacle layer, okay, and then if you try to press the jump button, then the player will perform the parkour action instead of the climb parkour action. So that's why you need to add this at the end. And also at the start of this player script dot player hanging, you need to add this not word, okay. It means that if the player is also not hanging, then we will be performing the parkour, because as I told you, when we are on some point, then we don't want to perform the parkour actions. After this, if we now go ahead and open up our player script, in our player script we already added if the player is hanging, then we don't want to do any of the thing, we don't want to apply the gravity, not any other thing, okay. But if you notice, the player movement method is on the top, so we need to move this player movement down below, since if we don't remove this, then the player still will have movement, the player will move to the left right while the player is hanging, okay. So you need to move this right here. Then after this, let's open up our climbing controller and make sure to check your animation name once again, okay, with this animation name. And also let's check the values, okay. So y1, y minus 1, x1, x. Okay, right here we need to add minus, okay? Because if it is 1 we will move to the right, if it is minus 1 then we will move to the left, okay? Make sure to check all of these values or else your climbing controller will be messed up, okay? So once you do this, save the script, get back to Unity, and also let's make sure our points are set up as well, as you can see. So now what we can do, we can now simply play the game and let's test it out. Okay, so now if you go ahead and perform the first one, as you can see it is perfectly working. Now the player jumps to the second one, now to the third one, now to the fourth, to the fifth. We can also get back down below, as you can see, okay? So it means it is working perfectly fine. But if you notice, the player hand offset is not looking good, okay? But don't worry, we will be fixing this hand offset of the player, okay, in our next video, since this video is already a little bit lengthy. Now if we jump right here, we will not be able to jump down since this is just a one-way climb point, okay? And from this climb point we will not be able to jump up. We will now add shimmy actions, but that will be in our future video, okay? And if you want the player to go down as well from this point, then you can just make the fourth one is two-way and that will be it, okay? So once this is done, now our climb up controller is working perfectly fine. We need to set the hand offset on each of the climbing controller, okay? So we will do that in the next video. Hello guys and welcome back. So now in this video we will be fixing our hand offset and also we will be adding our shimmy actions. So for that, what we're gonna do, we will open up miximo.com, and from here if you search for shimmy you will find these animations. So what we can do now, we will download this right hand shimmy, okay, in which the player moves on the right side. So click on it and download this one, okay? Since if I show you the code, the climbing controller right here, we are already using the avatar right hand, okay? So download this one, and yes, of course we will be shimming on the left side as well, but what we're gonna do, we will mirror this animation for that, okay? And as you know that when the player is moving on the left, then the player will use the left hand, so we'll be typing a code for that, okay, in which we will be using the avatar left hand as well, okay? So the main thing right here for now is just download this right side shimmy action, okay? So click on download without skin, FPX for Unity, click download, and once you download it, just simply drag and drop it inside the climbing animations, okay? So this is the animation right here, breast hang shimmy. What we're gonna do, we will click on rig, change it to humanoid, copy from other avatar. Let's select the main mesh, click apply, click on animation. Now let's drag and drop the player. This is the animation, okay? If you play it, as you can see, the player is shimmy to the right side, as you can see. So first of all, what we're gonna do, we will, let's change this back into pose to true, okay? Or you can take this, then change the based upon to original, then click apply, because we don't want any rotation in this. Then after this, if we select our other animation, okay, for example this hang hop up, as you can see there is this transform issue. Our shimmy action is a little bit above, as you can see. So what we will do, we will change the position Y offset. So if I change the offset to 0.72, okay, I have test this value, and now if you notice, the both animation transform position Y matches. As you can see, there is now no more distance issue. As you can see, both of them are now the same. Okay, so you can increase or decrease this value according to your own animation, but I will leave this as 72 since it matches the other animation, as you can see. Okay, so once you change the offset of this, now let's go ahead and click on our animator, and what we will do, we will drag and drop this in here. Okay, let's change its name to shimmy right. Okay, then we will drag and drop this again, and this time we will change this to shimmy left. Okay, so left and right, and now what we will do with this shimmy left, we will mirror this. Okay, then after this, if we change to the scene view, now let's create our points for our shimmy action. So what we're gonna do right here is we will select our point 5. Okay, first of all change its name to long point, and let me remove the 5 from the end. Okay, and let's increase the scale X of it to 9, for example, so that it can fit in this whole area. Okay, so let me move this right here like this. Okay, and if you want you can cover that area as well. Okay, but I will leave this right here. Okay, because we want to just perform the shimmy actions in this area only. Okay, I think it looks good. So once you add this now in here, what we will do, we will create a empty game object like this. Let's name this as 1. So, and also let's make this unpack completely. Okay, we don't want to make this long point a prefab now. So in here, create empty game object, name it as 1. Let's add an icon to it. For example, we will color it as red so that we can see it. Okay, let's move this 1 to that point, actually right here, for example. Then we will duplicate this and make it 2. Okay, let's duplicate this 10 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's now rename them as well. So 3, 4. Let me name them. So I will stop the video, name them in order to save our time. Okay, so once you name them, now let's select the point from 2 to 10. Hold down the shift button and move this as 1, 2. Okay, then press the shift button and click on 2, actually click on 3 and then select till 10. Then press the the control button again and then 1, 2. Okay, now while holding down the control button, click on 3 so that it get removed. Now move it to 1, 2. Hold down the control button. Okay, keep holding it down, click on 4 so that it gets removed. Then 1, 2. Then remove 5th now, 1, 2, then 6th, then 1, 2, then 7, and then 1, 2, then we have 8, so 1, 2, then we will remove the 9, then 1, 2. Okay, so you can do this with all of these points. Let's add 10 points more in order to cover all this area. So we will say 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, let's name them again. Okay, so once you name them, let's now select the point from 11 till 20. Hold down the control button again and 1, 2. Then remove the 11th, then 1, 2. Let's do it for the other ones as well. 1, 2. Okay, once you do it till 17, let's remove the 18, 19 and 20. That is it. Okay, let me now select all of them and let me move all of them a little bit to the right side like this. Okay, so that the ends are, I mean, there is a little bit space between the point and the end area right there. Okay, so we now have the points on which we can perform the shimmy actions. So first of all, let's select all of them again. Okay, and make sure that they are on the layer climb. Then we will add a component and let's add the script climbing point. Okay, make their neighbor as 1, and once you do that, make this is point 2a true. This will be of connection type jump, and make the point direction of them as -1. Okay, then if we select our first one, in this we will drag and drop the second, then in the second we will drag and drop the third, then in the third we will drag and drop the fourth, then select the fourth, drag and drop the fifth, and in the same way do it for the other points as well. And when you reach to the last one, which is this 17 right here, what we will do, we will simply leave this as empty. Okay, and now as you know that from the point 4, okay, we have a connection to this long point. So what we will do, we will now remove that connection. So if we click on point 4 in here, we will now provide this point, I mean this 5 point of this long point. Okay, so select point 4 and drag and drop the fifth one in there. Okay, so as you can see, there is now connection to this fifth point. You can select your closest point on your shimmy points. Okay, and you can just assign that to your main point. Okay, like this. And once you do this, let's now minimize our long point. And as you know, we have the shimmy left and shimmy right here. So what we will do, from the hanging idle, we will make a transition to shimmy right and then to the shimmy left. Then let's go ahead and type a code for this in order to perform this action. But now before opening up our text editor, first of all, let's select all of these again. Okay, from 1 to 17, and make the connection type as move. Okay, since we will be moving from this points, okay, from 1 to second, then from second to third, fourth, fifth, sixth, seventh, and till the end point. Okay, so make sure that all of them are set to move. Then if we open up our climbing controller script, okay, right here in this if condition, we say that if the connection type is jump and we press the jump button, then we perform the climb up and down, right and left actions. Now what we're gonna do after this if condition, right here we will say else if, and now if the neighbor dot connection type is equals to the connection type dot move, then we want to perform shimmy actions. Right here make this C small, and right here the C will be capital. Okay, so first of all, right here we will say current climb point equals to neighbor dot climbing point, just as we did right there for the jump. And then after this we will say that if the neighbor dot point direction dot x is equals to 1, it means the player want to move to the right side. So we will play the shimmy right animation. So for playing the shimmy right animation, we will use the same method as we did for the climbing. So what we can do, we can just copy that from there, paste it down below, and change the animation name to shimmy right. Okay, and we need to provide the target matching for this. So for the start time, we will pass 0 because we want to target match whenever the shimmy right is called. Okay, and now the end time will be, let me check it out. So if we play it right here, when the player lands the right hand, as you can see right here on this 30 percentage. Okay, so we will say 0.30 f. Okay, then what we can do, we can just simply copy this and paste it down below. Now change this dot x equals to -1. So if it is -1, the player wants to move left, so we'll change the animation name to shimmy left, and the start time and end time will be the same for this one. Okay, but as you know that when the player is performing the shimmy left animation, then this time the left hand will be the first which will land on the point. And as I told you in the starting of this video, we only have the avatar target set to the right hand. So now we have the animation on which we need to set the left hand. So in order to set the left hand right here, after this compare end time, we will now add one more parameter to our climb to ledge, which will be of type avatar target. Let me just actually cut this from here and paste it right here. So avatar target dot right hand. So what we're gonna do, we will remove the hand, the dot from there, and we will type hand. The hand will be equals to avatar target dot right hand. Then right here the body part will be now equals to hand. Then if you scroll down in the set hand position, we will now create another parameter which will be of type avatar target, and right here we will name this as hand. Okay, and now right here when we are setting the hand offset, we need to now make sure that if it is the left hand or the right hand. So up here we will create a variable by the name of horizontal direction. Actually, let's name this as hand direction. Okay, this will be equals to if else condition. So we will say if the hand is equals to the avatar target dot right hand. Okay, if that is the case, then we need to pass this transform ledge. So ledge will be dot right, else we will say minus ledge dot right. Okay, so what this means, it means that if the hand, okay, this hand is equals to avatar target dot right hand, then we will make the ledge dot right, and if it is not, then we will make the ledge left. Okay, so as you know that we can't use the dot left keyboard, so that's why we use the minus sign at the start. After this, now right here, instead of this ledge dot right, we will pass the hand direction right there. Then as you know that this set hand position has two parameters now, so we need to pass the avatar target as well. So for that we will simply pass hand. Okay, then once we have the connection to our left hand, now after this, as you know, the climb ledge now need a parameter, which if it is the left hand or right hand. So on the shimmy left, at the end we will set the avatar target to the left hand. Okay, then if we save the script, get back to Unity, and now let's test out our game. Okay, so if we go ahead and perform the first jump, as you can see it is working. Now second, third, let's move up. Okay, and now if we perform this one, as you can see now, the player is not performing the shimmy action because it is showing this error. First of all, it is showing animation name is incorrect. Then we have these two other exception. So the reason behind this is actually this debug message which we are printing, which is animation name is incorrect. Okay, so if we select our hanging idle, you will notice that this hanging idle animation is too large, okay, too lengthy, as you can see. And when the player perform the shimmy left or the shimmy right, after that, as you know that it gets back to the hanging idle, and if the hanging idle animation is really lengthy, so that's why it is showing that error. So in order to fix that, what we're gonna do, we will click on our player script, and right here inside our perform action method, right here, as you can see, we wait for the animation till it is 20%. So we actually don't want to wait that much. So instead of this crossfade, now we will type crossfade in fixed time. Okay, and what this will do, this will now only wait just for 0.2 seconds. Okay, so this is the first solution, and the second solution is that you can just decrease the length of this hanging idle. But as you know that this hanging idle is lengthy because the player is breathing, so if we cut it out then it will not look good. So that's why I just change the crossfade to crossfade in fixed time in the script and save the script. Get back right here. Let's now test it out again. Okay, let's jump there now. So now if we try to perform the shimmy actions, as you can see, the player is moving to the left side. We can also move to the right side. Okay, for now the player offset is a little bit messed up, so as you can see the player hands are inside the wall and also the player feet, but don't worry, we will be fixing that in a moment. So now the shimmy action works. Now let's go ahead and set the offset for each of the climbing action. So for setting the player hand offset, what we will do, first of all, let me press enter right there so that we can see this line down below. And after this avatar target hand, we will now create another parameter inside our climb to ledge method, and that will be of type vector3, and let's name this as player hand offset, which will be equals to null. Then after this, in our set hand position right here, we will say vector3 player hand offset. Okay, name this as player hand offset, just as we did right in our climb to ledge. Okay, player hand offset, and also add a null checker right there and here as well. Then what we will do for now, we will comment this code now, okay, and then at the top we will create a variable by the name of offset value. This will be equals to now if else condition, so we will say if the player hand offset is not equals to null, okay, it means that if we provided the player hand offset, then the player hand offset will be equals to not equals to, we will just simply say player hand offset dot value, okay. Then after this we will say else if the player hand offset is now not is actually equals to null, then we will say vector 3, and for the x we will pass in out value, for the y we will pass up down value, and for the z we will pass left right value. That is it, okay. Now what we will do, we will remove the comment from there and then we will cut this from here now. And as you know that for each of our climbing action now we need to set the offset, okay, because whenever we perform any climbing action the player hand offset is incorrect, okay. So make sure that you cut that 3 values, okay. Don't copy anything or your values will be gone. And first of all, if you get back to Unity, okay, it shows this error on 99 because as you know that the set hand position now has 3 parameters and we didn't provide the third parameter right here, so let's provide the player hand offset right here, okay. It will be actually inside these brackets. Now if we save that, get back right here, now you will notice that if we perform the climb up, as you can see the hand offset is now not set up. If you notice, okay, the player hands are not set up. So what we will do, we will now first of all set the hand offset for our first jump, okay. So right here inside this if condition, when we perform the idle to climb animation, right after this player script dot set control false, we will pass this value right there, okay. This is the value which we cut from here, okay. Now we will paste that in the idle to climb like this, and then as you know that the climb to ledge method now needs the hand and the player offset. So what we're gonna do right here now is after this we will not assign the hand because we already type a code for that in which we say that where the left hand is needed then we will only assign the left hand in that position, okay. I mean on that climbing action. Right here we will be just adding the player hand offset, okay. So we will say player hand offset after this start time end time, then we will say new vector 3, and inside this vector 3 for the x we will now pass the in out value which is this one, because when we press the jump button, okay, and the player jumps to the first point, the in out values will be set to this, okay. These in out values will be set to this, and now we are passing this in out values right here, okay. So first we will pass the in out value, then the up down value, then the left right value, okay. That is it. If we save the script, get back right here, now you will notice that the first thing will work perfectly fine, as you can see. Okay, now after this we need to set the offset now for our other climbing actions. Okay, for these four, and then the shimmy right and shimmy left as well. So let's start from the climb up. In here, when the player performs the climb up, we will be setting the values now again. Okay, we might change these values, but for now let's assign these values to our climb up as well and see how does it looks. Okay, so right here now, after this start time, end time, we need to provide the player hand offset, so we can just copy it from there and paste it right here. After this start time and end time, we will paste it. Okay, then if we save the script and get back to Unity, now let's go ahead and test it out. How does it looks? Right here it is fine, but if we perform it right here, as you can see, the values are messed up. Okay, so we need to make the player move a little bit out, and we need to move the player to the center. Okay, if we check the scene view, let's select the player. Okay, what we want to do, we want to move the player outside like this, then a little bit above, okay, like this, and then to the left side so that the player is in the center like this. Okay, so let me now close the game and set the values for my climb up. Okay, we will be now setting these values. Okay, so I have tested my game and these values worked perfectly fine for my climb up action. Okay, if I play the game and show it to you guys, okay, you will now notice that when we jump, as you can see, the player hands are perfectly fine on the point, as you can see. Okay, so for the climb up, I will leave these values. Now we need to do the same for the climb down, so let me copy these values. We might change them in the climb down, but for now let's just leave this as it is. Let's copy this player hand offset code, and after this paste it. Then let's go ahead and test it out on these values, that how does our climb down action see. So let's go ahead and jump to the first one, then to the second one. Now let's jump down. As you can see, there is some issue. We need to move the player hands a little bit outside. So right here the in out value will be changed. So as you know that we will be moving out our player just a little bit. So from 0.1 we will change it to 0.2. Okay, so now if we go ahead and check it out, okay, this is our first one, then this is jump up or climb up. Now let's do climb down. Okay, as you can see, the climb down is looking perfect as well, as you can see. Okay, so if you want your player to move out from the point, just increase this in out value. Okay, now we need to do for the climb right and climb left. So let's first of all see how our player looks in the right and left. So if you jump to the left, as you can see, the player hands are just a little bit, I think, outside, but I think it looks good like this. Okay, but we just need to move it a little bit down. Okay, in the left jump. Now let's see the right jump. Okay, the right jump, in this one we need to leave this as it is, because in this one, as you can see, the player hands are just fine. Okay, so we will leave the climb right as it is, and in the left one, as I told you, we will be moving the player hand a little bit down. So let's add the in out up down and left right values right there, and then we will copy this paste it after this, and in order to move the player down, I will change this up down value to 0.04, and we also want to move the player a little bit inside, so I will change this to 0.1. Okay, and then if we go ahead and play the game, okay, let's perform the action. Okay, there is our first jump, then second jump. Now if we move to the left, as you can see, now the player hands are perfectly fine, okay, on the ledge. Now let's jump to the right side, okay, and on the right side it looks good as well. Okay, let's move to the left, then right. Now let's move up. Okay, it looks good. Move right here. It looks good right here as well. Let's move up right there. As you can see, it looks good. And if we perform the shimmy left, as you can see, the player hands are a little bit inside. If we perform the shimmy right, as you can see, it is a little bit inside, okay, the player hands, and we need to move them a little bit down. Okay, if I show you right here, let's select the player. Okay, we need to move the player a little bit outside like this, and then down to this point, okay, like this. So what we will do now, we will copy this again, and we will paste it inside the shimmy right. Then let's paste it inside the shimmy left as well. Then copy the player and offset, and after this start time and end time, paste it, and right here we will paste it after the avatar target left hand. Okay, so let's do that. Now let's try it on these values. Let's see how does it looks on these values. Okay, so if we save the script, get back right here to Unity, then let's go ahead and perform it. Okay, these are looking good, as you can see. Okay, the player hands and feet are now, as you can see, outside. Okay, but on the shimmy right and shimmy left, the player hands are inside, and we don't want that now. So in order to move the player a little bit outside, for moving the player outside, we will change this to 2, and let's change this from 4 to 3 in order to move it down a little bit. Okay, and let's do the same for our left side as well. So we will paste it in the left side as well, because the right and left shimmy action, or you can say the shimmy animation, actually is the same. Okay, we just mirror that animation. Anyways, save the game. So now if we play the game, let's jump right there, then to the second one. And if you notice, now the player feet and everything are outside. Okay, now the player feet are not inside. And now if you notice, the player hands are looking good on the shimmy actions as well, as you can see. Okay, let me remove the click, and also let's disable the gizmos. Okay, so now if you notice, the player is perfectly fine. Okay, as you can see, and right here the player stops. Let's move to the left now. Okay, as you can see, everything looks perfectly fine now. Okay, so once you set the offset for all of these climb points, okay, then you are good to go. Okay, now the next thing which we want to do is we want to remove these cubes now. So what we're gonna do, we will select all of the points, the long point as well, disable the mesh renderer, and when you disable the mesh renderer, that will be it. Then if we play the game again, okay, now let's try to perform the parkour again. As you can see now, the player hands are now on the objects, as you can see. Okay, they look good. Okay, if we see it right here, as you can see, the player is performing parkour now really good. Okay, so now as you can see, the shimmy actions are added. Now what we want to do, we want that if the player is on the end of this shimmy actions, then we want to jump to this other side. Okay, let me show you. If we stop the game, okay, so when the player is on this point, okay, from here we want to jump to this side. Okay, and then from here the player can jump to this one, and then right here the player can perform shimmy actions. Okay, and in the same way in these directions. Hello guys and welcome back. So in this video we will be adding shimmy actions to this side so that you guys know how you can add the shimmy actions around your own building area. Okay, so for adding the shimmy actions, what we will do, we will remove this part of this building, since right here we don't have enough space for adding our parkour actions because this area is too small. So what we will do, we will remove that upper part, and then we can remove these areas as well. So you can just select it and delete it like this. Okay, let's remove that area as well, and if you want you can remove this as well. Okay, so once you remove this, now as you can see we have a lot of area for performing our shimmy actions. So what I will do now is I will open up my climbing points, and as you know that these climbing points will be too large for this area, so what we will do, we will create shimmy actions right here by our own. So what we will do, let me actually select the point 4, okay, that point 4, and let's duplicate it. Okay, so now we have point 5. Let's move this point 5 right here. Okay, and just change the point 5 neighbor to 0, then change it to 1 again. Okay, so that we don't have the reference right here. Okay, so turn on the mesh renderer, and what we will do, we will now rotate this on the y-axis by -90. Then let's move it right here, then in upward direction like this. Okay, make sure that it matches this area, then move it right here. Okay, and when you do that, let's select this rect tool and let's increase the scale x of this. Okay, let's change it to 4, for example, like this. Okay, and when you change the scale of it, let's actually make it 4.5 or 4.4. That is it. Okay, let's move it a little bit upward like this. That's it. Now let's remove this mesh renderer, or you can say disable it. Then we will click on prefab, then unpack completely. Now inside this point 4 we will add our sub points for shimmy actions, but first of all let's change its name to long point 2. Okay, then in here let's create an empty game object. Let's name this as 1, and let's select the icon for this in red color like this. You can select the other things as well like this if you want, but I will leave this as 1, and then I will move this right here, okay, to this point, but let me actually move it a little bit right here. That's it. Okay, now what we will do, we will duplicate this. Let's just say 10 times, so 2, 3, 4, 5, 6, 7, 8, 9, 10, and then as you know we will select the 9 points. Actually, first of all let's rename them, so 2, 3, then 4, then 5, then at the end we will name it as 10. Okay, So once you name them, let's now select the points from 2 to 10. Okay, just hold down the shift button and select till 10, then hold down the control button and move it like this, 1 2. Okay, then keep holding down the control button, click on 2 so that it get removed, then 1 2. Okay, in the same way do it for the others, 1 2 1 2, and then for this one as well. Okay, so once you do it till this point, then what we will do, we will remove the last point. Okay, we will leave this as 9. Okay, so we have 9 points for performing shimmy actions on this side. Now what we will do, we will expand the long point, which is this first one, and as you know right here, from this point 1 to this point 1 we will create a reference now. So if we select the first one, as you can see it as a reference to the second one, we will add another reference. But first of all, let's select these 9 points, okay, which we created right now, and to them make sure that you add the climbing point, then make their neighbor as 1, and on this one let's drag and drop 2, then to 2 add the 3, then select the third, right here add fourth, then to the fourth add fifth, and in this way you can just drag and drop them like this. To the eighth one we will add 9, and we will leave the 9 as it is. Then let's select from 1 to 9. Okay, select all of them, make them two-way, change this to move, and as you know, when the player jumps to this one from that one, then they will move in the right direction, so we will make the x1. That is it. Okay, so once you do this for all of them, then let's select the first one, which is this one. Okay, let me clear that out. Now right here on this one we will click on this plus sign right here. As you can see, another one is created, so now we will drag and drop this one in there. Okay, like this, just drag and drop this one in there. Then as you know that this is on the right side, so we will change this to 1, and this will be of type jump, and this will be two-way. Okay, so once you do that, let me now minimize them and let's try to play the game. Okay, let's go ahead and perform it. So first of all we need to move to that point. Let's now shimmy on the right side, and when we move to the first point, let's now click on the jump button and the D button. As you can see, the player jumps. Okay, but if you notice, the player body is, when the player jump, the player body go inside the building edges. Okay, and we don't want that. But as you know that the player is now performing the shimmy action. Okay, so let's now fix that issue where the player body goes inside this edge. Okay, first of all let me click on this pipe and delete it. Okay, you can delete this one as well. Then what we will do, the player body was going inside this edge, so the reason behind this is that on our player script right here, as you know, when we perform any parkour, we rotate the player towards that parkour point, and this rotation rotates really quickly. Okay, so what we want to do in order to fix this, we will add a code in which we will delay this rotation. Okay, so for that, above this timer counter, what we will do, we will create another float by the name of, let's just say rotate start time, and this will be equals to if else condition. So we will say if the CTP, okay, this is our compare target CTP, which is compare target parameter. As you can see, you can notice the pop-up, okay, compare target parameter. So if this is not equals to null, then what we will do, we will say CTP dot start time, else we will just simply pass 0. Okay, then after this timer counter plus equals to time dot delta time right here, now we will create a float by the name of normalized timer counter. Okay, let's name this timer counter. So we need to normalize that. So what we will say, we will say timer counter, let's multiply that by the animation state dot length. Then in the if condition right here, where we say if the look at obstacle is true, and now we will say and if the normalized timer counter is greater than the rotate start time. Okay, that is it. So when you do these changes, save the script, get back right here. Now let's try to perform the shimmy actions again. So let me climb to the top, then I will show you. Okay, so now if I move to the right side like this, okay, so now if we jump from here, now as you can see, the player is not getting inside the building edge, as you can see. And right here we can perform the shimmy actions, as you can see. Okay, it is looking good now. Okay, now if you want, you can add shimmy actions to the other side. Let me show you how you can add that. First of all, let me clear that out. This is showing because we didn't add any reference to this climbing point. So what we will do now, in order to add shimmy actions to this side, we will just simply duplicate our first long point. So let's duplicate it, okay, and change its name to now long point 3. Then move it right here, and we need to make the forward vector in the other direction. So what we will do, we will change the rotation y to 180, and now let's set this thing right here. So open up the mesh renderer, let's move this right here. Okay, then we need to move this down below a little bit like this, and also let's move it right here. Okay, so I think it looks good like this. Okay, once you do that, now what we will do is, as you know that now right here the first point is this 17. Okay, so let's select these whole points, and as you know that the x is -1, and if you notice right here the points will go now from 17 till 1. So what we will do, we will change this to, let's actually not change it, just leave this as 1. Okay, and what we will do, we will select our 1 point on this long point 3, okay, which is that one, and right here we need to remove this second now. So what we will do right here, we will say 1, and that is it. So now from 1 it will move to the second one, okay, like this. And then right here select the 17, and as you know the 17 is empty, so from this 17 it will move to 16. Okay, so what we will do, we will select the 17 and right here add 16, and as you know that is on the right side, so we will change this to 1. That is it. Then we want the player to jump from this 9 to 17, so let's open the second long point, select the 9, and in the 9 drag and drop this 17, that is on the right side, and this will be of type jump, and this will be is two-way. Okay, so make sure that you do these changes on this 9 point, and then you will be good to go. Okay, but before playing it now, let's select the long point 2, open up their mesh renderer, and what we will do, we will move this a little bit up so that it covers this whole area of this building edge like this. Okay, that is it. Now select the long point 2, disable the mesh renderer, select the third one, disable the mesh renderer. That is it. Now if we now play the game again, and let me climb these all areas, so in order to save our time. Okay, so now if we jump from here to the next point, as you can see the player jumps perfectly fine. Now let's move. As you can see, the player can shimmy on the left and right side perfectly fine. Okay, now let's jump from this point to the other one. As you can see, the player jumps and the player can move, as you can see. Okay, so the player can move to the right and left. Okay, now you know now that how you can add shimmy actions around the buildings. Okay, and also you can add the climb points as well. Now the next task, which is only for you guys, because you learned how you can add climb points and shimmy action points. Now what I want you guys to do is add climb points right here on these windows and move the player down below to this ground back again. Okay, for now we don't have the jump from climb points, we don't have that actions, but we will be adding that in our upcoming videos. We will also be adding the jump up actions from the shimmy points. Okay, for example, if the player is hanging right here, then we will add an action in which the player will simply jump up to the top of this building. Okay, but the test for you guys is that add the climb points on these windows and on these edges. Okay, till this point you can now do that on your own, and now I will end this video right here. Hello guys and welcome back. So in this video now we will add the action which is jump from wall. Okay, for example, if we are hanging to any of the obstacle right here, okay, or you can say this climb point, then from here we want to jump down. Okay, so first of all what we will do, we will download the animations for that action. So if you open up your browser and on the miximo.com, if you search for jump from wall, you will find this animation. Okay, as you can see. So what we will do, we will simply download this animation without skin, and then FBX for Unity, click download. And once you download this, I want you to download the other animation as well, which is by the name of pressed hang to crouch, or you can just search for hang to crouch as well, and you will find this animation. Okay, this first one, and we will be using this animation on our climb point. So for example, if the player is on these climb points right here, then we want the player to jump to this rooftop. Okay, so for that purpose we will use this animation. Okay, so let's download this as well in the same format and skin. And once you download these animations, what I want you to do is inside the animations folder, let's drag and drop them. Okay, so I have drag and drop it. This is the first animation, I think. Let me check. Okay, nope. It is this animation pressed hang to crouch, and then the other one is by the name of jump from wall. Okay, so these two are the animation. Just simply select them, then click on rig, and as you know that we need to change it to humanoid, then copy from other avatar, and in here let's select the main mesh, click apply, then let's select the first one. Okay, so this is the animation as you can see, and if we select the other one, which is jump from wall, as you can see this is the jump from wall. For now the animation has rotation, but we will be fixing that in a moment. First of all, select these two animation and drag and drop them inside the climbing animations, okay, because we need them right here since these are related to our climbing system. Okay, so now let's find them inside this folder where it is. Okay, this is the idle to braced hang, this is jump from wall right here, and then we have this one right here, braced hang to crouch. Okay, so first of all we will be adding the jump from wall action, okay, this one in which the player will jump from the wall. So what we will do with this is we want the position of this as same as the other climbing animation. So if we, for example, select this hanging idle, okay, as you can see its offset is 0.4, okay, and let's select now these two animation. If you notice that this hanging idle is a little bit down below, as you can see, let me check it again. Okay, so the hands are right there, and this is a little bit down below, and this is a little bit up here. Okay, so what we need to do, we need to move this jump from wall a little bit down. Okay, so let me pause the video and check this offset value. Okay, let me match it with my hanging idle, and then I will show you my value. Okay, so I have checked, and 0.4 is a good value for my jump from wall animation. Okay, as you can see now both of these matches now. Okay, as you can see. So once you find a good value for your offset, then after that what I want you to do is to click on the animator, and we are already inside the animation, okay, climbing animation, because right here we will be adding our jump from wall animation, actually not action. Okay, so simply drag and drop it right here, and let's name this as jump from wall, okay, like this. Okay, remove the spaces in between. And now, as you know that when the player jump from the wall, okay, we will first of all play this animation. Then after that, when the player is in the air, we will be playing the falling animation, okay. And as you know that our falling animation is right here, okay, which is this falling idle. So what we will do, we will make a transition from the jump from wall to the base layer, and in here we will select states and then falling idle. Okay, so now if you select the transition, you will notice that when the player jumps, as you can see, the player will then play the falling idle till that point when the player feet hits the surface, okay, or you can say the ground. Okay, so it is looking good. So now we are ready to play this jump from wall animation. For that, first of all, in the scripts folder, first of all we need to open up the player script. Okay, then let's open up the climbing controller, and with this we need to open up the parkour controller as well. Okay, so now right here we have this if condition, okay, in which we say that if the player hanging is not true, and then we have this else if it is true. Okay, so it means that if the player is hanging, now from player hanging we want to now jump, or you can say we want to leave the hanging state. Okay, and we want to play the jump from wall animation. So right here we will do that. But first of all, let me tell you that we need to set up a button for doing that action, okay? Because for now we don't have any button. So first of all, open your project setting, then inside the input manager, what we will do now is let's just simply right click on this jump button and click on duplicate array element, and let's name this button as leave, okay, and the positive button for this will be F, okay. So when we press the F button, the player will leave the hanging stat, okay. So we have a button leave now set up. Now what we can do, we can get back right here, and in here we will say if input dot get button, okay, and that button is the leave button, and also the player is not in action. And as you know, the player in action is on our player script. Okay, let me show you right here, player in action. So at the start we need to type player script dot player in action, okay. So if this is the case, then what we will do, we will play the jump from hang animation, okay. So in order to play it, what we will do, we will scroll down right here. After this set hand position, what we will do, we will create a enumerator by the name of jump from wall, okay. And in here what we will do, we will play the jump from wall animation. But the reason I have created this enumerator for this, okay, I can also simply call the jump from wall right here. But the reason I have created this enumerator is because first of all, we want to play the whole animation, okay, and then after that we want to give control back to the player, okay. If you call it directly up there in the if condition, then the player will still have control while playing the animation, okay, and we actually don't want that. So right here, first of all, we will say player script dot player hanging, okay. We will set this to false first of all. Then now let's call the animation. So we will say yield return player script dot to while, no, actually not that. On our player script, if you notice, we have a function right here which is perform action, and as you know, in this we pass the animation name and all the other parameters, okay. And as you know that for the jump from wall, we just need to assign the animation name and not the other things, okay, because it is not needed in this. So what we can do, we need to make this nullable, okay, which means that if the other things are left as it is, okay, left empty, then it's okay, okay. So for the CTP, or you can say compare target parameters, what we will do, we will simply equal this to null, okay. And for the required rotation, what we will do, we can't equal this to null, so we will equal this to a new quaternion, okay. And as you know, the other are also are already equals to false and 0, okay. So we don't need to change that, okay. So now just save this right here. Now we can now call the perform action, and in here we need to pass the animation name, which is jump from wall, okay. Then when the whole animation is played, then after that what we want to do, we want to set the player control to true. So we will say player script dot player control. Let's set this to true. Okay, so once you do that, now let's copy this function name, move up. In here we will say start coroutine, and let's pass the jump from wall, and at the end we will simply return, because now the player is no more on the climb point, so we don't need to do this other shimmy actions. Okay, after this, when the player is jumping from the wall, we need to reset the player required rotation. Okay, so on the player script, after this set control, we will create another function which will be by the name of reset required rotation, and in here, as you guessed it by the name, we will now reset it. So we will say required rotation equals to transform dot rotation. Now on our climbing controller, before we give control back to the player, we need to call this function now. But I have noticed right here that we have type player control. Actually, it is set control. Okay, this is the function name right here. So we need to type set control, and then we need to pass true to this as control. Okay, and now before setting it true, we need to now call the function which we created to reset the required rotations. We will say player script reset required rotation, and that is it. Now if we save this and get back to Unity, okay, so let me focus up on the player. Here it is, we have no errors. Let's now play it. Okay, so now if we jump, okay, let's jump another one. Now if we press the F button, as you can see, it is playing the falling down animation. Okay, let's test it again. Okay, so now if you press F, as you can see, it is playing the animation perfectly fine, and also the reset required rotation method, or you can say function, is also working. Okay, as you can see. Okay, let's jump even more further. Let's jump from here, press the F button. As you can see, the player jumps perfectly fine down below. Okay, so in this way you can add the jump down parkour action. Okay, or you can say jump from wall. As you can see, it looks really good. Okay, so with this done, now in the next video we will be adding our other parkour action, which is the, where is it, okay, this one, pressed hang to crouch. Okay, we will be actually, you can say we will be moving up to the rooftop when we are on this points. Okay, so let's do that in the next video. Hello guys and welcome back. So now in this video we will be adding the other action, which will be climbing from this point to this rooftop. Okay, for that we already have this animation which is pressed hang to crouch, as you can see. Okay, so what we need to do with this animation now is, first of all, in our animator, let's get back to the base layer and get inside the parkour animations. Okay, and in here let's now drag and drop it right here. Okay, and let's name this as climb to top. Okay, and Now if you notice this animation, in this animation the player only do this. Okay, the player just sits there. Okay, we need to make the player stand up when we climb to the top. Okay, so as you know that we already done something similar right here. Okay, from climbing up, then we play standing, and then we go back right there. Okay, as you can see right here, the player also just sits, and then we combine it with the standing animation, so it becomes a fully animation right here. So we will do the same with this one, climb to top. So what we're gonna do, we will make a transition from here to standing. Okay, and now if you play it, as you can see, it is looking good. Okay, now if we double click on it, okay, this is the animation. Make the root transform position y to feet. Okay, and let's change the offset of this so that it matches our other animations. Okay, so let's match it with this one, hanging idle. Okay, so if you notice, the hanging idle is a little bit down below, and this one is a little bit up there. Okay, as you can see, where is it? Okay, right here. Okay, so here is the hanging idle, and then this is this one. So what we need to do, we need to move this a little bit down below. So let me test out a value for this, and you can do it for your own as well, and then let's see how does it looks. Okay, so I have tested the values, and minus 0.22 is a good value for this pressed hang to crouch. Okay, as you can see, it is now matching with our hanging idle, as you can see. Okay, okay, so now once the value is matched, then as you know, we have already make a transition as well, and we name it as climb to top. So now let's add this animation as well. So as I told you in the previous video that we will be climbing up to the rooftop only for from this points. Okay, from these ones, because of course we can't climb to the top from this point. Okay, unless this window was open or anything like that. Okay, for now we just have these points, so from here we will just climb to the top right here. Okay, so as you know that on these points we have this climbing point script. Okay, so what we're gonna do, we will create a pool on this climbing point. Okay, and that pool will be, for example, by the name of mount point. Okay, and if it is true, then the player will know that yes, from this point I can climb to the top, or you can say mount to the top. Okay, something like that. So let's do it. Let's open up the script. It is actually already opened right here. So at the top we will say public bool. Let's name this as mount point. Let's make the M capital right here. Okay, mount point. Save the script, get back right here, and now if you notice we have this mount point right here. Okay, so now to all of these points we need to make this true, because from all of these points the player can climb to the top. Okay, so let's select these nines and set it to true. Then we need to select all of these, set it to true, and then the other side as well, like that. Okay, so once you do that, get back to your text editor, and now on the climbing controller right here we create a numerator from for the jump from wall. Now we need to create it for the other action. Okay, so we will say numerator, let's name this as climb to top. Okay, and in here first of all we will set the player hanging to false. So we will say player script dot player hanging, let's set it to false. Then let's call the animation right here. So we will say yielded run. Then we will say player script dot perform action. Let's call our animation, which is climb to top. Okay, make sure that you type your own animation name right here, whatever you name it. And then we will wait for 0.5 seconds. Okay, because this animation is a little bit long, so we don't want to give the control back to the player quickly. Okay, we want to wait for some time so that the player climb up perfectly fine. Okay, so we will say yield return new, wait for seconds, let's wait for 0.5 seconds. Then after this, what we will do now, we will say player script dot, we will do the same as we did for the jump from wall, so we will just gonna simply copy and paste that like this. Okay, so now it looks good. What we can do now is to scroll up. Okay, let me find the leaf. Okay, right here, leaf. And now after the if condition inside this else condition, okay, which is this one, right down below, we will add another if condition, and now we will say that if the current climb point, and then we will say dot mount point is true. Okay, and we will also say if the point direction dot y is equals to 1, which means that if the player is moving up, okay, then what we want to do, we want to call that enumerator type function which we created, climb to top. Okay, so let's call that right here. So we'll say start quarantine, climb to top. That's it. From here we will simply return. Okay, and let's move this ledge to ledge comment from there, cut it and paste it right here, because right here we perform the ledge to ledge jumping, or you can say the shimmy actions and all of that. Okay, and as you know that this is our climb to top code right here, and this is the leaf climb point code. Okay, so you can just comment that all thing. Okay, so it looks good and you guys can understand as well. Okay, and guys, right here instead of this point direction we need to type input direction dot y. Okay, I don't know why I type point direction. So now if you save the script, get back right here. Okay, now let's try testing the climb to top. Okay, so as you can see we can perform this one as well perfectly fine. Now let's test the other one. Okay, so now if we press the W key and the jump key, as you can see the player is climbing to the top. Don't worry, we didn't have colliders on the rooftop, so that's why the player fall down to the ground. Okay, so we need to add colliders right here. Okay, so this is the roof tile right here, and then okay, so this is the roof tile. Okay, so first of all let's select these three and add mesh collider to them. Then let's select this one. Okay, expand it, add mesh collider to them as well. And then right here, add mesh collider as well. And if you want, you can add mesh collider to this thing as well. Okay, and to this one as well, mesh collider, that's it. Okay, so now let's test it again. Let's see how does it looks now. Okay, so now we are right here. We can perform shimmy actions as well. Now if we perform the climb to top, as you can see, it is performing the climb to top. But for now, if you notice, the player is walking on this area. Okay, and we actually don't want that. And as you can see, the player falls down. So this is because, let me show you again. This is because we didn't have a layer on that area. Okay, so we need to provide layer to this top roof as well. And also, if you notice, when we perform this, the player feet gets inside the rooftop. Okay, we actually don't want that as well. So first of all, let's add a layer to this. So if we actually select the surface, as you can see, the layer surface is added to this. Okay, so in order to fix the first issue, let's select this whole thing, add surface layer. Yes, change children, select that one, expand it, add surface layer, then select this one and add surface layer. That is it. Now that issue will be fixed. Now the next one is the player feet were getting a little bit inside. Okay, the player was getting stuck, so we need to fix that. So in order to fix this, let's get back to the player script, and then we're gonna fix it right here. But before the fixing it, let me tell you the reason why that is happening. That is because we are not target matching when we are performing that action. Okay, so in order to fix it, you can either use target matching, but the simple way to solve this is to enable the character controller when we are performing that. Okay, so let's go ahead and do that. So we'll say public void, and let's create a method by the name of enable character controller, and this will take a bool which will be by the name of enabled. Okay, and in here we will say what we name our character controller. Let me check it. Okay, CC. So we will say character controller dot enabled. This will be equals to enabled bool, this one. Okay, so now if we get back right here, okay, so right here when we play the animation, we will say player script dot enable character controller, and let's pass true to it. Okay, that's it. Save the script, get back right here, and let's go ahead and now play the game. Okay, let's move up right here. Okay, so as you can see, it is working perfectly fine. Now we can shimmy action as well. Let's play it again. Now as you can see, the player feet are not getting stuck inside. Okay, the player feet are looking perfectly fine. Okay, if I show you again, let me actually pause the video and climb the player up to this point again. Okay, so now if we perform it again, you can notice it. Let me make the screen full. Okay, as you can see now, the player feet are not getting stuck and it is looking perfectly fine. Okay, and as you can see, when we added the surface layer, now the player can walk on this area as well, and also the player is not getting inside the building. Okay, so both of the issues are now fixed. Now the next thing which we will be doing is jumping back to the climb point. Okay, for from right here, as you can see, the player cannot actually climb back to the climb point. Okay, or you can say jump down to the climb point. Okay, so in the next video we will do that, and with that then our course will be completed. Okay, the climbing controller will be completed. Okay, still we need to add some post processing work. Okay, but that will be in the upcoming videos. Hello guys and welcome back. So now in this video we will be adding the drop to hang parkour action. So for example, if the player is standing right here on the roof, then from here when the player presses the button, we will move the player to this climb point. Okay, and in the hanging stat. So let me tell you how this will work. So for example, if this is our player, okay, and to this player the nearest point is this one. Okay, so what we want to do, when the player presses the button, we will make the player jump to the nearest climbing point. And you will be thinking that how we will detect the climbing points. Okay, we will be detecting that using raycast. Okay, so from the player from the player transform in the downward direction, we will be creating raycast, and then if that ray hits this climbing point, then we will know that right here we have a climbing point, and then the player will jump to it. Okay, to the nearest climbing point. So first of all, on miximo.com search for drop to free hang and simply download this animation. Okay, this will be the animation. So click on download without skin fpx for unity, click download, and once it is downloaded inside the jump down actions, drag and drop it. Okay, so let me find it now where it is. This is the animation. Change the rig to humanoid, copy from other avatar. Let's select our main mesh, click apply, and this is the animation. Let's drag and drop the player in there. Okay, so as you can see, this is the animation. Okay, for now the animation offset is a little bit upwards. Okay, so what we can do, we need to change the offset of this. So actually let me move it to the climbing animations folder. Okay, and when you move it there, this is the animation. Now let's test it with our hanging idle. For now, let's leave this as 2. Okay, we might need to change this value at the end of this video, but for now 2 will be good. Okay, now get back to the climbing animations. Let's drag and drop it in here. We will remove the spaces from the name. Okay, so it is now dropped to free hang. Then let's make a transition to the whoops let's make a transition to the hanging idle. Okay, so now if we play it, as you can see here, it is. For now, the animation has this thing. Okay, if you notice it, it is taking a little bit of time. So what we can do, if we open up this settings, let's change this to 0.5 and this to 0.1. Okay, let's select it again, and now if we play it, as you can see, it is looking good. Let me select the transition. Okay, now if you notice that now when the player transition to the next animation, the player moves down a little bit, as you can see. So what we need to do, we need to now move this animation even more down. Okay, so let's make this as 0.6. Click apply, let's select it again. I think 0.6 is a good value for this, as you can see. Okay, so you can add your own value to it, and when it looks good, then just leave that value as it is, and also make sure that you name it correctly. Okay, so now we are ready to type a script for it. Okay, but first let me tell you that, as I told you in the paint, that we will be creating a raycast, and by using that raycast we will be detecting the ledges, or you can say the climb points. So open up your environment checker script, and then after the check climbing, okay, after this we will create a function now for checking for the climb points. Okay, so we will say public void, let's name this as check drop climb point, and in here we will say drop hit. This will be equals to new raycast hit. Okay, then let's create a origin for our raycast. So we will say var, or you can say variable, equals origin equals to transform dot position. Okay, from the player position, as I told you, in the downward direction, so we will say vector3 dot down. Let's multiply that by 0.1f in order to give it some offset, and then we will say transform dot forward, multiply that by 2f. Okay, then we will say that if physics dot raycast, okay, let's cast away from the origin, then in the minus transform dot forward, then we need to store the information, so we will say out raycast hit. Okay, then we will give a length to this ray, which will be 3, and we want to detect any point that is on the climbing layer, so we will say climbing layer. Okay, so if we found anything, then that will be stored inside our drop hit, so we will say drop hit, and that will be equals to the hit. We will say return true, and right here we will return false. That is it. So now when we are now we are actually creating a raycast. Okay, now the next thing which we want to do is, as I told you, we will be getting the nearest climb point to the player. Okay, so we need to get the nearest climbing point. So for that, let's get back to the climbing controller, and after this climb to top, let's create a method. So first of all, we will say climbing point. Okay, then we need to, inside this method, we will get the nearest climbing point. So what we will do, we will name this as get nearest climbing point. Okay, this will take a transform. So let's name this as drop climb point, and then it will take a vector 3, which will be by the name of hit point, or let's just say, okay, we can just leave this as hit point. Okay, then in here we will create a variable by the name of points. This will be equals to ledge dot get component, actually components, then in children's, I forgot the children's spelling, it is CHILDREN actually. Okay, so children, we need to pass the climbing point. Okay, then what we will do, we will say climbing point, then nearest point, we will equal that to null. Then we will create a float by the name of nearest point direction. This will be equals to mathf dot infinity. Okay, then now we need to check all of the points, and then from all of that points we will get the nearest climbing point to the player. Okay, so for that we need to add a for each loop. Okay, so in here we will create a variable by the name of point in points. Okay, and let's create a float by the name of distance, and by using this we will measure the distance to the nearest climbing point. Okay, so we will say point dot transform dot position, and then we will say hit point. Okay, then we will say that if this distance is less than the nearest point distance. Okay, I've named this as direction, change this to distance, and this one as well right here. Okay, so if the distance is less than the nearest point distance, then it means that we have a nearest point, so we will equal the nearest point to the point. Okay, and then the nearest point distance will be equals to the distance, and then after the for each we will return that nearest point. Okay, right here guys, change this ledge to drop climb point actually. Okay, on the climbing controller, make sure that you change that. Then let's get back to the environment checker. Okay, right here what we need to do, we need to say out raycast hit, and let's pass right here the drop hit. Okay, we forgot to do that. And also, since this is returning true and false, so instead of the void we need to type bool. So now once you do this, now let's get back to the climbing controller. Okay, and right here where we jump to the climb point, now right here we will type a code in which the player can jump from the top to the climb point, okay, from the rooftop. So right here we will say if the leave button is pressed, okay, so we will say if input dot get button and the button name is leave. Make sure that you type your own button name which we created in our previous video. Then we will also say with this that if the player script dot player in action is false, okay, then what we will do, we will jump from rooftop to the climb point. Okay, so right here we will first of all say if the environment checker, let me see the reference name, okay, it is EC right here. Okay, so you will say if the environment checker dot check drop climb point, okay, this is the method which we created right here, okay, in which we create a raycast, okay, and by using that raycast we direct a climb point. Okay, so we will say that if we can deduct a climb point, okay, so right here we will say out raycast hit drop hit. Okay, so now in here what we want to do, we want to first of all get the nearest climb point. Okay, let me tell you again, if we press the leave button, or you can say the F button, and if the player is not in action, okay, then first of all using the raycast we check for a climb point. Okay, and when we find a climb point, okay, then from that climb point we will get the nearest point. Okay, so let's do that. So we will say current climb point equals to get nearest climbing point. Okay, then right here we will say drop hit dot transform, then we will say drop hit dot point. Okay, so when we get the nearest climbing point, after that we will set the control of the player false, so we will say player script dot set control, let's make this false, and after this right here we need to set the handoff set for this parkour action. Okay, so we will set the handoff set right here, but for now we didn't know that where the player hands are, so for now let's leave this as it is in a comment, and right down below let's play the animation. Okay, so we will say start coroutine, and as you know that we have created a method right here which is climb to ledge, in which we pass the animation name and everything. Okay, so right here we will say start coroutine, let's call that climb to ledge, and in here we will now call the animation name. So first of all let's check it out what is it is. Okay, so it is drop to free hang. Okay, make sure that you type your own animation name, so I will say drop to free hang. Right here the O is small, Okay, now after the animation name, we need to pass the transform of the current climb point. So we will say current climb point dot transform. Okay, and then after this, for the start and end time, we need to check the animation. Okay, if I show you right here, we need to compare start time and end time for our target matching. Okay, so we need to pass these two. So what I will do now is I will get back right here, click on this drop to free hang, and let's check the start and end time. Okay, so if I play the animation, okay, right here as you can see the players start rotating. So somewhere right here on this 40%, this will be our start time. Okay, 40.4, and let's check the end time. So the end time should be around 54. Okay, because right here the player hangs fully as you can see. Okay, so the start was around 40.4, so I will say 41. Let's just make it 41, and then the end time was around 54 percentage, so I will type 0.54. Okay, then after this we need to assign the player hand of set, but as I told you we don't know where the player hands are for now, so what we're gonna do for now, we will just pass zero values in it, or actually let's pass the values similar to our other values. Okay, for example the climb up. Okay, so let's just copy that from there, and where is it? Okay, right here. So right here, paste it. Okay, and then at the end, after this, let's pass these values. Okay, so in order to pass this, we need to just simply copy that from there and paste it right here. That's it. Okay, I think we are missing one bracket, so this is the first one. Okay, we need to remove this one from here and put it right here. That's it. Okay, so after passing the player hand of set, let's save the script, get back to Unity. Let's change into scene view. Okay, here it is. Now let's play the game and let's test it out. How does it looks? Okay, so let's jump to the first one. So now if you move up, and now let's run towards this point, and right here if you press the F button, as you can see the player can now climb back. As you can see, for now the transform was a little bit messed up. Okay, the player was in the air. If we test it out again, okay, from here, okay, if we press the F button, as you can see the player transform is a little bit messed up. Okay, but in the shimmy left and right it is fine, that's why it is looking good. But when we jump back to the point, the player was in the air, so we need to fix the transform issue. So guys, I have tested out my game and these in out and up down left right values works fine for me. Okay, I just changed this to 0. minus 0.44 and it works fine. Okay, if I now go ahead and test it out for you guys. Okay, so now if I jump right here, as you can see it looks good. Okay, if we test it out again on the other side, as you can see it looks good. Okay, so in this way you can change these values and find the perfect values for your own action. Okay, for your own parkour action. So now with this done, what I will do, I will simply end this video right here.